Hey guys, we have received multiple grievances about the sound quality of many of our previous videos from multiple viewers over a long period of time. We paid serious attention and as a solution, we are republishing all the episodes from our Linux for VLSI and Bash shell scripting series all together in this marathon episode by digitally remastering the audio. In this marathon episode, you will learn the need of Linux skills for a fresher in the VLSI industry. You will learn the basic theories and necessary hands-on practical of Linux commands in detail. Once you are familiar with all the Linux commands, we will move to the shell scripting in the later part of this marathon. Once you complete the marathon, you will be professionally trained in Linux and shell scripting and will be ready for the VLSI industry. So stay tuned, stay focused. Hey guys, welcome to the first episode of Linux Basics for VLSI. In a recent poll, you folks have voted and conveyed me that 22% of you are not using the Linux at all. However, in the VLSI domain, the Linux knowledge is a must. In this series, we will cover the basics of the Linux command line operations. Those are frequently used in day-to-day work in VLSI. In today's episode, we will cover the installation of Ubuntu Linux in your existing Windows operating system without any need of separate partition or dual boot architecture. We will cover two hands-on methods of installation. First, we will use Windows App Store to install the command line terminal of Ubuntu. Then, in the second method, we will install the fully functional Ubuntu distribution through VirtualBox. So, sit tight, stay tuned, and stay focused. Enjoy the learning experience. Hey folks, welcome back. We are in our Windows operating system and now we are going to install the Ubuntu built-in app for the Windows operating system. So first, let me go to Control Panel. Here I have to make some changes. So after I go to Control Panel, I go to Program and then I go to Programs and Features. So here you can see this particular option, Turn Windows Feature On or Off. You have to go there. So here we are turning on this Windows subsystem for Linux. You can see it, I have kept it highlighted, Windows subsystem for Linux. So it says restart now. So I have to reboot my PC. Hence, I'll come back after the restart. So folks, we are back after the reboot and now let me go to the App Store. So here you can see the icon. Also, we can go from here to the Windows App Store that is named as Microsoft Store. Let me click it. So next what I do, we search for Linux and here there are multiple Linux versions you can see here. Kali is a Ubuntu 18.4 and I think among them I find this one is the latest, Ubuntu 20.04 LTS. So I will go ahead and click it. Before installing, if you want to check, you can go ahead. You can check your operating system and the hardware requirements, the system requirements. I think my machine is okay because I have a dual boot already and I'm running Linux already. So I'm not going to verify it. For your case, you can check whether anything is needed more for you. However, once you have the Windows 10 installed, I think your system is ready to install this particular Ubuntu app. So one more thing here, as it written that Ubuntu 20.04 LTS on Windows allows you to use Ubuntu terminal and run Ubuntu command line utilities, bash, SSH, git, apt and many more. So this will give you the basic command prompt, that is Linux shell. That should be your expectation, that after installation you will get only the shell, and for this particular course you need only the shell. I think that is enough. So let me click on get. So you can see folks, here it started downloading by itself. Let me wait till the download finish. So folks, you can see that it gave a message that Ubuntu 20.04 LTS just got installed. So this particular utility we have installed, and here we can pin it to start. So I have kept this pinned inside start. So let me close it. Now since I have pinned it to start menu, so I can see here the Ubuntu 20.04 LTS. Here you can see I'm highlighting it. I'm going to click on it. Here you can see it's keeping a message installing. This may take a few minutes. So we have to wait for the Linux prompt to get configured by the Windows operating system. Let us wait for some time. So folks, you can see here this one has come and it is saying enter new Unix username. In Linux system, generally you log in with a username and password, and obviously this is not your Windows ID and password to which you are logging to the Windows. Okay, this is separate. Let me give a name here. So I have given the username. Now it is asking for the password. It is asking to reconfirm the password which I have just typed. So you can see password updated successfully, installation successful. To run as an administrator in Ubuntu as a root, you have to use the sudo command, and all this thing, documentation, man page, everything is there given. And here to check for new updates, done sudo apt update. And here you can see that our shell has come here. So I have given the first command, echo command. Echo is similar to the print command in Linux shell. Which shell we are currently in, we can check with the $shell command. And which user ID we are logged in with, we can check with this command. So now we can see we are using the bash shell and this is our username. Our installation is complete. Here command. Now what I'll do, I'll close this one. Again I will open this shell. Again I go to this particular and I click it. So you can say my Ubuntu shell is ready. Here I can perform all the Linux commands. This is different from the Windows command prompt. I am keeping side by side. So this is our Linux shell. This is the command line prompt for our Ubuntu system. You can see by the icon. And this is our Windows command prompt, that is giving as our Windows command line feature. So don't confuse with them. this is what we are not using, so we are closing it. What we are using is this one, that is the Linux shell inside the Windows. So I'll close it. I think folks, we are done for this particular thing, so let's close it. Okay folks, and in the second part, what we'll do, we will install a VirtualBox, and inside that we will install the full Ubuntu operating system. Let's begin. I type VirtualBox. So folks, you can see that here the definition comes: Oracle VM VirtualBox is a free and open source hosted for x86 visualization, and VirtualBox may be installed in Windows, Mac and Linux and Solaris. So what this does is it gives a virtual environment where we can install different operating system while staying inside a already installed operating system. So you need not to go anywhere, or you need not to do any partition. You can install any other operating system apart from the operating system that you are currently using. And in this case, right now we are in Windows, we are going to install Linux, and we do not need any partition or anything. And in this manner, what will happen, that this Ubuntu will install and can be used like just any other software. Let me open the free download manager. So we have reached to virtualbox.org. So we can go to download VirtualBox 6.1 either from clicking here, or we can go to this download. So the link in the left pane, it worked, and after clicking this download, we have reached to the download page. So you can see here you will find the VirtualBox binaries and the source code. Here you can see that we are already on Windows. It is also available for other operating systems. So in case you are using the Mac OS, so you can go for OS X for that one. If you are using Solaris or Linux, you can go there. However, our goal is to install Linux within Windows, so we will pick up the Windows binary. So let me copy the link address, and a faster download I will do it with the download manager. Here you can see it will download in the download folder, and we start it. Generally, a download manager downs the file than a web browser, and if it is broken or interrupted, it can be resumed. So that is the beauty of the download manager. I'm using free download manager, and I think you can see you just thought there is a network error, and then automatically free download manager reinitiated the download, and it has completed the download. We can see here it is, you can see that it has completed the download. So let me close it, and let me also close this one. We do not need any more. So I'll provide this link in the description of the video so that you can directly go here. So close it. So here is our download folder, and you can see this installer has come and downloaded in this particular folder, and let me run it as administrator. So folks, you can see after I have launched the installer, it has come, and I will proceed with the install. So what I am doing, I am installing everything in the hard drive here, and in this path, this particular path, you can see here, this will be installed. Fine, everything is fine. It's okay. You can see I have proceeded with the installation steps. It is going and installing the components. So it has done finishing the installation, and I will just, you can see if I click it finish and it launches automatically. I will not launch it automatically. Let it finish. And here you can see I have double clicked the icon and I'm waiting for it to launch. Also you can go here and from here you can also launch it. So folks, you can see this window of VirtualBox has come. We have installed it successfully and we have launched. I'll stop here. The next section, we are going to install Linux on VirtualBox. So let me close it. So folks, in this particular section, we will be downloading the Ubuntu ISO from Ubuntu website. So we are downloading the same operating system ISO here as we have done the Windows App Store. We have written download Ubuntu's 20.04 LTS. So we are staying on the same operating system, although there is a up-to-date version available. In your case, if you want, you can install the latest up-to-date version, Ubuntu 21.04. This is 21.04. However, we are installing Ubuntu 20.04 and there is a subversion, that is LTS. The LTS means the long-term support. So once you install an LTS version, the system updates and all those things are, I think, for 3 to 5 years, somewhere in the timeline. And within that timeline, you do not have to reinstall any kind of further versions. So automatically everything will be installed as the update. So this is the theme of the LTS version of Ubuntu. Let me turn on the free download manager. Let me launch it. Go here. Let me download. So let me copy this link here, which has come of the ISO, and add it to the. Okay, so I think this particular URL has a problem. So let me hit back. Because the last link was a bad link, and then what we did, we picked up the second option that came in the search. We copy the link address. And he says work. So you can see releases.ubuntu.com/20.04. This link worked perfectly, and here it is also not showing that particular error. So we are going to download this one. So I'm just going to reiterate, the first one link, the download option did not work. So we moved on to the next one, that is not the ubuntu.com, that is the releases.ubuntu.com. This link is opened here, and here we can go for this particular link, which I copied and added in the free download manager, and it is downloading. So you can see the downloads manager has a much more higher download speed than your regular browser. So it is downloading, I think, in Mbps speed. So let it finish. Let the download finish and then we'll talk again. So folks, you can see that the download has finished, and this section is complete. We'll move to the next section where we will install this ISO inside the VirtualBox. So folks, we are on the next section. In this section, we will install the Ubuntu ISO image as a full operating system inside the VirtualBox. let me start the VirtualBox. One desktop link is here, and another way you can go up this point and click it to run the VirtualBox. So once you see this VirtualBox is here, you can go ahead and here you click New. Here I am typing Ubuntu. So you can see that I have written that Ubuntu 20.04 and the subversions I have not included, although they are there in the ISO file name. Mostly it is Ubuntu 20.04 LTS, and rest of the options are automatically selected inside the VirtualBox. The type is Linux. Ubuntu is a Linux operating system, and at present we can only download the 64-bit version. And this machine, whatever I am using, is a 64-bit machine. So you can see that everything is pre-selected once you type this thing. And pick the memory size. This is RAM size. So I have 8 GB RAM in my machine. However, I can select somewhere in between. So it takes something more. Okay, no, this is higher. So let me go up to P only. Okay, you can see up to this much I have picked up and I have stayed within the green marker. Okay, and let me go to the next. So here I leave everything as is. The recommended size is 10 GB. So, and here I leave it as is VDI. This option is VDI, VirtualBox Disk Image. Next, there is a dynamical allocation. We say it can add or subtract the hard disk size based on the Ubuntu requirement. So let it be there in the dynamical allocation. So here you can see here this will be installed. So you can see now I have made it bigger. So you can see everything is configured for installation of Ubuntu operating system inside the VirtualBox. I just go to settings here and you can see it is as we provided. I'll make one small change here. Change it to bidirectional, so that any copy paste operation in vice versa from Windows to Linux and Linux to Windows can happen. That's what these options do. And because the Linux operating system is inside the VirtualBox layer, so this all copy paste action will cross the VirtualBox boundary, and to operating system we can exchange copy paste operation. So here there are multiple CPUs. I am just picking one. I think everything is okay here, and system acceleration page, the hardware for virtualization is enabling the acceleration section of the system page, although it is not supported by the host system. It should be visible. I understand what happened here. Let me cancel this and let me go to the control panel. Let me go to the control panel here. Programs and features. Let me go. Turn on this one. Turn on features. Here there is a virtual. So you can see here the virtual machine platform. So this must be enabled from the control panel. Otherwise, we are seeing that particular error, right? So let me enable it. Okay, it is asking for a restart. So let me exit from the VirtualBox first, and I'll be coming back after the restart. So folks, we are back after the restart. So let me turn on the VirtualBox. So you can see that here we have configuration inside the VirtualBox is there. where we are going to install the Ubuntu. In the settings, we have done the bidirectional so that we can do the copy pasting in vice versa operation, and you can see here everything is okay now. Earlier the error was coming, has been fixed by the setting change that we have done in the control panel. So you can see here our Ubuntu operating system is ready to install in the virtual box, and everything is okay and ready. So this is the by default setting, how many processor will be there, and we can change it. I have just taken 2 CPUs and say okay. Again we go back to settings, is these systems, and I think it's taken okay. So let us go to the storage, and here once we go here we can see empty, and here we will use the ISO file. Once I click here, there is a drop down, so I choose a disk file. So let me navigate to the downloads folder where we have downloaded the Ubuntu ISO file. You can see it is here, Ubuntu 20.04, and we have the subversions, and it's a 64-bit ISO, and we pick it. Here we click it and pick it. Done. Here everything is done. Let other things be there, and we hit OK. So here it is selected, and let me do the start. So you can see here the Ubuntu installation has started inside this particular window. So this is very much typically similar when you have a hard disk partition, and there if you are installing the Ubuntu system, you will go through the same steps. In my machine, I have a dual boot, that is Windows 10 and Ubuntu. So when I installed these things, I went through all the steps. In case you have only one particular operating system, that is Windows 10, then you will be using this virtual box to install the Ubuntu operating system inside Windows system. So it has checked the ISO file thoroughly, and it has not found any error, so it is moving forward. Here there are two options: try Ubuntu, install Ubuntu. So we will go for the install Ubuntu, and we are using the English language. So try Ubuntu gives you a live CD version that everything loaded in the RAM, and then you can play it. If you have a bootable Linux, you can do it. You don't have to install the OS in the hard disk, and from pen drive you can run it as a live operating system. Everything happens on RAM, and what is the disadvantage? That you cannot save anything. You can try everything, but you cannot save anything. Okay, so here we are going for the installation, and again both case English is selected. So I'll skip this option as I want to do the minimalistic installation right now. In your case, you may check these two options. However, I am going for the minimalistic install, so not this one. I am saying the normal installation, but not the additional update while installing Ubuntu. That will take more time and eat up my internet bandwidth. So what I do, I uncheck this option. In your case, you can pick up these options. So you can see here that it is saying this computer currently has detected no operating systems. Okay, no operating system inside this particular virtual box. And here when you do the operation, nothing is going to happen or nothing is going to harm to your actual Windows installation. So you can go ahead with this one. This is whatever happening inside this virtual box. So erase this, can install Ubuntu. So we continue. And another thing, folks, as I have mentioned, that you will go through the very same steps if you want to install Ubuntu in your desktop or laptop when you have a separate partition. So here I am in India, so India is selected. And let me type my username. And let me choose my password. So it says spare password. Let me continue. So you can see the installation process is progressing, and you can see here this progress bar is doing whatever happening inside is saying here, the copying files and etc. So folks, in this way, without creating a dual boot, you can install a fully featured operating system inside your Windows installation. So folks, the installation inside the virtual box is complete, and restart now. So this is not going to restart your Windows. This is going to restart just the operating system, that is Ubuntu, inside virtual box. So it is asking, please remove the installation medium. Generally, for actual installation, you use a pen drive nowadays. At this step, you pull out your pen drive. Okay, you cannot eject it safely or something like that during the boot. You just have to pull it out from the USB socket. So, however, in this case, we are not using any USB installer. In this case, we will just press enter. So you can see the Ubuntu has taken a reboot and the Ubuntu boot up sequence has started. So folks, you can see here that I have given my username, and once I click in my username, I have to enter my password. Just installed and successfully logged in to the newly installed Ubuntu system inside the virtual box. Let me skip. Next. Next. So this is location service. You can turn it on. Done. So here is your Ubuntu operating system is ready. So folks, our installation is complete, and we are going to the virtual box, and here how we start it. So this way we start the Ubuntu Linux. The boot up sequence is ongoing. And this is our login page has come. Here we have to log in using our password. ID is already displayed. So here if you see these things we do not need, so I'll remove it and rather I will pick up the terminal and right click and I'll click to add to favorites. I hit escape, again escape, again escape. So terminal has come here, and for any further practice of the commands or codes, you can go here and open this, start typing. Like this is the command to check the username, present working directory, and ls. You can see all the files and folders are here. So your terminal is there. And we are currently using the bash shell. So I think we are done with the installation of Ubuntu operating system inside the VirtualBox, and this way you can start using it and learn the commands. Hey guys, welcome to the second episode of Linux Basics for VLSI. In this series, we are covering Linux fundamentals and features that are frequently used in day-to-day work in VLSI. In today's episode, we will make you familiar with Linux know-how, LSF grid engine, BNC viewer, and SSH clients, which are used in day-to-day work in the VLSI industry. We will also make yourself familiar with commercial and non-commercial Linux distributions out there. So sit tight and enjoy the learning experience. Hey folks, welcome back to the computer screen. In today's episode, we will be going to discuss these points. Software categories, their fundamental. Commercial software categories. What is Linux? Famous Linux distributions and logos. Linux desktop environments, various look and feels. Why you must know Linux for VLSI, VNC server and viewer. Also, we will look into SSH clients. Layered connectivity used to Linux in VLSI. So folks, this is the menu for today, and without any further delay, let's begin. Software categories, fundamental. First of all, when we have any computers, we obviously have to have a software inside it. Now, broadly, the computer softwares can be classified into two categories. The first one is system software or operating system. Mostly you are familiar with Windows, that is a system software or operating system. The next one is application software or app. So application software is like Office. Let's look at some of the examples. System software examples are Windows, Mac and Linux. Also Solaris. So these are system softwares. These system softwares take care of the booting of the computer system. And the application software such as Office, Notepad, Paint, all of these you are familiar with, and many others. These are general softwares, that is application softwares. These are used for their specific purposes. Now once the machine has booted up and ready, that time we launch the application softwares. Now you understand fundamental difference of the two kind of softwares. Now, commercial software category. We have just talked about two broader category of the softwares. Any one of them can be recategorized in closed source software, which has subdivision of freeware, shareware, and proprietary software. Now, what is a freeware? Freeware is a software where you don't have to pay any license fees. You can go ahead, download it, install it, and start using it. Shareware is a software where you also do not have to pay the license fee. Condition is you will get advertisements in the software once you are connected to the internet. And here, if you want to remove the advertisements, you have to purchase the license. The next category is proprietary software, which is neither like freeware nor like shareware. For this category, you have to purchase the license. The another category is the open source software, where it is similar to freeware. However, you have the access to the source code, where in the closed source softwares, you cannot see the software code. Whereas in open source software, you can access the source code from some repositories and you can make your own fork of that particular software if you are a programmer. Now, our proprietary operating system is Windows. Generally, we use it from the schools or college days. And the Linux comes under the open source software. Now, why open source? We'll come to know about the various distributions. Linux, when started, it was only a single particular flavor or two particular flavor. From there, it has branched out in many flavors. These flavors are termed as distributions or distros. So, we're done with this particular slide. Let's move on. What is Linux? That is a good question. Now, let us see the answer. Linux is a family of open source Unix-like operating system first released on September 17, 1991 by Linus Torvalds. This operating system core is called the Linux kernel. So from the name of the creator, name the operating system as Linux. So the core is termed as kernel. Better you pin into your mind. Later on, you will see what is a kernel and how the architecture is there. Typically, have the GNE utilities come in several distributions to serve the different purposes. So, we are talking here about the various distributions. I just talk about some of them later on. We'll see some logos in upcoming slides. So, wait for that time. Non-commercial Linux distributions are like Debian, Fedora, and Ubuntu. So, these are very much famous. At least, the Fedora and the Ubuntu are very much famous. There are a lot of other famous distributions also. So, we'll show them. Commercial Linux distributions include enterprise distribution of Red Hat and SUSE. So these two are most used Linux operating systems in VLSI because when they are used in the companies, they have to use a purchased copy so that they get a proper support in case of there is some issue in the operating system. So here we are done. Let's go to the next point. CentOS is an open source version of the Red Hat. It came to the end of life in December 2020. Yes, last December only. If I have made the video before the December 2020, then I could have mentioned the CentOS is a very good alternative of the Red Hat because it is built on the Red Hat codebase. Now, after the end of life, it will continue as CentOS Stream or RHL Beta. Whereas the Rocky Linux has emerged as a successor of the CentOS, a complete rebirth. It's a fork of the CentOS, and people who are using the CentOS earlier now moving to the Rocky Linux. Now, why I mention about the CentOS and then Rocky Linux? In many of the companies, instead of Red Hat Enterprise, many of the small companies, they use the CentOS earlier than December 2020. Now, I think they are migrating to the Rocky Linux. So this is just for your information purpose. I have kept these points. Famous Linux distributions and logos. Now, I'll go through in this slide some of the famous Linux logos, their names, so that you can have a good idea of what to look for in case you are having a installation. Obviously, you cannot have the enterprise distributions because they are priced. However, you can go for the free ones. Now, let's start. First one is Ubuntu. Already in last video, I have shown the installation of Ubuntu to the VirtualBox. Next comes the Debian. Actually, Debian is the father of Ubuntu. So, Ubuntu is a fork of the main Debian distributions. Next is the Fedora. Fedora is also based on the Red Hat code base. Next is the Linux Mint. Next is the Arch Linux. We have the SUSE. And so, we also have the Red Hat Linux. Also, we have the Garuda Linux. Now, I will ask you a question to find out in the internet why the Garuda is getting popular in the Indian subcontinent. Please go ahead, look for the answer and put your answers in the comments. Rocky Linux is just I mentioned, which is a rebirth of the CentOS. We also have the Gentoo Linux, we have the Puppy Linux, and we have the Kali Linux. Kali Linux is used for the ethical hacking purpose. So folks, these are the few very famous Linux distributions and their logos. So we are done with this particular slide. Let's move on. Linux desktop environments look and feel. Now, when we use the Linux in GUI mode, we can have three different kind of desktops. First one, yes, you have seen this particular desktop in Ubuntu installation. and it is called Genome. This particular desktop environment is called Genome. The next one here, it is called XFCE. So this is another kind of desktop environment. You can see the change, look and feel is very much different. Obviously, these things are very much distribution specific. Some distribution use Genome, some distribution use XFCE. The third one is called the KDE Plasma. This is, you can see from the very beginning, it is having a menu bar and all, which kind of Windows look alike. KDE can be found in the Ubuntu installation. So these three major desktops can be found. Okay, so if you are logging into a particular Linux based machine, there you can come across any of these three desktop environments. So you will not be shocked that, okay, I learned some particular desktop environment and now it looks different. No, there are several distributions. So you are now familiar with most of them. We are done with this particular slide. Let's move on. Why you must know Linux or the VLSI? First, at learning stage, many free and open source VLSI tools are available in Linux only. In this channel, you can see that I have already created a series on STA, where I have used the open source software called OpenTimer. So this is, you can install in Linux only and in Mac, but not in Windows. So such many softwares are there out there in the open source domain, which you can install and try and learn. So that can be your basic motivation of learning the Linux. However, wait for the next points. All industry-level VLSI tools installs and run on either Red Hat or SUSE distribution. That means beyond this channel, if you try to enter into the VLSI industry, there you have to face either Red Hat or SUSE. This is a must. So learning basics Linux commands is the first coursework of any fresher entering into the VLSI industry. So when you get on board, maybe you are the intern or maybe you are an employee. In that case, the first coursework that you have to do, that is Linux. Because in VLSI, everything at the end runs on Linux. Most of the time, you have to log into a remote server through the VNC viewer, which connects from Windows, that is starts from Windows and end up in Linux server. So your Linux knowledge is must. There are a few more points. Let's see them. Load sharing facility, LSF by IBM or Univer Grade Engine, that is UG, both works through Linux. These load sharing facility and UG, that is LSF and UG, reserve your slot for the VLSI tool execution with mentioned specific resources including RAM, CPU, RHEL, SUSE, GUI, CLI. Let's move on to the next point. Because every VLSI tool has a separate system requirement to run. Yes, this is a very important point because in VLSI, each tool will have its CPU requirement, separate RAM requirement, maybe some other hardware requirements like GPU. We have to specify through the command line resource specification for either of the two, that is LSF or Grid Engine. To use any GUI, that is graphical user interface, you have to launch it from the Linux command line prompt. You will say that I will use a Linux GUI. However, to launch the GUI, you have to first go into the Linux command line and then you have to launch it. So this GUI is not only the Linux operating system, this GUI could be GUI VLSI tool also. Next, many batch processing of the VLSI tools can be easily done by Linux scripts, that is PERL scripts. So for this already I have a tutorial series in this channel, bash scripting for VLSI. You can go ahead and watch that particular series. These bash scripting makes life easier for batch processing, automation, everything. So the shell scripting, that is bash scripting, is a bit advanced. However, to use that, you must have the basic Linux command skills. That is another motivation for you to learn the Linux. Next, you have to use a remote disk base. Sometimes you have to mount it also. This mounting concept is specific to the Linux only. You don't have this mounting concept in Windows. The reason is the base machine generally don't contain much space in your home directory. So you have to use a remote machine always and a remote disk base. And also the VLSI tool will not run in your Linux base machine. It has to run through the LSF or Grid Engine as mentioned in the first point of this page. So as summed up, these are all really for you to learn Linux. If you are enough motivated to learn the Linux, let's move on to the next slide. VNC server and viewer as used in the VLSI. This is a very good concept. VNC server and the viewer are the two important things used in the industry. The remote machine to which you want to log in will run a VNC server from where you will get a server address as you can see in this picture, and it will be a Linux machine definitely. Whereas your machine, that is on which you are working, sitting in your desktop, mostly it is a Windows machine from which you will launch the VNC viewer. However, the VNC viewer is also available for Linux distributions too. So this is the general architecture in any of the companies. Your base machine on which you are working, physical computer, that is Windows based, from which you launch a VNC viewer and connect to the remote machine which is running the VNC server, which is on Linux. So at the end machine, you have to use the Linux commands or Linux features or both. So this is another motivation for you to learn the Linux. Now let's move on to the next slide. SSH terminal emulators and managers. Now, before showing you anything here, I would like to briefly say that why this is important. To VNC viewer, you can connect to a remote machine, work there. However, to transfer file in between your remote machine and your local machine, whether it could be a Linux-based machine and the remote Linux machine, or the remote disk area where you are working and the base area, or your base Windows system and your remote Linux machine. Any of the combinations, you can use a SSH terminal emulator and manager. The terminal emulator will give you a Linux terminal, and the managers will have the facility to secure file transfer. A few of the popular SSH terminal emulator and managers are Qt, MovaXterm, Visual Studio Code, Bitwise, Terminus, OpenSSH, WinSCP, Xmanager, and Xshell. So these are few popular and widely used SSH terminal emulator and managers. So this will help you to remote login to terminal and or to transfer file in between your local and the remote machine. So you can explore by your own about the softwares. Many of them you can install in your Windows. We are done with this particular slide. Let's move on. What is LSS or grid engine? Here at the top left, you can see the IBM LSS logo, and right hand side, you can see the grid engine logo. Here comes our first point. LSS stands for Load Sharing Facility, which is a workload management system for job scheduling and distribution across variety of physical computers with high performance configuration. In VLSI industry, at the end, we use very high configuration machines to run the VLSI tools. It may be high on CPU, it may be high on RAM, or both. And these machines will run on Red Hat, SUSE, either of the two. Or you can have both Red Hat and SUSE inside your company. However, there will be an array. Say if your company has 100 employees, they cannot give you 100 Red Hat machine or 100 SUSE machine. That will be very costly. And to circumvent the cost, there is an array of 20 machines. So it's a rough number I'm saying. So those 10 maybe are Red Hat, 10 maybe SUSE. So once you book a slot through the LSS, you can get one of the machines. Your job can be executed there, and you can then free the resources. This is the concept. Okay, let's see the bullets below. UG stands for the Univa Grid Engine, which is forked from Sun Grid Engine. It has similar functionality in nature as LSS. The VLSI software cannot be run interactively on a machine because they require too much CPU, time, memory, or other system resources. Nowadays, you also need a GPU. Many of the VLSI softwares are using GPUs. Hence, these must run in batch, that is batch job, to LSS or UG. LSS or UG takes care of the batch management, time to launch, job queue management. So everything, top to bottom. There are 20 machines and 100 employees. So each of the employees in a time sequence, they will fire job for the machines. So there will be queues. Say each one has fired one job. So there will be 100 jobs, but 20 machines. This LSS or UG will make sure that 100 jobs must start and finish properly in the array. It will pick up the proper machine and then execute the job and finish it. Okay. Based on the job specification, or LSF or UG will start allocating machine, start execution of the job, and where there is enough system resources available for the jobs to complete. So not only it takes care of the beginning and ending, however, it also checks that the proper system resources are allocated. If that system resource is not free, the job will wait in the queue. Once such particular system resource is free, the job will run. Once the job is completed, the running program exits the queue and frees up the physical machine. So this free machine is now available for the next job. So the slot is free and open for the next execution. So there may be the next request maybe from the same employee, or it may be from the different employee. Okay. So in this way, the smart and efficient management of the resources is done through the LSS or grid engine. Layered connectivity to Linux in VLSI. This is a very important slide. So sit tight and watch it carefully. This is your Windows-based machine where you physically use the keyboard, mouse, etc. and you have the monitors. It is generally Windows, in which you will launch the VNC viewer. I have already exemplified what is a VNC viewer. Now, this VLC viewer takes you to the Linux base machine, that is remote machine, but that is base machine. This base machine will have limitation that your home directory will not contain much space and you cannot run high-end VLSI tools here because this is a very smaller configuration machine. Now, from this base machine, you will launch the LSA for UG commands, which will pull up a LSA for UG machine. And the LSS grid or the UG grid will provide you the high-end Linux machine where the job will run. So, in this layered way, the VLSI tool is run in the industry. Now, let me bring my mouse. Generally, once you have the Windows machine on and you have the VNC turned on and you have gone to this stage. So, you will stay at this stage only and you will move to and fro here and here in these 3 layers. Okay, so this is the general practice. And once you log out, you may log out from this and you come back to your Windows. Again, once you logged in VNC, first you go there and then you go to the Linux base machine. And from there you fire the LSA for UG jobs, which will run at the high-end Linux machines. So this is the architecture, how the Linux machines are used in VLSI. So folks, we are done with this particular guide. Let's move on. Hey guys, welcome to the 3rd episode of Linux Basics for VLSI. In this series, we are covering Linux fundamentals and features that are frequently used in VLSI. Today's episode will make you familiar with Linux kernel, various Linux shells, Linux file tree architecture, mounting and unmounting concept, repository concept, and software installation basics. So, sit tight and enjoy the learning experience. Episode, we are going to discuss Linux architecture inside out. What is Linux kernel and shell? Some famous shells in the Linux. TCSH, the favorite shell for VLSI engineers. Repositories and software installation in Linux. File structure comparison, Windows versus Linux. File tree structure in Linux. And finally, we'll be discussing what is mounting concept in Linux. So, this is the menu for today. Without any further delay, let's begin. Linux architecture, inside out. You already have seen this picture in the thumbnail. So, let us start how the Linux works from inside out. If we think the inside thing, first, whatever physical thing is there, it is the hardware on which the Linux kernel is wrapped around. So, the layer of Linux that is directly interacting with the hardware is kernel. Now, this kernel has multiple processes, that is multiple running processes for various things. We'll come later. Multiple devices are connected. Their firmware are also part of the kernel. And many external firmware which are installed by the user also stay at the layer of the kernel. Next, the file system. In Windows, you might have a concept of FAT, that is file allocation table. On latest, you have a NTFS. So Linux also, there is a file system called ext2. Obviously, don't worry, at later point, we'll cover these things in this particular episode only. So that file system is taken care at the kernel level. Multiple device drivers also stay at the level of the kernel. So kernel also controls the driver and hence controls the external devices through the device drivers. Above kernel in Linux, we have the shell. So the shell is the word that you might hear or you hear it more than anything because you hear the shell scripting, we have tickle shell, we have TCSH shell, we have bash shell, anything that you hear. The shell word you hear many times. Above the kernel in Linux, the layer that wraps around the kernel is shell. It is few familiar names like is TCL-Script, bash, CSH, TCSH, KSH. KSH is the corn shell. TSH and TCSH are C shell and tenise C shell. Bash is born again shell and TCL-Script you already know. This is the concept of the shell. Multiple shell names are popular and all popular names I have tried to keep in the same picture. The wrapper above the shell is called apps, that is software or application software. What we generally see in this layer is office software like LibreOffice or OpenOffice. Then we have NEdit is a text editor. Then we use the ls command to see the files. We use the gvim as a text editor. We use the Firefox for internet browsing. We use GCC for C compiler or G++ compiler. We use VLC to watch video or listen to music. We use gedit for text editor. So all these applications are wrapped over the shell. Let me bring my mouse here. Any particular code execution or instruction that is going from the apps layer, it will cross the shell and then it will cross the kernel and it has to access the hardware. It will access the hardware and then again control comes back to the apps layer. So this way, to and fro, the thing works. This is the Linux architecture inside out. I have explained you the various layers, that is hardware, above that kernel, above that shell, and above that all the application software, that is apps. We are done with this particular slide. Let us move on to the next slide. Now we'll go deeper in the subject. What is kernel? The Linux kernel is the main component of a Linux operating system and is the core interface between a computer's hardware and its processes. From the picture, you already know that the kernel wraps around the hardware. Any hardware level communication, that is communication in the machine language, machine readable binaries, that are done by the kernel. It communicates between the two and manages resources as efficiently as possible. You know, right? Any computer nowadays is a multitasking system. One particular OS might be running multiple softwares at the same time, whether it is your system software or it is a user, that is application software. Anything and everything that has to be managed properly, and that management is done by the kernel. The kernel looks after 4 main things. First, memory management. Keep track how much memory is used to store what and where. This is a very good thing because we are working on a particular application software, and that software we are saving some files. So at first the files are at RAM and then they will go to the hard disk. At hard disk, they will be stored as per the file system and the file tree structure. So all these things, the memory management is done by the kernel. Process management. Determine which process can use the central processing unit, that is CPU, when and for how long. So we have multiple cores for our CPU nowadays. The process management, any process may take 1 core, may take 2 core, or maybe all the core. So this CPU management and the core management, all these things are taken care by the Linux kernel. Device drivers as mediator or interpreter between the hardware and the processes. So all the devices, say, right now I am speaking through a USB microphone and that microphone needs a driver to run. So that particular driver is taken care by the kernel. System calls and security. Receive request from the service from the processes. There are multiple background system process run that generally as a end user we do not see them. But if we try to list out all these processes, we can see what processor are running. So there is a command called top. If we run the command, we can see what all processes are ongoing. All these system calls are well taken care by the Linux kernel. In a nutshell, 4 things: memory management, process management, device driver management, and system calls and security. All these things are tightly managed and timely managed by the Linux kernel. We are done with this particular slide, so let's move on. What is the Linux shell? Well, this particular word shell you hear every now and then. This word you do not hear for the Windows. This word you hear for only the Linux system, because the shell concept, the name shell, belongs only to the Linux and the Unix systems. So this is a graphical representation where we access the shell. Generally here it is a terminal, you can see, and in this terminal we access the shell. Although this terminal is not the shell. At the command line, whatever command we type, those command goes to shell, and those commands also belong to the shell. In 80s and early 90s, every computer was command line based. Nowadays, you might not see computers which run entirely in the command line, but maybe 20 years ago or 25 years ago, that was the picture. That time, mostly the Linux operating system used to boot on the command line, and once it boot up, only the command line is with you. I myself learned in that fashion. Nowadays, you have the VMware. There you can load the Linux GUI. From there, you open a terminal. So this is the very much difference. We're done with the first point. The Windows had a forefather named as DOS, which was a complete command line operating system. Why I mentioned this point? Because you might be wondering that Linux has only the command line. No, before the Windows 95, there were the major operating system was DOS. The full name of it is Disk Operating System, and it was also like the command line. That time when the DOS was there, the DOS used to boot in a command line fashion like the Linux. Similarly, Linux GUI called the X Windows and the forefather called Bourne Shell, that is SH, released in 1989. Recently, whatever we use the GUI, it is called X Windows system in Linux. And nowadays, I have already shown in the last episode that there are P4 Linux desktops like Genome, XFCE, Plasma, all those things are there. Shell is a command line system software that interprets the commands and sends them to the OS. It is an interpreter between the end user, that is you, and the computer hardware. The shell accepts your commands and executes with the hardware. A shell provides the below thing, that is built-in commands, programming control structures, environment variables. Linux support multiple shells. Nowadays, default shell is the bash, that is born again shell. So it is a upgraded version of the born shell, that is bash. So all these things are there. So a shell will contain its own commands. It will give the programming control. I have made already a series on bash. So that is a favorite shell for the Linux programming. So there all the programming controls are very good enough. You can write a good script in bash and use it like any other programming language. Although it is interpreted, it is not compiled. Environment variables are there. It's very much needed. And we know there are multiple shells. I'm not talking about anymore. So I think we have covered what is a Linux shell from the concept. Nowadays, to the picture is also there where you will access the shell. So I think text and graphics both are done. So let's move on to the next slide. Some famous shells in Linux. Here we are going to discuss about few shells. Those are very much famous in the market and you may came across them every now and then. Although in VLSI, 1 or 2 shells you will be facing everyday work. However, if you are a Linux enthusiast, you might find all the shells to play around. The first thing is bash, that is born again shell. Second is C shell. It's more like the C programming language. It's the scripting part. TCSH is the corn shell. And finally, the TCSH. You have seen the logos here or the names, whatever applicable. Now, we will contain a table. The first, we will have the shell name. Second, we will have the name of the developers. And the third column, we will have the location where it was developed. So here is the table. So let me bring my mouse pointer. So bash, that is born again shell. It was developed by Brian Fox and Chet Frame in the location Free Software Foundation. C shell, that is CSH, was developed by Bill Joy and at the University of California. TSH, Korn shell, was developed by David Korn and location is AT&T Bell Labs. TCSH, that is Tennessee shell, was developed by Ken Ger and it was developed in the location of Carnegie Mellon University. So you can see that the various shells were developed at various geographical locations also and from different teams. So that's why the Linux system is so much popular. It spreads around. People are enthusiasts. They still develop multiple distribution. They contribute for development of the Linux. And the great thing about the Linux, it is open source. So people can easily contribute. That's for this particular slide. Let's move on to the next slide. In this slide, we'll talk about the TCSH and we'll explore why this is the favorite working shell. That is your typing commands and all these things. Why it is favorite for the VLSI usage. So one point came here. First point is VLSI most used command line shell is TCSH and the most used programming shell is bash. I have already created a series on bash which is based on the programming language or shell scripting. The command line that is used day-to-day work is TCSH. Next point, TCSH is a great shell for those who are slow typists because TCSH sometimes gives auto completion if you hit the tab key. And the third point, which was already there, command line editing and the file name or command completion. So I have mentioned this already that if you type some amount of the file name or the command and then you hit tab, it gets completed in the TCSH. The fourth point is you can use the tab key to cut down the amount of typing you do that I was saying. When you press the tab key in TCSH, we'll try to complete either a file name or a command. Most of the VLSI command line tools require login shell to be the TCSH. This is the industry use which I mentioned here. VLSI command line environment variables are easy to configure to setenv variable, whereas the same thing is export command in the bash. However, in the VLSI world, any manual if you open up, you will see that all the environment variables are set through the setenv command. All the VLSI tools prefer the TCSH to be used. proprietary software license manager work well with the TCSH. There are license managers because any of the VLSI tool, they are proprietary tools and they require license to run. The license will be configured by the environment variable and the license will be managed by the license manager. That is another kind of software that has to be installed separately apart from the basic software, and that works very well in the TCSH. So keeping all these points in mind, this is just to give you a snapshot why the TCSH is the favorite working shell, that is your typing shell in the VLSI. So folks, we are done with this particular slide. Let's move on. Bash, the favorite shell for programming in VLSI, and for this reason I have created 4 episodes where in the first 2 episodes I have covered basics, and the third episode I have covered the SED, and in the 4th episode I have covered the AWK. So you guys can go ahead and watch those episodes because this 4 episode concentrates on the programming through the bash shell and the 2 other tools that can be added with the basic bash scripting, that is SED and AWK. So folks, we are done with this particular slide. Let's move on. Repositories concept in Linux. Now, why I am keeping this particular slide is a very general concept, or it's a very much needed concept of the repositories in Linux. This particular terminology you will not hear if you are using Windows. Now, here first we have a repository server where all the Linux basic file, all the packages, the installation thing, they will be there. It is maintained by Ubuntu, or it is maintained by the Debian, or it is maintained by the Fedora group. So all these groups, they will maintain their own repository server, from where you download a copy of the Linux into your local machine. After you install the Linux, whatever software you are installing through the command line, I'll come at those commands later on. Whatever software you are installing through the command line will communicate with the repository server and fetch the respective dependency packages from there and finally install in your local machine. So this is the functioning of the repositories. So let us see in the text. Linux repository is a storage location from which your system retrieves and installs OS updates and applications. Once you have installed, say, Ubuntu, every month we will get some updates, and those updates will be loaded on the repository server, from where you can download and update your local installation. Each repository is a collection of software hosted on a remote server and intended to be used for installing and updating software packages on Linux system. Now, you might be wondering at this point why I am talking about the repositories, because many times if you try to install software manually instead of the command line or the RPM or Debian package, that time it will throw out an error. We are missing these packages. So for those packages, you have to add the repositories first and then you have to install them. In between also you have to update the things. This concept is necessary because this is a very far away concept from the Windows software installation where you have only one file to install. In Linux, when you try to install a software, it will maybe in the background installing 5, 6 or 10 dependent packages on which the software depends to be installed or to be run, or both. So those things coming from the repository server. So this concept is very much needed because you as a beginner, you want to install some software, and if you have to troubleshoot, you have to know this particular concept. Repositories contain thousands of programs and relevant packages. Already mentioned the relevant packages, that means the packages which are required either to install the software or to run the software properly. Standard repositories provide a high degree of security since the software included is thoroughly tested and built to be compatible with the particular distribution and version. This is another reason why the Linux is so much secure, because the software repositories are maintained by the respective groups like Ubuntu group or the Fedora group or the Debian group or the Red Hat group. They maintain these repositories. So the files staying there are clean, and hence it is very much secure that you can install any software from the original repositories without even thinking, because they will not contain any malicious code or something like that. And these codes are well tested by those respective groups. So that is why the repository is very much important, and hence Linux machine is considered as a much more secure system as compared to a Windows system, because in Windows you can download the file from anywhere and install it, but in Linux you must have the proper repositories from where you are installing. Forget about the RPM or Debian dev packages. I'm not talking about them. You can do that. However, they will also may connect with the repositories for dependent packages. can expect the installer updates to occur with no unexpected side effects. This is the very much good thing. Apart from any security threats, they will not come. The security threats will not come if you are installing from a proper repository. And also, you will not have a crash or something kind of stuff where you are installing from a repository. That means they are well tried and tested. Then they are uploaded in the repository server. I think this slide is done and the concept transfer is also done from my side. So let's move on to the next slide. Software installation in Linux. So far we have become familiar with different repositories, hardware, kernels and everything that is Linux inside out. So now let's look on to the fact how we can install the Linux. I will just exemplify here. I will not show any demo here. Later we can go through such installation, or you can go ahead and patch OpenTimer. I have already installed. There I have installed all the repositories first and then I installed the packages. Okay. That thing you can go ahead and see the OpenTimer installation. The video you can find in the static timing analysis playlist. So here, first for the Ubuntu or the Debian, these 4 commands we use. Let me bring my mouse. First one is the apt-get install. Then we give the program name or the package name. And if you want to remove it, we get apt-get remove. We generally add sudo because any installation or uninstallation requires the root permission, and Ubuntu here it is sudo, sudo. And we use the apt update to update the packages and upgrade to upgrade the packages already installed. Say we have a package version 1.01 and we get a 1.05. So for that upgradation, we use the apt-get upgrade. So all these 4 commands are used for the command line installation. I can tell you that the command line installation is much more easier than any GUI, because if some error is thrown out, the GUI will not give you the exact reason what is going on and why that installation has been stuck, but the command line will give you the message. So that's why the command line install I prefer, and I'll suggest you that you go ahead and install it in the command line way, because you can troubleshoot if there is an error. At least you can copy paste the error in search engine and you can find out from the respective Linux group forums what happened, because generally these are software errors and they are common and they are reported in the respective forums like the Ubuntu forum or Fedora forum. So we are done with this particular 4 commands. Let's move on to the next. So for Fedora or Red Hat, we have the yum. So yum install, then the package name, yum remove the package name, yum update the package name. So this is the way we do it in the Fedora. In SUSE, we use zyper. So zyper install, then the package name, and zyper remove the package name. For BSD, we use the pkg command. So pkg install, package name, pkg delete, then the package name. So this way we do it in the BSD. So mostly in this tutorial, I am using the Ubuntu distribution. So you can keep your focus here in these particular commands, which I will be using again and again. Although I have given you different flavors which are used just to have a broader picture and a bird's eye view how the installation is done in the Linux. So folks, we are done with this particular slide. Let's move on. Repositories are in Ubuntu. We have already discussed what is a repository and why we keep a repository. In this tutorial, I will be using the Ubuntu throughout. I am educating you through this particular slide what all repositories are there for Ubuntu. The first one is the main. This is the officially supported open source software. Canonical is the group which maintains for the Ubuntu. Canonical provides official support for these packages. Every open source software package included in the default installation is included along with some other important packages. So this is the purpose of the main repository. Restricted, officially supported closed source software, that is hardware drivers, support for the length of the release. Restricted, and this is for closed source softwares, this repository. Universe, community maintained open source. Community means I already mentioned that the Linux is open source system and many people, they contribute to software, they help to enhance the software by their own contribution in the software code. That makes a community. So if such community exists for a particular distribution, say Ubuntu, all those contributions will be kept in a particular repository, and that repository is named as Universe. The majority of the Ubuntu software comes from this repository. Canonical does not provide official support or updates. Since these packages are contributed by the community, hence the main group that takes care of the Ubuntu system, the Canonical, they do not provide the support here. Here you will get whatever is contributed and updated by the community in the Universe repository. Multiverse, unsupported closed source and patent encumbered software. So those which are not supported by the canonical or they are closed source or some patent is there. So all those software will reside on the multiverse repository. So I'll show you in the Ubuntu where you can see all these repositories later on the hands-on episode. So just for your knowledge, you can think the main, restricted, universe and multiverse. So the main is by the canonical and the universe is by the community. Rest of the things are closed source. We are done with this particular slide. Let's move on. File structure comparison, Windows versus Linux. Here we have a table. File structure, I have 4 points here as a category on which we are going to compare Windows and Linux. So file system in Windows, generally nowadays you will see the NTFS. Earlier it was FAT32. Before the millennium, I think everything was FAT32. Windows Millennium Edition, everything is NTFS. In Linux, earlier it was XFS, then it was ext3 and then ext4. It is called extended file system. So it is also extended version 3 and extended version 4. They are termed as ext4 and ext3. So latest is running ext4. And in pen drive, you will obviously find either the FAT or the FAT32. That is the first category comparison. Second category is when we do a partition. So if we do a partition in Windows, generally our first drive is C, second is D and third is E. Sorry for the typo here. And Linux, the same thing will come as dev/sda1, dev/sda2, dev/sda3. I'll come later to you all these names. They are there in this particular episode. Mounting point indicator. So we have CD-ROM drive, DVD-ROM drive or any disk drive. So those will come with the drive letter C, D, E, F, G. And in Linux, the mount path is all under this slash. This is called root. I'll come later to this detail. OS installation location. In Windows, we have all the OS related files in the C drive. Whereas in Linux, we have all the files installed in the slash. This is called the root directory. We are done in a sort and sheet fashion. What are the file system? What are the partition? What is the mount point loader and the OS installation for Windows versus Linux comparison. This way, you will be able to correlate concept of Windows that is already in your mind versus the Linux thing that is you are learning new. So this was the purpose of this slide. So let's move on. Overall file tree structure in Linux. So this particular slide is graphical only. So here is our root directory. First we have the bin, then we have the dev, then we have the etc, then we have the user, we have the home, we have the sbin, we have the temp and we have the work. So under the root, we will have all these directories. These are major directories. However, these directories can have subdirectories. I am not talking about them because that will make your concept much more complex. And right now as a beginner, I will not make things complicated. Later, you can learn by yourself what are the subdirectories and all. Linux has a file tree structure as compared to the Windows. Windows, we don't see this kind of file tree or this kind of structure. There we see only drives and each drive will have its own file structure. All these things you will see common in any of the Linux installation, whether it is Red Hat, whether it is the Ubuntu, whether it is BSD, whether it is Garuda, all these kind of Linux, you will see these folders common, which will stay under the root folder, that is slash. The root is the topmost folder in which they will be there. So what these things mean, I'll come in the next slides. Let's move on in detail. The slash or the root directory is the topmost directory in the hierarchy. This is where all other file systems are mounted when the system boots up. Not to be confused with the slash root. Slash root, we have a separate directory. The only slash that is called the root directory, that is the system root. And the slash root, this is similar to a slash home directory, but for the root user or the super user, that is the system administrator. Next is slash boot. The slash boot directory contains all the files necessary for the boot up sequence of the system. Mostly consists of the bootloader, that is group, which is for the Linux systems, and the kernel files. So here all the boot related files are there. The slash bin. The slash bin stand for the binaries. It will contain necessary core utilities required to mount other directories. In most distribution, these also exist as a symbolic link as slash user slash bin. Slash dev. The slash dev abbreviates as devices. Everything is a file in GNU Linux, even devices. The hardware is represented as a special file. The slash dev abbreviates as a devices. The /etc, that is generally the etc. This etc directory consists of system-wide configuration files and databases. Things are very straightforward, so I did not re-explain any of them. Let's move on to the next points. The /user directory contains the executable binaries and other shared resources. The home directory has a folder for each and every user. So each user has a home directory for them. It enables to have user-specific configuration files. By default, each user has read and write access to their home directory and must need special elevated permissions modify files outside their home directory. The sbin. It is like a bin directory, but commands used by the system administrators consist of important commands for starting, maintaining, and recovering the system. So all the system-related binaries will be stored here. The /tmp. This is the place where the temporary files are stored. This directory cleaned up during the startup. So this is more like the temp directory of the Windows. If you are familiar, then you can correlate. /var. The var directory, which is the important information like caches, log files, etc. are stored. This is similar to the /tmp, but the files aren't clear during the startup. So this is the difference between the var and the tmp. tmp is cleaned up at the startup, but var is not. Although it will contain similar files like caches, log files, and etc. So we are done with all these points. Move on for the next points. The /media, the mount point for the devices such as USB devices and other media devices. The opt is optional where the locally installed software exists. So this is for locally installed software. /mnt, temporary directories are mounted in the /mnt. I'll go in detail for the mounting concept later. Just for now, you can remember that the temporary directories are mounted in the mnt. For example, a dual boot system, you would mount the Windows partition as /mnt/Windows. The /lib. The /lib directory has some important C libraries required by the /bin directory. There also exist lib32 and lib64 depending upon the system architecture. It exists as a symbolic link to the user lib in most distributions. So I'll cover later on in this series what is symbolic link and what is hard link. These are all important directories that I have discussed under the file tree structure of a Linux. We are done. Let's move on to the next slide. What is mounting in Linux? Now this is a very different concept as compared to the Windows. Why? Because in Windows, if you insert a pen drive, right, or if you insert a CD, you can directly read it. Nowadays, even if you insert a pen drive in Ubuntu, it will sense it and it will automatically allocate it as a drive. However, at the background, the mounting is going on. Now, what goes behind the background, I'm going to explain here, because if you eject a pen drive, even it is physically connected, you cannot access it anymore. To reuse it, you have to exert and insert it again. That means you have to reinitiate the mount process. Now, this mounting is very much needed because in VLSI, you sometimes have to mount a remote disk to work there. That is the relevancy. That's why I have kept this particular slide. In VLSI, when you are actually working inside a company, your home directory generally do not contain much space. You have to mount a remote directory to the mount command and use it. And I think for ease, this mount command may be included in your CSHRC file. I'll come later on. Yes, what is a CSHRC file? But for now, you just become familiar with the mounting concept. Later on, you will find the usage. In Windows, where there is one directory tree per storage component, that is hard drive, that is pen drive or SD card or DVD RW or external hard drive. So generally one particular tree, this is the structure. The Linux have a single directory tree as we have seen already. All accessible storage must have an associated location inside this single directory tree only. Mounting is the act of associating a storage device to a particular location or path in the Linux native directory tree. In Linux, you have a /root and inside that you have different directories, and this works like a tree structure. So whatever drive you have to include inside a hierarchy under this file structure. So mounting is that particular process. Let's say a CD-ROM device hardware is location. This is the physical location. /dev, dev is for devices, and then CD-ROM. And the chosen mount point will be /media, then /CD-ROM. The corresponding command is mount, then dev/CD-ROM, then media/CD-ROM. We have space in between mount and the next section and the next section to it. This way mounts a particular CD-ROM. After mount files inside the CD-ROM is accessible as /media/CD-ROM, then some directories I have put wildcard and some files which also have put wildcard. So in this hierarchy, you will access the directories and the files inside. When you have finished using the CD-ROM, you unmount it as unmount /dev/CD-ROM or unmount media/ both will work. You can unmount using either of them. In GUI or GNOME desktop, you click on eject or safely remove. Comes with the right click context menu. This works as the unmount command in the background. After this step, although the CD-ROM is physically connected, you cannot access it until you mount it again. So this is the concept of mounting, and this way the mounting and unmounting works in Linux. So this is slightly different from the Windows system, which keep in your mind. So we are done with this particular slide. Let's move on. Hey guys, welcome to the 4th episode of Linux Basics for VLSI. Today onwards, we are doing hands-on bootcamp to turbo boost your hands-on Linux skills. So sit tight and enjoy the learning experience. Hey guys, welcome back to the computer screen. We are starting the session right now. So here in front of me, I have two terminals open, first one and the second one. So you know already how to open a terminal, because in the installation episode I have already shown you how to open this particular terminal. And right now I am inside the home/msg, that is my username, and then there is a directory test. So I am working here right now. First thing what I will tell you, that I keep this particular left terminal to check the man pages and the right terminal for my work. Right now I am in the right hand terminal. One thing before starting anything, I would like to mention that what shell right now I am using is how to check echo $12. So I am using the TCSH. In your case, once you install the Linux, right, the first shell that by default comes to you is bash. In your case, you will see this particular shell, that is bash. In my case, I have TCSH. Now your question is that how to set this particular TCSH, or in case you don't have the TCSH inside your Linux installation, how to get it. I am using my Ubuntu installation, so I will show you the step how to install the TCSH. Here I am writing the command. So you can see that I have written sudo, that means I am installing it as a super user, and I am using the apt-get install command to install the binary TCSH. TCSH is a shell, however it's a binary. So I will hit enter. So it is asking for the root password. You can see that in this way you can install the TCSH. In my case, since I have already installed, it is giving the message TCSH is already in the newest version. In my machine, I have the latest version of TCSH. And in the last episode, I have already explained why TCSH shell is kept as a working shell for the VLSI industry. And today I have shown you how to install the TCSH. And here you can see that at the last line, in your case, if you have already any binary that you are trying to install, if you are trying to install by this particular command sudo apt-get install, if it is already there in your machine, it will show you that 0 newly installed. That means nothing installed. In case there is a version upgrade, it will do the version upgrade. In case it is not installed, it will install that particular thing. So here, once you install, here one will come, one newly installed. You can see I am using the commands very easy way. So in this easy way, you can learn the commands on the go. While you are watching this video, you can open a particular terminal side by side and you can try out the commands. How to check what all the shells are there already installed in your machine? I will explain this cat command later on. So just now let me use it. Cat, then slash etc, then whereis. So if I hit tab, so it completes. Since I am using TCSH, let me show you. If I type sh and then hit tab, it will give the option. So sh, then I type e, then again I hit tab and it completes. So this is the beauty of the TCSH shell. So now let's come back to the topic. Here we are seeing that what all login shells are available here. So you can see here is sh, here is bash, here is rbash, there is dash, and TCSH also is there. So you can see all these shells are already installed in the machine. So this particular file, if you access, cat command displays the content of a file, that is human readable file. Here you can see that it has listed out all the shells, those are installed in this particular machine. So now let me show you, after you have installed the TCSH in your machine, how you will enable it as your default login shell. For that you have to use a command called chsh. I'll educate you. Let me go back to the left terminal. Here I type man. Man command is used for accessing the manual. Then I type the binary name chsh. So you can see here chsh is to change the login shell, and here is the description. The chsh command changes the user login shell. This determines the name of the user's initial login command. A normal user's may only change the login shell for his or her account. Super user may change the login shell for any account. So if you are root, you can change it for anyone. So you cannot change any other user's login shell. That is the restriction in Linux. So let me get out of this particular command, and now let me go into this particular shell back. chsh, here I type it and it asking for the password, that is your password. In my case I am giving my password. Now here it is saying changing the login shell for msg. Msg is my username. Enter the new value or press enter for the default one. So here what I see that it is asking for the login shell. TCSH is installed. Either you can pick this or you can pick this, anyone. I am picking this and putting it here. In your case, here it will be bash. You will replace it with this particular TCSH. Now, if I hit enter, it takes. Here immediately nothing will change. What happens? You completely log out or you completely reboot the system, either of the two, and then once you log in, your default shell will be changed to TCSH. So once you open any terminal, that time if you do echo $shell, it will show what is your present shell is TCSH. Immediately after changing, it will show only bash, which is I think in Ubuntu is the default one. However, once you change it to TCSH, you have to do logout and login to activate the default shell change to the new shell. We are done with this particular shell modification command. With that note, let me clear the screen. I will type clear. This command will clean up the screen. So here the screen is made clear. Once you log in, how to check what is your username? So you do it by who am I. So you have to write it continuously. So you can see this is your login name. In my case, this is my login name. If I write tilde and then enter, it is saying home/msg. So tilde means to my home directory. Right now I am in home, then msg, then test. Okay, so here inside this directory. However, this tilde, say if I write pd then tilde, pd means change directory. So here again I write pwd. You can see that earlier we was in this particular directory we use cd tilde and we reach to this. Now I would like to go back to my previous directory. For that I will use cd then dash. So I am again back in my previous directory, the test directory, that the place where I started. So let me clear the screen. The next command that we are going to try out is date. If I type date and press enter, you can see that it is showing today's date and the time. I have configured the time zone to be IST, Indian Standard Time, and hence it is showing the IST. If I do date minus u, it will show me the time zone with respect to the UTC. Let me clear the screen and start again with the PWD command. PWD. So once I do the PWD, you can see that it is showing present working directory. Now there are two switches to it. So first, let me write the first switch L. If I type L, it will give the logical path. In case we are inside a linked directory, that means a directory which is not actually a directory, instead it is a shortcut. In that case, this L will give the logical path. And to see the physical path, you can use P. So in this case, this is a physical directory. So both the logical and the physical, that means PWD with L and PWD with P, both are giving the same result. Let me clear the screen again. The next command is nothing but a simple letter, that is W. If I type, it will show all the people who are logged in the system. So you can see here, when in actual VLSI, you are logged into a remote machine. In that case, what you will find that once you type this W command, you will see that multiple users are logged in there. Because in VLSI, you start with a Windows machine and then you logged into a remote machine. So in that particular machine, if you type this W command, you will see all of the other users who are logged in. The next command is which. Now, which command gives you a path. Say PWD already we have used. However, this is a binary, right? So if I type which PWD, it will show the path of the PWD. So when we type the PWD, it is running from user bin PWD. Now there is another similar command. Where is PWD? Once we type it, what it is getting listed out? It is giving the binary path, it's giving the header file path, it is also giving the documentation, and here also the documentation. So now whereis can give both binary and the documentation. If I want to search only the binary, what I will do? I will add here -b binary. So it will return only the binaries. Here you can see it is returning the binary as well as the header file. So both are in the same category, that means either header file or binary. So the software part, not the documentation part. If I want to search the documentation part, what I will do? I will do here N. So this will give me the manual. So where the man pages are stored? Here. Talking about this man pages, I already mentioned there is a command called man. So here if I go in the list terminal and type man pwd. So here you can see this manual which is actually getting accessed from this particular path. So the man command actually reads this particular file and displays it. So you can see PW is the print working directory. Here L is the logical, I have already mentioned. P is the physical. You can see all these things I have talked to you. You want to go in detail of any binary in Linux, you can type the man, and to come out of this you have to press Q. Q means you can see here in the line which is at the bottom, press H for help or Q to quit. So you have to Q to quit. So you will come out of the man page. Let me come back to the right hand terminal again. Here we are showing you right now the whereis command. So I have shown you the two options, that is to search the binary and search the manual. Here you can see where the binary is and where the manual. And if you type which, it will give you the binary. Let me go back here and check the man of which. Here you can see which to locate a command. It gives you the location of a command or binary. So here you can see the exit status. Whether it is found or not found, based on that, different exit values are there. Let me quit it. Now the next command that we are going to try, let me clear the screen before that. So now we'll create a directory. So in Windows, what you know that you have to keep files inside folders. In Linux, the folders are called directories, and Windows also it is sometimes called directories. But most common name in Windows is folder and most common name in Linux is directory. So let me here do the directory creation. Linux command paste. So I have typed the directory name, and now if I hit enter, this directory will be created. To see all files and folders inside the present working directory, you have to type ls, that is listing command. Here you can see that the directory is created here, and we will go inside it. I will type cd, that is change directory, to Linux, and then I hit tab. So I am in TCSH. You can see that once I hit the tab, it completed. Let me show you again. So if I typed up to Linux and then I hit tab, so it is completing. So this auto completion feature is there inside the TCSH. It is why most of the time we use it in VLSI, because we have to access very long path, and that long path we cannot type manually. That will be very tedious when we are actually working in a remote location, as I have explained in my last episode. If I hit enter, I am inside the directory, and here there is nothing inside. So let me type the pwd command. You can see that we are inside the directory where we have created. I have done a typo here. I missed a n here. Instead of command, I have typed command. So it's okay. Let's make some other directories inside. What I'll do is mkdir folder 1. Folder 1. If I press my up arrow key in TCSH, the same last command comes up. So here I type 2, and then I type mkdir mydir. Now you can see that I am doing ls. Here you can see there are 3 different directories are created. Now the question is that how I can create multiple nested directories in one shot. There is one command. We have to type mkdir, then p, and then we write a/b/c/d. With this particular command, all these directories will be created hierarchically, one inside another in one go. If I hit this and then I type cd, then here actually I double click to select it and middle click to paste it. That is possible in this particular shell. That is another learning that you got. If I write this and I hit enter, let me write pwd, and you can see that this long path we have created manually. This one is Linux command test, and then we have created all these directories at one shot. I am going here. Now I have to come back again to my directory. So I have shown there is an option called cd space dash, right? There is another option. If I write cd ... what will happen? Then I write pwd, you can see I have moved one level up. In the similar way, if I write cd space ... this ... means the directory above with respect to the directory we are presently in. So we will move one level up. Again, we see that we have moved up. pwd, you can see that we have come here. Then let me go back and give cd again ... So here, and we have reached up to a, and however we have to go one more level up. So cd. Another trick I'll show you. Let me go back again inside the D directory. What I'll do, I'll use this ... multiple times. So cd space ... slash ... slash ... slash. So 4 level up. So this will take me 4 level up. You can see that here we come back again in this directory. So let me demonstrate this command once again. So cd a/b/d, I go inside. I print pwd. Here I am down 4 hierarchy, and I have to come up again 4 hierarchy up. So I use dot dot, then dot dot, then dot dot, then I don't have to use anything else, any name specific. This is a very relative command. So it goes 4 level up and I hit enter and I type pwd. So I come back again to the directory from where I started. The next command that we are going to do here is the touch command. Let me clear the screen. In Linux, everything is a file. Even a directory is also a file. However, creating directory, we use the mkdir command, and for creating any file with 0 size, we use the touch command. So, touch aaa.txt. Now, if I type ls, you can see that we have the directory A, folder 1, folder 2, my directory, and we have this. Now let me touch again v, right? If I do this and I type alias, you can see these 2 files are created. So these files are just created. They have not been populated with any data. They are blank files. However, these 2 files have been created. I would like to enter some text inside the aaa.txt. What I will do? There is the editor called Nano, which is very much similar to the Notepad. However, this works inside the Linux shell only. So I will type Nano and then I will type AAA and I hit tab. So TCSH is completing the rest of the part. So I hit enter. You can see it has opened. And here I can type with round box. I hit enter. Jump over easy dog. So here text has been entered. So here at the bottom you can see there are a lot of shortcuts are there. This caret means control in your keyboard. To save I will use Control S. So this is saved. Now you can see all these things are there. I can create a Nano tutorial later on, but just for your information, there is a text editor Nano which runs inside the shell and in a very easy fashion. What I will do, I will use Control X to exit. It is asking save the modified buffer. I will say Y. Yes. Now I told you that you can see the content of a file using a cat command, cat aaa.txt. So you can see that we have entered 3 lines and a blank line inside the first text file, that is aaa.txt. Now let me do the same thing. Open nano and bbb.txt. bb roy rate retain good wise. Well, you see folks, you may recall what this line means. This is nothing but the register color code. You remember this by this particular line. Here let me save the file, Control S, 4 lines, and let me exit. I exited. So I'll use the cat command, cat bbb.txt here. You can see, and 2 files which have been created by the touch command is now populated using the nano command. Now the next file extension that I am going to create is not actually a mp3. However, I am using the touch command to create song.mp3. So this is just for your example, and I will touch video.avi as a video file. So you know these are video file extension and audio file extensions. I have touched and created a 0-byte file with name and extension. So here my alias is already aliased. So if I type which alias, right, it will say alias with color. So here in my shell it is already ready that it will display with color. In your case, what you will do, alias -- color. If you type, you can see that the directories are coming in blue and the mp3 is coming as green and the video is coming as pink or purple, you can say, and the text files are coming as white. So each different file extension will be colored differently. I have set it as an alias. Let me touch few more files. Touch pong2 dot mp3 3.mp3 and 4.mp3 and touch video 2.avi and video 3.avi and video 4.avi. So here I have created multiple files. You can see if I type alias, it will show all the type of the files. Let me clear and go back to the starting point. Clear. Now let me do the alias. You can see all the type of the files are listed here. I have highlighted. Inside the directory, this is countable files. And if there is huge number of files, if you want to count them, what you will do? You will do alias star.txt. So it will give you only the file that are present inside the directory with the extension txt. Now the same thing I will show you. Let me go back one level up and I will type alias. Then let me copy the directory name here. Then slash start.txt. So what it will do, even if you are one level up, you can do this hierarchy thing that you type the directory name, then slash, then start.txt. It will give you the files. So you have learned it, you can use it. Let me go back to the previous directory, that means inside the directory. Now I will type alias, then star.mp3. So what it will do, it will list out. Alias is listing basically. So it will list out all the mp3 files here. Now if I do the alias for star.avi, it will list out all the video files here. These are now horizontally reported, right? If I want to list them up vertically, what I will do? ls minus l. You can see here all the details will come. These are file permissions. I will come and here you can see the owner and all these things here at the time at which they are created. You can see all these detailed thing come. Let me clear the screen. I will teach you one thing more here. How to create a hidden file. So in Linux, you can create a hidden file. Touch dot hidden one. We do one more. Touch hidden 2, touch hidden 3. So these file name which are starting with dot and do not have any extension, or either have an extension or not, but beginning they will have a dot. Those are hidden files. So if I do the alias, you will not see them. Those are hidden. Just to list out all these hidden files, I have to do alias dash l, or let me do a, alias minus a, all. So this will do what? That it will list out all the files including the hidden files. A means all. If I type alias dash lt, timestamp wise it will list up. So you can see that it is 1927, this one is at the top, and 1915, which was the first, it is at the top. If I want to reverse it, this listing, what I'll do, I'll put a R here. So this, let me tell you one thing, this L, this R and this T, these are separate arguments. So let me show you here. Man ls. So you can see here we have separate arguments. Okay, C, D, F, all these things. You can go ahead in this manual. All these things are separate arguments. You can use them separately or you can club them together. So when I write that alias minus lt, right, I can do alias minus l then dash t. It will give me the same thing. Instead, what I do for my ease, I type alias minus lt combine. Now in reverse order, I would like to see, I add R. So you can see it has reverse. So 1915 file which was created comes at the top, and the file which is created at the last, timestamp wise comes at bottom. Now instead, this is very cumbersome to type, right? What I will do, I will do ls give a dash. I will club all the arguments together, L, R and T together, and I will hit enter. So this thing is not only for the ls, this is for all of the binaries in Linux. You can combine multiple arguments. Obviously, those arguments should not have any corresponding value to be entered. These are only arguments and they do not have to carry any value for them. So all those arguments can be combined. Let me bring up here. Here, if L accepts any value right after this, then we cannot combine L, T and R. In that case, we can combine T and R, right? And we have to give the value after L. So you have to remember. Let me clear the screen. Now I have to sort the file size wise. ls, then I write dash L, then sorting file size wise is capital S, that is in upper caps S. What we write, and you can see that here it goes like here. You can see this column here. This, I think it's in byte. So if I add H, that is human readable, it gives, so you can see K has come here. So 4K, this is then byte, okay? If it is gigabyte, here G will come. All these things. So if you add H, it gives the human readable format. To reverse it, what I will do, I will add R. So you can write or remember any combination wise. That means L, R, S, S, R, L, whatever you are comfortable with. You can see it has listed out in a reverse order, means 0 byte file size are there in the above, and here if I go down, it shows you the file size which is higher. Here another thing I would like to show you rather, that we have another command called file, and okay, let me first, before giving, let me clear the screen. File command, and then we give here we have aaa.txt, right? So here if I type file and then write the file name, it gives the type of the file. So this is ASCII text file, okay? File, then song.mp3. So it is saying it is empty, right? So if a file is not containing anything, it is empty. In an actual case, mp3 will be an audio, right? In that case, it will show something like that. And if I write file, then A is a directory, right? So it shows A, it is a directory. Staying in terminal, in case you don't have any colors or something, you have to decide what type of file is this. You can type this particular command. For today, we will close here. Hey guys, welcome to the 5th episode of Linux Basics for VLSI. Today is the second day of the bootcamp and we will be completing the basic Linux commands today. You may open up a Linux terminal side by side while watching this video to try out the shown command steps. So gear up and enjoy the learning experience. Hey guys, welcome back to the computer screen. We are starting from the point where we have left in the last episode. So let me show you some additional facts that last day we have just touched based. So this is a command that I have used last episode. So if I put this right, what all these things mean. Now here you can see this first column from the left side is the file permission or the directory permission. Now here you can see the content. This is user. User means right now I am the user, so my user ID is there. Next, it is also same here in this case. However, once you are in an actual company, here what you will see that this is a group's ID. This column is the file size in byte. Now here you can see the month and here you can see the date. And here you can see the time. And in the last column, the file name or the directory name. So if you remember that I have used a particular switch which is named as -h that converts these file sizes in a human readable format. Let me use it and repeat the same command. Now, once I do this, you can see that this was in bytes. Now it is showing in kilobytes. So you can see here it is also showing in the kilobytes. Now this is the factor that you must remember whenever you are working with ls-l, you must include the h, because this h helps you to get the values quickly, because our human mind is kind of habituated with the kilo and giga and all those kind of abbreviations instead of the bytes here as it is written. So that will help you to understand or grab the file size much more easily. This particular command and the columns is done. Let me clear the screen. So let's move on to the next command, cat command. What does this cat command means? Let me first show you the manual. Here you can see that the cat concatenate files and prints the standard output. So this means that this particular cat command concatenate the content of more than one file and show you in the computer screen. So here all the particular switches are there. All these switches means different things. You can go ahead and try out them. So for now, just I will exiting the particular man page and let me show you one cat example. Cat, then etc, then services. So I hit tab and it completes because right now I'm using the TCSH shell. So here you can see it shows the content of this particular file. Now this is a very huge length. Now if you want to see this thing with a particular height page by page, what you will do? So you first do the cat and then use the pipe command. It acts like a kind of redirection to another Unix command or Linux command. So here if I type less means we have seen so much of the lines and now I want to see lesser amount of the particular lines, and that's why I'm typing the less. So if I type less here, you can see the cursor is blinking here and only one page is shown. So if you hit the page down button in your keyboard, what will happen? It will move one page. You can scroll down by the down arrow key, then it will scroll by line. This is I'm scrolling with the down arrow key and I'm going down with one line at a time. And in case you want to go down per page, you have to hit the page down key. So here I am hitting the page down key and you can see that I am going down and I have reached to the end. You can see that here end is highlighted and this is the end of this particular file. So now if I have to go up, I will again hit the page up key and I will go up. So you can use the page up down to move up or down by page, or in case you are working line by line, you want to move up line by line, you can use the up or the down arrow key. Here I am using the down arrow key and here I am using the up arrow key in your keyboard. This is the way the cat command generally used for any of the files. Another thing is that here the cat command, you don't have to really open the file. That means it is another advantage that you don't have to open the file and by any mistake, say if you delete something, right? If you have a write permission there, in case you delete it, so that will be a cumbersome thing to it. You delete some data inside the file. However, when you open with the cat and the piped less command, that time you don't have that risk. So you can use it in a much more kind of relaxed way so that you do not by mistake. There is no chance of doing mistake, and there is no chance that you delete any line. Now let me move to the next command. Let me clear the screen. I'll show you again. It is the command man PR. So PR means convert text files for printing. So it does almost the same thing like the cat here. Let me show you. PR then slash etc slash services. So if I do this and it prints and then it goes away, right? So here you can see, and in the same fashion, if we are using the piped less command, then what happens? That again we are viewing it page by page in the same way. To get out of this, you have to hit the Q. Remember, whenever you are in less, whether you are through cat or through PR, okay, or the less itself you can use. So you have to go out using the Q. So let me show you with the less command, okay. With the less command, what you can do, that we clear the screen. With the less command, if I type etc, okay, this file is there and I type less. Now you don't need the cat command. With the less command, you can go simply in the fashion. So less by itself is equipped to do the purpose. However, in cases you may use cat and less combined, or you can do the less. So for your viewing, you can use the less. Now let me quit. So there is another similar command, more, and if I type slash etc, then okay, the screen is cluttered. Let me clear the screen. More etc services. More also works in the similar fashion. So here you can see, so this way you can use the more. Let me hit Q and clear the screen. Let me go to the main page of more. So more is file partial filter for PRT viewing. Okay, I think you can go ahead and use the less or cat and less combined. So let me get out of this main page. Now let me show you here. I have done the ls. If you remember, in last episode we have populated AAA and BBB.txt. So now cat can concatenate the contents of the two files. Let us see how. So I write cat, then I write AAA.txt, then BBB.txt. Okay. So if I hit enter, what happens? So you can see it together flattens the two files. That means it is not opening the two files, but it is showing the content of the two files one by one and back to back. Now this thing is done here. If you want to save this particular data that is coming out of the concatenation of the two files into a third file, what you will do? So let me resurrect the command here and I add a redirection command, that is a right hand arrow. You can find, I think, in the key row where the shift is there. It is beside the shift key in your keyboard. Here you can find it. So then I write out.txt. What will do? So this command, this cat command will do this thing. It will concatenate the output, and the redirection operator takes this combined output to another file. So let me hit the enter. Content is gone to the out.txt. Now let me do the cat out.txt. When I hit, what I see? Yes, we have concatenated two files, that is AAA and BBB.txt, and then we have just combined them in output. So what was in AAA? I cat AAA.txt and cat BBB.txt. So you can see with the cat command, we can combine two files, and either we can save it on the screen, that means we can show it on the screen, or we can save it into a particular file. Just like here we have done this. Now let me clear the screen. Now we will see the another use of the cat command. I write cat. Here what I will do, I'll use cat command as a text editor to enter some text into a file. So here write.txt. Here I go. So once this hit the enter key, right, here the prompt come. So let me write it's a sunny day. Let's go to the playground and play. So we are done, and let me save this file. Cat. I did the cat again here on the file. Now you can see that the text that we have typed in the terminal is saved on the write.txt. So this way you can use the cat command as the text editor to enter some text. So what I did here, I have exited. I have typed Ctrl+C from my keyboard to get out of the editor mode. The next I'll show you. Now this is the file that already there we have written. I want to add some more text into it. What I will do, I will type cat, then 2 times the right arrow key, and then I write write.txt. So what will happen now here, once I write something, this is an additional line, and here is stop, and here I press Ctrl+C again. So now let me do the cat on write.txt. What happens here? You can see the first line we entered in our first operation here, and here when we do this thing, we add another line. That means we are appending some more line to the existing text file. So this way, either you can write a fresh file, fresh text file through cat command, or you can append some text in the existing text file. Obviously, you have to have the right permission for that particular file. Don't worry, I'll come to the file permissions later. These are a bit more advanced, so I am covering the basic things right now. I'll cover the advanced things later. So we are done with the cat command. Now what we will do, we will use another command. Before that, let us move to the man page. Man sort. So here you can see this particular command, sort command, sorts the lines of the text files. Obviously not inside the file, however, it's only in the outside. So let me type sort in write.txt. So here it is doing nothing. So sort out.txt. So here you can see, okay, let me cat the out.txt. So you can see that this is the original file right here, and here it is getting sorted using the sort command. So here it sorts among the lines. So this is the purpose of using sort. You can go to the man page for more exploration. Now let me move on to the next command. Before that, let me clear the screen. The next command is that the head command and the tail command. Now these two commands are used either to view a first few lines, that is using the head, and last few lines using the tail command. As you can see that this file is very huge. If I write this and then I do the line count here, 417 lines are there in this particular file. Now we want to see first few lines. I do head then write etc. So if I write, you can see the first few lines are coming here. If I write less, then the same thing you will be able to compare. So you can see here in the left terminal I have used the head and the first few lines. Here you can see these first few lines using the less command. And if I type tail and then write this particular file, what will happen? The last few lines will come. So now if I go using the page down button, I go to the last lines. So here you can see couple of last lines are coming here. Obvious question is that how we are having the control that we will display only few particular lines. Now this will be done using a next argument inside this particular head or tail command. Let me clear the screen. I type head, then dash 10, then the file name. So it will print the first 10 lines of this particular file. Alternatively, instead of a minus sign, if you use the plus sign, the same thing will be done. So either you can use a plus sign or you use a minus sign, whatever is your choice. Now, again what I have to do, that I have to do the last 10 lines to print of a file. I'll type tail, then dash 10 or minus 10, then this one. So it prints the last 10 lines. So here you can see the last 10 lines are printed. So let me go to the main page. So here you can see output the last part of the files. The opposite is head. So you can see the suggestion here, keep head. So just for your easy remembrance, because when we use say ls, then we write dash, then l, right? And then write h. Keeping in that mind, you can remember that to use the head or tail command with the dash number, say 15 lines. Here I go and I type 15 lines. So here better to go and remember this dash, because most of the cases we are using the arguments with the dash commands. That is easier to remember. However, you can use the plus or minus. Now we are done with this command. We'll move forward. Let me clear the screen. The next command that I am going to demonstrate is grep. Let me show you. Now, so grep, e grep, f grep, r grep. So I'll just demonstrate the grep. Of the things I am not showing right now. This prints the matching patterns. What is matching pattern? Matching pattern is under the regular expression. I have explained this in the third episode of the bash scripting already in this channel. What is the regular expression? You can go ahead in that particular episode and use the chapters to navigate to the relevant chapters. Let me go out of this and show you what you do simply with the grep file. Already you are familiar with the /etc/services file. Here I would like to grep one particular term, the TCP term. I want to see which lines contain this particular word TCP. Grep, then TCP, then I will give the file name. So once I type, right, you can see that here lot of lines, those are containing TCP, are listed out. If I want to do the exact opposite things, that means I want to see which lines do not contain the TCP. The basic negation of the search condition. I'll do here, clear the screen and resurrect the command here, and I add here -v. Whenever I type the -v command, it does the negation of the operation. That means whatever we were looking for, we go in a totally opposite direction. That means we will see the lines where this particular phrase is not present. So these are the lines. You can see here UDP and all are coming. Let me show you the commands. Two 46 lines contain the word TCP, and if I do at the -v, how many lines do not contain the TCP is 171. Now let us see the how many lines are there in this particular file. If you can see, if we add these numbers, this number comes up. So this means the grep command can be used to positively find or negatively find a particular word inside a file. Let me clear the screen. I have just shown you the line count, right? I'll show you some more variations. Let me show you the man page of the wc command. It prints new line, word and byte counts of each file. Count how many lines are there, or how many words are there, or how many characters are there in the file. So let me exit and show you with example. Typing wc-l, then /pc/services. Here you can see there are 417 lines. Now L for line, W for word. How many words are there? There are 94 words are in the particular file. Next, if I want to see the characters, I type this. L for line, W for words, and C for characters. WC-L gives the total lines, WC-W gives the number of words, and this gives the characters. This way you can have a count. Sometimes you are writing something in Unix and you have to submit in some box where you have some text limitation. Here you can count your characters, you can count your words, all those things using this simple command. Now we have shown you just one example with the grep. With the grep command we can do the count also. Let me show you. Grep -p CP, we are searching, and then etc/services. So this gives the count, and the lines which do not contain the lines we can get from this. Okay, so these are similar because to remember grep minus, if I remove and I give the, here you can see it is giving the exact same number. So grep -p is a single command that you can use to count the matching number of lines. Or the reverse you can do with this one. And the same thing if I use it, let me show you. Here you can see that it is equal to 171 in both the cases. So these, here we are using two commands. We are using the single command with the argument. So you can use either of them, whichever you are comfortable. I have shown you both the commands. Now let me show you another thing. When we are searching with the grep, we are just finding out the lines. But what if we want to see the line numbers also along with the search? What we'll have to do? We add -n. So you can see here the lines are coming with the line numbers also. Here it is the line number. Earlier you can see that all the line numbers. If you want to see the opposite grep -v with n, it gives the line number. So here you can see again, here at the leftmost column, and here the colon is using as a separator. This is the line number, then it is the separator, and then it is the actual line. So this way the line number can be shown. Now let me show you some more commands. Such output.txt. Okay, I have just created one particular file. Now I'll show you how you can copy this file to another location. I will type cp and then output.txt. I'll copy it to the temp folder. So here it is. Now let me do the ls temp folder. Here you can see it has been copied to the temp folder. Temp folder I have already explained in previous episode. It contains the temporary files. Let me clear the screen and let me show you the cp command. You can copy the same file with a different name. cp output, then you type it output2.txt. So if you want to duplicate a file, you can use the cp command. So this way you can duplicate a file. Now you want to remove the file, that is delete the file that you have copied to the temp folder, or any file. Say if you want to delete, right, you use the command rm. Rm means remove, and I type here, let me select it, the file name. So I type rm. So this file is removed now and you cannot see this particular file. If I type rm then /mp then /output.txt, if I want to remove it, I can also remove it. Now the file is removed from the temp folder. So this way you can remove. Let me show you another thing. rm -v. So v if I use, then I use output.txt. What happens? You see. So it gives a message. -v means verbose, and it echoes what it is doing. It is a good practice that when you are removing a file, you can use the -v command, so that you also get a confirmation that the file is deleted on the screen. Now let me show you some other usage of the particular rm command. I am making a directory mkdir. I have already shown you. Now if I try to remove it using the command, what happened? I have used the v, so it will give a verbose information. Here you can see that it is showing rm cannot remove the abcd. It's a directory. Now if I want to remove a directory, what I will have to do? I will have to do R. That means it gives a recursive delete command, and you can see that now the directory is removed. For removing a file, you can use rm-v command, and for removing a directory, you can use the rm-rb or br, whatever you say, that particular command. Now I will show you another command through which you can rename a file. Let me make a copy. out.txt to output.txt. So I have copied it. Now I want to rename this output file to outx.txt. I can use the mv. That means move. Move is a command that is used for moving a directory or a file. However, it can be used for renaming. The next command that we are going to see is a find command. So if I type ls, you can see there are a lot of files here, right? So let me copy song3.mp3 inside my dir and then copy the same file to folder 2 and copy the same to folder 1. Okay, so I have copied the same file in my directory. So let me do the ls. Okay, all the files are there. Now I don't know where this particular file, that means the song3.mp3 is present, and I want to search it. How I will search it? I will use the find command, and the next field that I'm going to give / means the present directory, or you can give a full path. That means here you can see this is / Linux test command. You can give the full path also. There is no issue. But here I am giving a relative path, that means / whatever the directory is, the point where we are right now, and the subdirectories. If I go, so it will not go above. It will not go in the test directory. It will be inside the Linux command test directory, and it will go further searching in the subdirectories. And then I hit name, then I make a double quote, and I just copy this particular file name. Now you can see I have written find, and then I have given the path where to search, then I give the argument name, and then I give the argument value. Obviously I have to provide it within the double quotes. Now if I hit enter, you can see it has listed out all the directories. Even in the base directory where I am searching, all these things are there. Now if I don't know whatever name is there, let me copy the song3.mp3 in a with another name, that is song3.mp3. Let me copy it. Now what will happen? One character is upper caps here. Now how I can find this? Both files are same, but the names are different because this is a small caps and this is upper caps. In this case, I am resurrecting the command, and here I am adding I. I means insensitive. So case insensitive searcher. Here if I search, you can see it is listing out the case insensitive search. That is, it is searching with the upper caps S as well as the lower caps S. Now if I remove this I, what happens? It do not give this result. So this means it's better you search with a case insensitive search. In that case you will be able to find the file. In case there is such small change where any particular character or two particular character is in upper caps, so in that case you will be able to find it. I have shown you the find command. Let me clear the screen. Here next I will show you the command which is creating a soft link. So I will use ln. Ln is creating for soft link. I use s for the soft link. Now you can correlate what is a soft link. Soft link is a similar concept of the shortcuts. In Windows, what you do a right click, and from context menu you select create shortcut, right? So here in Linux command line, this is the same thing. Okay, so here I type out.txt to link.txt. Once I type it, so you know, right, we already have the output.txt and I create a link. If I do the alias now, you will see the link.txt. And how to understand which are links, I have to do alias minus L. So here you can see it is pointing. So this link.txt is now shortcut of out.txt. So this way we can create a shortcut. Similar to the concept, on Windows we do right click and we select the create shortcut command. And here we use the ls minus L. Then we give the file name of which we want to create a shortcut, and then we give the name of the shortcut which we want to create. So this way, how to see the link? If you do the ls minus L, all the basic files will be listed and the linked file will show an arrow. That means this file is a shortcut of this file. So this way you will get which is link and which is not a link. So this is the concept of the file linking. Now I'll show the last command of today's episode. History command gives you all the commands that I have used in today's episode. For me, for you, what it will give? The session you have logged in and the commands that you have used in that particular session. So it will list out. So all these commands one by one I have used. So the history command gives the list of the commands that I have used in this particular session. Let me clear the screen, and that's all folks for today. Hey guys, welcome to the 6th episode of Linux Basics for VLSI. Today is the 3rd day of the bootcamp where we'll be covering some of the advanced Linux commands. If you don't know these commands, then you may face glitch every now and then in your day-to-day work in VLSI. You may open up a Linux terminal side by side while watching this video to try out the shown command steps. So gear up and enjoy the learning experience. Hey guys, welcome back to the computer screen. Today we are going to walk around to a couple of advanced commands. All the basic commands we have done in the last 2 episodes. In today's episode, we will cover the advanced commands. So without any further delay, let's begin. So this command, when I execute, what happens that here you can see these columns are coming out. So last episode, I have already explained what these columns means. Now, today we will look into the first column. So here you can see there are fields 1, 2, 3, 1, 2, 3. If I start from here, and for now, we are not talking about this particular column. So here you can see I have highlighted fields are there. So RW dash, RW dash, R dash dash. So these 3 are fields which represent a file permission. In Linux, the file concept is a bit different as compared to its Windows counterpart. What is different? Whenever we have a file in Windows, anyone can access that. Obviously, that person has to be connected with the system. Now, in Linux, there will be multiple users, and multiple users, each one have their own area of working. And if there is a common area where multiple users can work, what will happen? Several users will be creating files. Now, Linux has a provision that if multiple users are working in the same area, even though one cannot alter another person's file until or unless the other person gives the proper permission. Now, how that is done? That is done through a command and these fields which is kept highlighted. So let me show you the command here. The command is chmod. It is to modify the permission of the file. So I will go in detail. Let it be there. The file permission. Here you can see there are fields already mentioned. So these first three fields corresponding to the user, that means you. The next three fields corresponding to the group means, say, in a company, there are several groups. Some are front-end group, some are back-end group, some are CAD group. Say, you are inside one of these group. So here in this highlighted field, the particular group's permission will be there. And the rest of the three field belongs to anyone else in the world who are connected to the physical device. Now, by this point, the explanation that I have given, you have already understood that why this is an advanced topic right now I am discussing. Here you can see RW means read write, and the third value comes as execute. Here you can see that read write execute, read write execute, read write execute is there. And here you can see read write read, read write and read. So these are flags. That means you can turn on any one of the read write or execute permission or turn off any one of them. So you can do it whatever combination you like. So here it is the write.txt. Let me change its permission to be executable. What I will do? chmod plus x. X is for execute. Let me bring up the same command. You can see here the difference. Here it was rw dash then r dash dash. Here you can see this has even execute permission for the end user and the group. Now to be very specific, how we can do that? We have octal value for each of the three sections. 7, 7, 7. Now 4 is for read, 2 is for write permission, and 1 is for execute permission. So all these octal values you can add up. For this first three position, I want to have the read. That means what I read? ch what? I will keep read only. That means 2. Then for it, I will have only execute. That means 1, and third one will have only read permission. Read means again 2. So I give it chmod 212. I just do it for this particular file. Now you can see I have given write, execute and write permission. So you can see write, execute and write. So let me clear the screen. Four is for read, 2 is for write, 1 is for execute. I'll bring up the text again. Now I want to add a read permission here in the first field. Rest of the field I will keep intact. So what will happen? Read is 4, then that means 4 plus 2, it will be 6. So 6, 1, 2. Now you can see that read permission is added. Now I want to add read permission in the second field. What I have to do? Read, we have to add 4. So 6 will be constant. 1 plus 4 is equal to 5. So what I will do? Here I write 5. And ls minus l again. You can see r was not present that time. Here r has came. Now for the third field, add only write permission. I want to change that permission to execute only. Now execute means 1. Okay. So what I will do? I'll change to you can see this is how you can add these octal values 4 is for read, 2 is for write, and 1 is for execute. And this way, in the same sequence for the user, in the group, and the rest of the world, you can change the file permission. Now, I'll show you another way of doing the same thing. Here, I'll add the read and write permission. So first, let me give everybody the read permission. I'll write the same command in a different way. chmod u plus or e plus r others plus r. Then give the write.txt. You can see that I have added the read permission to everybody. That means user, group, and others. If you think that the numbering system is difficult for you, you can proceed in this way. This is much more easy. However, you have to remember the sequence U, G, and O. U means user, G means group, and O means others. Now, let me add write permission to everybody. So you can see write permission is given to everyone. What I'll do next, I'll remove the execute permission from the third field and from the in field. You can see that plus means those things will be added and minus thing means they will be subtracted. That means they will be removed. So here it is plus RW, here plus RW, minus X minus. So here you can see earlier execute permission was there in the two fields here, and then the execute field has been removed. So this way you can maintain the read, write, execute permissions. Modify it a bit more. Here let me remove R and here let me do the minus R. You can see here the read permission has been removed. I want to give everyone the RWX permission. Read, write, execute. Read, write, execute. Read, write, execute. And I do this. So you can see now everyone has this read, write, execute. I'll next remove the permission from everyone. It's a crazy thing. However, we can do it. I replace the and you can see now this file do not have permission for anyone to do anything. I'll change it back to the all permission. So folks, the command chmod I have demonstrated two different ways. One is a octal number system. Here you can see 4, 2 and 1 read, write, execute. You can change is by the value addition and calculation of the position wise, or you can do it in a much more quick way without remembering the octal values, that is these three fields, comma separated fields, where plus means we are adding, minus means we are subtracting the particular permission. Either of these two ways, you can change the file permission of a particular file. So this was the first topic of the advanced Linux command line operations. We are done with this particular one. Let's move on. So I have cleared the screen. Go out from here. The next command we'll be demonstrating is DOS to Unix. So here you can see that the DOS or Windows text file, a line break is there, also a new line. It's a combination of two characters, that is a carriage return, that is usually comes by the enter key and followed by a line feed LF. In Unix text file, the line break is a single character. the line fit elf, this is the difference. Let us not talk about the Mac one. Let us focus on the Windows right now. So in Windows there are two end of line characters, whereas in Unix there is one character. So if you try to process a particular file which was originally written in Windows, or you have opened a file in Windows and copied it into your Linux system, you have to use this binary DOS to Unix. The reverse is also Unix to DOS. The purpose is just the reverse. So here is the text file. It is created in Unix. So in case it has came from the Windows, or you have copied the content from a Windows file into this file, what you have to do? DOS to Unix followed by the file name. So here you can see DOS to Unix converting the file to Unix format. So this way the end of line character as well as many non-printable characters which come under a Windows file. Yes, a text file in Windows does have some non-printable characters. That means you cannot see them, but they still inside the file. So those particular characters will be removed, and accordingly the modifications will be done as per the Unix file system. The reverse, if you want to do, you have to do Unix to DOS, then create the file name. So you can see that converting the my text to DOS format, earlier converting the file to Unix format. So this way, this particular binary helps you to convert this. When you are working in VLSI, base machine is Windows. There you have some file or some data which maybe came over an email. You copy it inside a text file, inside your VNC, and actually inside the Linux. That time when that particular file is getting read by the particular software, it gives some error which you cannot figure it out. At that particular situation, this DOS to Unix binary generally comes into picture. The second binary, that Unix to DOS, is not that much used in VLSI. However, the first one, that is the DOS to Unix, is used in a huge quantity, and most of the time if you open up the file you cannot see the non-printable character, and you will keep wondering what is wrong with this particular file. So that thing you have to take care by this particular binary. So the next command that we are going to discuss is the diff command that compares file side by side. Let me go back here. Let me do ls start.txt. Now we have aa.txt and bbb.txt. If I do if dash y, so here you can see these two files are side by side compared, and let me add a line which is common to them. Let me do the same thing. I have to make one small change here. Now you can see that the fourth line is same and it is still showing. Now if we want to suppress this common line, what we'll have to do? Another error, let me copy it from the landing page. And here. So you can see after giving the suppress common lines, what happened, that the line, the good morning, which was here and here, the same line, it vanished. This is a very primitive binary in Linux. A bit more advanced command, we can use the sdiff command. I'll show you here. Let me clear the screen here. See the man of sdiff. So sdiff is the side-by-side merge of file command. Sdiff, then -s, then I give aa.txt and bbb.txt. So s will suppress the common line. Now you can see the last step that we have done with the diff comes to us in a very easy format. Now if I do this is L. So here it is ignoring that particular line which is matching here. I think the -s is a much better option. Now if I do the capital B, it will ignore the blank lines. And if I do W, it will ignore the white spaces. So these are the set of commands that you can with the sdiff command. Another thing I'll show you here. If you write here I, it will ignore the cases. Here, although both the cases are same, that means lower gaps, in case you have some difference with the case in the both of the files, this I switch will help you to address that particular situation. Let me clear the screen. Next command is tkdiff. So let me show you the manual here. tkdiff is a graphical diff utility. Then how we use that? tkdiff then file to compare two particular files. We'll not go in the deep advanced area. We'll stay here because that area yet not covered the CVS and all. Here what we have used about this two file. Let me use. So you can see that a graphical diff has come here and you can see a lot of color coding is there so that you can see the difference. In actual file when you are comparing, I think the tkdiff is the best option to compare among the three particular binaries which I have shown. However, in some system tkdiff may not be present. At that time you have to request your Unix admin to install it, and meantime you have to use either the sdiff or the diff, whatever you have in your hand, to diff between the two text files to find out what is the difference in between the two text files. That means you side by side you can compare. It will highlight what is the common and what is the uncommon thing there. Let me do that. tkdiff and mytext.txt and text2.txt. So here you can see that up to this in both the files we have the same text. Up to this one is different. So what will happen if you have two different versions of the same programming file or some other file where there is a slight change? So this particular tkdiff will help you to understand where is that difference is like. So here you can see it has marked the red with a highlight. Earlier the two files we are comparing were completely different. However, these two files we have up to this same and the rest is different. So this way the different part will be highlighted by the tkdiff, and since it graphically, if the file is very long, you can scroll up and down, and also you have menus. I am not going in that direction right now. You can see the difference here just by looking. Close it. Next command we are going to do is the xargs. Xarg does what? Build and execute command lines from standard input. So this is nothing but a command that can process the piped output results one by one in sequence. So let me show you how. So here, if I write find dot slash, you must have remembered the find command from the last episode. In case you don't remember, please go ahead, use the chapter and learn this command. I name star.txt, then I give pipe xargs. I write DOS to Unix. So this means now find will find all the text files under this particular directory, that means present directory, and all the subdirectories, and give one by one output to xarg, which will apply the another Unix command DOS to Unix on each of the file. So this means you are on the single go using one particular command from where you are getting a list, and in the next section using pipe and xargs you are applying a second Unix command on each of that particular file. Let me hit it. So you can see it has found all the text files and it has updated all of them with the DOS to Unix. So it may happen that in VLSI you have copied multiple files from your Windows location to your Linux location either by FTP or manually, and all those files in your common area, that is under a particular directory and under the subdirectories, you have to convert them using the DOS to Unix. You can use that. Here in this command, you can give the topmost directory of your working area and execute this. Another thing could be, here it could be a different file rather than a text file, that is human readable ASCII file, like any file, like a C programming file, a PERL programming file, or a Verilog file, or a VHDL file. Any file could be that. So if you hit that, it will find all those files and it will convert them into the particular format. So I have shown you, you can try out like this. You can go ahead and read the manual of the xargs and you can choose what to do. I have shown you a very safe thing that you can do without any destructive operation. Show you with an example. Now we have several dump files. That has unexpected thing when some program crashes and all the dump files are there, right? Now if you use the find command to find the dump file, so you can see these dump files. Removing them one by one, you have to click and then to execute one by one. However, if you want to remove them automatically, all the dump files, so you can see here that all these dump files from different directory and subdirectories which the find command has fetched, they in a single shot have been deleted. In a single shot, they have been deleted using the find and the xargs command together. This is the beauty of the xargs command. So I'll now show you a way how you can run any particular scripting file, like whether it is a bash or whether it is a tickle or it is a perl. Now I'll create each one of these particular files. So I have touched the bash.sh. I am using nano to open this particular file, let me start which bash. So here is the bash, right? And here I write #bang user bin bash as the first line, and then I write echo hello world. I do the save here and then save it, exit. Now I have to make this particular file executable. I change its permission as executable by the command chmod +x, and then I write /sh, and when I execute this particular shell script is executed and it is showing the hello world. Now I'll do the same thing with the Perl file. The extension has to be PL. Let me remove this. Now let me open here. So here first line I have to give the Perl binary, which Perl. So Perl resides here. Let me copy it and give the #bang reserved in Perl as the first line, and then in the next line I type print hello world. If I hit save. So you can see that the syntax highlighting is there. It highlights the print command with a different color, the first line with a different color inside nano. So here let me exit. Let me change the permission. And let me now execute it. So you can see that hello world has come here. Now let me do the same thing for the tickle file. Here let me search for which TCL-SH. This is a tickle shell. Now I'll again do #bang user bin TCL-Sh, and then it's I save it and then I exit. I do the permission change. I have to make it executable, so I write chmod +x, then the file name, and then I execute giving the same file name. So you can see hello world. Now you can see that the shell script has executed, the Perl script has executed, the tickle script has executed. So this way you can make the scripts those use any of the Unix shell like Perl, tickle or bash, whatever you are using. So folks, today I'll stop here. Hey guys, welcome to the 7th episode of Linux Basics for VLSI. Today is the 4th day of the bootcamp where we'll be covering some more of the advanced Linux commands. If you don't know these commands, then you may face glitch every now and then in your day-to-day work in VLSI. You may open up a Linux terminal side by side while watching this video to try out the shown command steps. So gear up and enjoy the learning experience. Hey guys, welcome back to the computer screen. We are continuing with the advanced commands in the Linux, and today the first command I will show you is tree. Let me show you the manual. Now, the tree, by the name, you know that a tree has branches and all. So, the tree command lists the contents of the directories in a tree-like format. And here we can see the tree is a recursive directory listing program that produces indented listing of files, which is colorized if the lscolor environment variable is set and the output is tty. With no arguments, tree list and files in the current directory. With the directory arguments are given, the tree lists all the files and directories found in that particular directory. So here are the switches. Let me show you an example. If you remember, earlier we have created a hierarchy here. Let me go inside K, then P, L, T, then T, right? Let me do a mkdir E, T, and H, m.ex. So here is our file is created. Let me go back to the initial directory where I started today. So here now, if I do the tree, what will happen? And I set the argument as A. If I hit enter, you can see it is showing that this hierarchy down, the directories go. So A, inside there is B, inside there is C, inside there is D, inside there is E. All these directories are there. And E contains a temp.txt. And here you can see the form.mp3. Now let me show you another example. If I go one level up and I do, then I hit tab and only one directory is here. If I do it, you can see here first it is all directories, subdirectories and file. Then it lists up that this directory contains two files. Plain files are reported here. Then folder 1 has song.mp3, folder 2 has song3.mp3, mkdir has song3.mp3 and like that. Now, this is the directory from the beginning we are working on. So let me go back to the exact level. Let me clear the screen. Let me try this particular tree command on /etc. So you can see here it has a long directory. So let me invoke this and I do a pipe less so that I can see the screen. Few episodes back already I have explained this pipe less command. Now here you can see that with the less the color is gone. However, you can see that the etc inside that this is the directory. This is a direct file. Then we have another directory. And we have here another directory and the file. So these are links. If we keep on scrolling right, we see it the way it is there. So let me quit this one. Let me clear the screen. Let me bring up the basic command and let us now scroll in the terminal with the colors so that you can see that how you will exactly get. So you can see here XML directory is there. Here you can see this is a directory which contains two files, and if you go up right, you can see all the directories, subdirectories and file is listed like a tree structure. So I'm scrolling it. So you can see that I have reached back to the top where the command was executed. So this is the philosophy of the tree command. And when we use this particular command, what happens that it lists off all the subdirectories. In VLSI, it might happen that in a particular tool, when it is run, multiple directories and subdirectory structures are created and all those files are kept there. So at that time, you want to see that what files is inside what. In Linux command line interface, this particular command, P command, will help you to see the contents as well as see what type of files are there, because it will colorize for you and you will be able to understand that where these files are there. There is another use of this command. Say you are communicating through email to another team or the customer that your file structure contains this kind of files in this kind of hierarchy. How would you write that? You don't have to do that. You can just execute the tree command on the directory and either take a snapshot or copy and paste whole thing in a text file, and then you can send that text file to the respective recipient. We are done with this particular command. Let me clear the screen. Speak about the alias command. So alias command creates a shorthand command for a longer command that you want to execute. Now, if I write alias so you can see I have used command alias, and this is the next shortcut. And here I have put the command that I want to execute. And obviously this is what I am doing in the TCSH shell. Right now I'm working in the TCSH shell, using it accordingly. I have already shown you how you can switch to the TCSH shell. In case you have not seen, please go ahead and watch the first hands-on episode, that is part 1 of the bootcamp. So let me come back to the point. Here what you can see that this particular shorthand command, whenever I execute, say if I execute LLL, it will do the ls-l. There is a file called .cshrc. Generally, this file is given to you when you work in a company. You don't have to create it by your own. And this file will contain multiple aliases, and you can add your own alias, so that instead of typing again and again long command, you can have your own command that you can execute. Let me show you one particular command which I use here. Let me write which p. So I set alias this p to the clear command. So here you have to give the full path. That is the best option. Instead of giving a just clear, you just write the whole path. So that will be easier for the alias command to execute. Now whenever I hit C, thing is cleared now. This is the utility of the alias. Although the command looks very small, however, its application in a day-to-day life in the VLSI world is huge, tremendously huge. We are done with this particular alias command. There is nothing more to show from my side. The next command I will show you, that is setenv command in the man page. So the setenv command change or add an environment variable. So what is an environment variable? An environment variable is a variable that is within the invoke shell. That is what we do through the terminal, and that value you can reuse multiple times whenever or wherever you call it. Here you can see the description. The setenv function adds a variable name to the environment with the value if the name does not already exist. Okay, and if the name exists in the environment, then its value is changed to the value and override is non-zero. Here you can see. So the exact opposite command of setenv is unsetenv. So if you have set something you want to unset, you can use the unsetenv. Okay, so let me show you hands-on. Type just the pwd to get the full path here and execute. Folks, remember that this is a TCSH shell, and accordingly I am writing the command. If you move on to another shell, the commands will be different. And here I set that is path command. So now another point to be noted, the environment variables are always in the upper caps. They cannot be in the lower caps or the mixed caps. So they must be always in the whole upper cap. This is another tradition or convention we follow, and that must be followed. Differentiate the regular variable and the environment variable. Now, if I do echo dollar this path, I hit tab and you can see that this path is already there, right? So it is showing that this variable is here. Now a question comes that I am new to a system and I cannot locate where the CSHRC file is. Then how I will know what all the environment variables have been already defined? There is a command for that. Let me show you the man page. So this is the command env. This command can be used to find out the environment variables. So here, when I executed the env command, right, you can see all the environment variables that is defined in this system, maybe inside the TCSH file or maybe elsewhere. Somewhere some program might have their own way of declaring. So here you can see that all the things are declared. Okay, let me clear the screen. This way the environment variable has been set. Now, what is the significance of environment variable in VLSI? In VLSI, generally the VLSI tools use a license, and that license path is set by an environment variable. If that environment variable is not set, the tool will invoke, however it will not run because it will not able to fetch the license. This is the reason why the particular environment variable is so much important in the VLSI. Now, we are done with this particular command. So let me move on to the next command. The next command is diff. So the diff command reports file system disk space usage. So that means how much disk space has been used. So here you can see the H command is human readable. I will insist that you use this thing because that clears the value so that you can easily grasp how much space is available. Right now I am in the directory. This particular directory, let me hit df -h and I'll do this for the present directory. The present directory we can call as dot. So I hit it. You can see this is mounted on this particular file system. The total file size is 356 GB, where 271 GB is used and available is 68 GB. So that is used is 81%. This way you can find out that path where you are working, whether that path has sufficient area to run your VLSI tool and generate the output files so that your program do not crash. So this is a kind of preventive measure to check for the available space before you hit the running of a tool, because in VLSI multiple tools use huge amount of disk space, and if you do not have the disk space, the program will crash in between. Then you have to again do the root cause analysis and all, and unnecessarily your time will be wasted, LSF machine will be wasted, and you will be not able to achieve the deadline. So this way, this particular command will help you to judge the disk space, and you can start working at in a particular area with the tool and the required disk space. In case you don't have a disk space, you can go ahead to your Unix admin and ask that please provide me this much amount of disk space which I need to run for this particular tool. After you get the allocated disk space, you can run your tool. Accordingly, your output will be there. So we are done with this particular command. Let me show you the next command. The next command is DU. So this does the exact opposite. This is the estimate that how much space is used. Earlier you are getting how much space is free. Now if you execute this particular command, DU -h, and then I give this particular directory. Okay, let me give my own working directory. So you can see that how much each of the folder is occupying. So this folder is about 4K, that is KB. This here it is 8 KB, 12 KB, 16 KB, 20 KB, 4 KB, 88 KB. Okay, so all these things it will list up. So this is a very fair and simple use of this particular command, and this way you can take a directory size before you want to shift this entire content to another workspace, or you want to archive it like a zip or tar or something. Then you might have an idea that how much compression is going on before you can send that tar or zip to your other part of the team or the customer, whatever is applicable in your case. We are done with this particular command. Let me clear the screen and move on to the next command. The next command is another system command that displays the amount of free and used memory in the system. Memory, I mean to say memories, not the hard disk. That includes both the RAM and the wap memory. So let me execute it. I always use the -h so that everything comes in human readable format. Here you can see memory, this is RAM. I have almost 8 GB of RAM in my machine, and 1.4 GB of which is getting currently used now. Free is 3.5 GB and shared is 21 MB, and buffer or cache is 2.8. Okay, available is. This way this distribution is happening, and the swap file is 27 and used is 0, and B is the entire one. So both these memories, their status is given to you by this particular command. Let me clear the screen and move on to the next command. The next command is wget. So wget is a non-interactive network downloader. So it's basically a download manager. You have already seen in the first episode where I have used pre-download manager for the graphical user interface. This is a command line download manager. You can use it for downloading programs. Let me show you with an example. So here I have kept .url. So this is the download URL of the Google Chrome for Linux. Use wget to get this particular file download to my local directory. So you can see it is proceeding, and let me interrupt it in between. I have hit the Control C. So the download has been reached to 24%. What can happen that you are downloading and due to some network issue or power cut, your download get stopped at say 24%. What you will do? You will again do the same command and you will add a -e command. And you can see it has resumed from that particular point. Let me interrupt it again so that you can see it once more time. So you can see it is 59%, right? Let me hit the command again. You can see here it again starts from that 59% in it proceeds. So you can see we can resume a download. So here the download has completed. So you can see that it's a perfect command line download manager which can even resume an interrupted download. So this is one of the pretty much used tool in the Linux command line to download files. Maybe from your, right now we have, it could be any file what you want to download from another URL. So let me clear the screen. The next command we are going to try, that is tar. Tar is archiving utility. I will cover in the subsequent section all the archiving utility. First one, we are starting with the tar. So here you can see tar is an archiving utility. Now here are all the switches. You can read by yourself and then you can go. I'll show you directly with an example. So you can see that this particular directory AAA has the two files, that is a.txt and b.txt. Make a tar file of. That means I will compress this directory into a tar file. tar-tvf. P means create and V means verbose. This is for a regular file. Also here you can see that the example is here. I will type tar dash evf, then I will give the name of the tar file first, the target file aaa.tar, and then I will provide the directory name. So you can see it is verbose and it is creating tar file. T for create, and if we change the T with X, we extract that particular file. Let me show you. So you can see aaa.tar has been created. Now I want to extract this aaa.tar. So I change C with X, and this is sdiff. For you can use any sequence, that is FBX, PFX, whatever you want. You are not restricted. You can combine this later. The best way you can remember. With that note, let me move on. XVF, and here we keep the aaa.tar. So you can see it has extracted the files now. Now, in some case, you have a situation where without extracting a particular tar, in some situation, you have to see what is inside. So at that time, what you will do? You have to tar minus tvf. You can see that if I write this, it will not extract anything. It will just give a ls inside the tar file. So here you can see it will show the permissions here, and here you can see what files are there inside. So these are not extracted by the tvf command. CVF is used for creating, XVF is used for extracting, and dash TVF is used for just viewing what the content is without any extract. Now another thing you can do, that file.txt. We have done this operation so far on a directory. Now imagine if you have a file which is of gigabit size and that you want to compress. You can use the same command. sdiff, then file.tdiff txt. Now let me do the alias tar. Here you can see that it has been created. In the same way, you can extract this particular file or view what is the content using either the CVF, XVF or TVF. So these are the three switches. Example of tar is done here. Let me clear it. Let me show you the next command. It is zip. So gzip is the command which does zip kind of archive, and we can combine it with the tar so that compression level will increase. Now let me go here. If I want to combine this tz, increase the compression level, what I'll have to do? R S T V Z. So you can see I have added the Z in the tar, and then I write so here I have created a tar.gz. Sometimes this is also written like this, tgz, just to tell you that tar and gz has been combined. This way the creation is done, the extraction is done in this way. So here the XVF earlier was there, we have added Z, so XVZF is done here. You can use any kind of combination for your remembrance. Let me show you the example. Here let me extract this particular archive. So you can see that this particular archive has been extracted. Now I want to just see the contents, but I do not want to extract the contents. What I will do? R minus TVZF. And here I give this name. So here you can see again, it will list up the files inside. So I have shown you the particular way of dealing with archives: creation of an archive, extraction of an archive, and viewing the contents of an archive without extracting it. These are the three very common things that we generally do with the compressed file before or after. Let me move on to the next particular command. This is for the zip archive. In Windows, you have so far used the WinZip. You are very much familiar with WinZip and the .zip file in Windows. In Linux, we also have the zip format. That command line, we use the zip binary to compress particular file, and we use unzip command, this one. Unzip command to unzip it. We use zip command to zip it and unzip command to unzip it. This is a bit different from the last known command. Let me go here and add the zip. I am compressing the AAA into a zip archive. So you can see here, let me do the ls. So you can see that AAA zip has been created. Now I want to extract the zip file. What I'll do unzip AAA dot zip. So you can see that it has been. Now we come to the third kind of operation, that we have a zip file. We do not want to extract it. However, we want to see the content of what command we should use. We will use the unzip with argument -l. Here you can see it has listed here all the details. So you can see what is the content here without the fraction. This is the command, and with that particular note, we are done with this particular command. So you have came across 3 uses, that is archiving, extracting, and viewing without the extraction. So let me clear the screen here. I am using my alias C here for the clear, if you remember. So the next command I'll show you is the rar command. Yes, this is in Windows. You are familiar with the WinRAR. The same RAR archival process is available in Linux with the rar command, and we have the exact opposite with the unrar command. So now by this time you have already related that the tar, it has a different way of operation, and the zip and the rar has a different way of. So zip has zip and unzip, and rar has rar and unrar. However, for tar, the same binary is used for extraction and the creation. Here let me exit and let me show you with an example here. Here, when we are creating a rar file, we have to give an argument. However, in this rar, we don't have a dashed argument. That means we have only a letter. So here we have to use a, and then we have the directory name .rar I give, and then I give the exact directory name which I want to compress into the aaa.rar. So here you can see we are using the A to add. So you can see adding is done. So A is used for adding the files into a archive. The archival is done. Now we want to extract the files for this rar. What we will do? Unrar, then we don't have the dashed argument, we have the only letter. So extract is E, and we will use aaa.rar. So it is asking whether you want to replace the file. I say yes. Yes, you can see this is the process of creating a rar archive and extracting a rar archive. Now let us move on to the third option, that is to view an archive without the extraction process. Let me clear the screen. Unrar, then L. L is used for listing. I am writing aaa.rar. Now again I am emphasizing for rar we don't have the dash argument, we have only a letter which signifies something to the operation, and here L is listing. So here you can see when we give without extraction, the entire listing of the files inside is done. So here you can see the archive name is the version. Here everything is about the version and the software, okay, and here you can see at this section the files and their permissions and blah blah blah, everything are even here. So this is the result without the extraction. We have come to the end of today's episode here, and I would like to tell you that this archiving process and extracting process and view the archive without extraction process, these processes are very frequently used in the VLSI domain. In Linux, mostly the tar.gz is used. However, nowadays you will see the zip and the rar options also. The tar is a old age option which came with the primitive Linux, and then as the time progresses, the zip and the rar also have been added. With that note, I'll conclude today's episode. Thank you for watching. Hey guys, welcome to the 8th episode of Linux Basics for VLSI. Today is the 5th day of the bootcamp where we'll be covering some of the expert level Linux commands. With these commands, you will operate the Linux like a pro. You may open up a Linux terminal side by side while watching this video to try out the shown command steps. So gear up and enjoy the learning experience. Hey guys, welcome back. Today we are moving towards the expert pro level commands that you can use in your Linux system. The first command we are going to try today is ps command. Here you can see the ps command report a snapshot of the current processes. Now, what are the processes? Processes are the different system softwares running in the background to keep you ready for all the user application softwares. Let me quit the manual and we'll go back to the left terminal, and here let me show you the command plain and simple use. So here you can see the ps command is executed. Now the ps command has 4 columns. PID. The PID is the unique process ID. So for each different system software which is running, there will be one unique process ID. So here you can see this is the process ID for TCSH and this is the process ID for the PS itself. The process PS also calls a system process and hence it also has a PID. Now the next one is TTY. TTY means the terminal type that the user is logged into. Here it gives the time, that means the CPU time, that in minutes and seconds the process, that means this process, is running. Next comes the CMD. Now CMD is the name of the process or the binary command that either you have run system command or it is running in the background. We are done with the example. Here the plain and simple example you can see here, and let me now move on towards some more detailed examples. Now we want to use PS and we want to see every process on the system what all are running. So here you can see the command. Let me bring up 5 less. So you can see that there are several process IDs are there. I think here it is increasing one by one, and you can see all the system process or the binaries which are running for this one. So you can see the number is increasing here, and here the separate different binaries are there which are the part of the OS, and mostly these are the system's own process that is running for the kernel to keep your system ready for running any user application software. Let me quit it, and similar we can see with the E here. All these next few commands I will show you almost similar. They give the similar result. Why I am doing this? Because you may came across someone is using one and someone else is using another one. So you may get confused. So hence I am showing all the usage so that you know which one is running by someone or by you and you can correlate. The next one is PSEF. So here you can see that there are a couple of more columns also got added apart from the basic columns. Let me quit it. Rest of the things remain same. So here you can see some more columns are also getting added. Here, quit it again. Some more columns are also added here. So these are the couple of commands from here to here. If I highlight. So all these can give you the list of the system processes that are running. That means the process which are directly linked with the kernel. Let me clear the screen. Next, in the ps command, we will show you the variant of the ps command that is used for listing up the process those are related to this particular terminal which we are running. Here you can see only 2 are running, that is TCSH and PS. These two, we turn on I have turned on JVim. Let me minimize it, and now let me execute the ps-t. Now let me see what are all the running processes are there. So I'll give ps dash r, only a single command is running. The next command gives you the process that is running by you. That means the user who is right now operating. You can see. So these processes are running there for you, and that's the definition and the example. Here the screen. The next command will show you to print a process tree. Let me add yes. So you can see all the process are shown here. Now let me move towards the next command. In the right hand terminal, let me type. So it is to display the Linux processes. Now you will tell that we are using already the ps command. Now what is the difference here? Know the answer, you have to see it. Quit it here. Go back to the left hand side terminal and let me execute the top command. Here you can see how much percentage of CPU is there, how much swap is there. All this data is coming, and let me explain you what all these columns means. The PID here you can see shows a task unique process ID. So the unique process ID is shown by PID, which was also there in the PS. Now here we can see there is an additional column that is for the user. So you can see my username is MSG, and there is also a super user root. Both are there. Now next column is PR. PR means for the priority of the task, how much priority this task had. So you can see in the top nothing is static, everything is dynamic. So it is changing, because in a real system there will be priority of task. Once one task has executed, it is deprioritized and other priority tasks are going up. So that's why you can see there is a lot of change and up and down here in the priority column. The next column is NI. NI represents nice value of the task. Negative nice value implies higher priority. Now positive nice value means lower priority. So here this is a negative value, means it has higher priority, and here it is also negative, that means it is higher priority, and here it is positive, that means it has a lower priority. So the next column is vert. Vert means the virtual memory used by the task. The next column is res. Res means anything occupying the physical memory. Next is SHR. It represents the amount of shared memory used by a task. It is a subset of the res. Next comes the percentage CPU. Represents the CPU usage. Next comes the percentage mem. Shows the memory usage of the task. Here is time. Time means the CPU time. It is counted as the unit of hundredths of a second. And the final column is the command. That means the binary which is running. That is the definition and the description of the top command. Now you can see in PS, if I type PS here in the right hand side, you can see PS is a static entry and it gives a static value. Whereas the top, you can see this is a very dynamic process and everything is moving up and down and prioritizing, deprioritizing, everything is happening. Now, this was the general top command. So let me quit it. Once you exit, right, the screen which was displaying to you, it fixed there and you come out of the display. Let me clear the screen here. I use C as an alias for clear the screen command. So here, the next is I want to specifically run the top for a particular user. So here you can see my username is MSG here. So top dash U, and then I type the username MSG. You can see that it lists up the processes for the username MSG only, because if you look in this particular column, there is only MSG. Earlier it was a mix of MSG and root. Now let me quit it and clean the screen. In place of MSG, let me type root. Here you can see the root user is only there, and you can see only these things are getting displayed for the root user. That means all the system or kernel process, those are running, that is for the root user. If we quit it and in the screen, now let me show you another option. Here I have run the plain top command, and if I press T, what happens in the right hand side, you can see it is showing the real-time path of the binary here. In the rightmost column, in the column which is entitled as command, here you can see it is showing the full path, the full binary path instead of the only the binary name. So this is another addition of the command that you can use. The next command I will show you is the kill command. Let me show you the manual. So the kill command sends a signal to the process, kill it. Now this is a very similar command or similar process that we do with the Control-Alt-Delete in the Unix system. Now this is very similar process to the Control-Alt-Delete operation in the Windows. Now in Windows we have GUI, whereas in Linux most of the things are terminal wise. So here we are using the terminal, and let me launch a process and check. So Audacity is launched. Let me now go back to the terminal here, and since I am the user MSG here, let me invoke the top command with the user in. And when I press the C command, here you can see the Audacity which is running. I want to kill this particular process. Let me exit this using the Q command, and here you can see this Audacity has process ID 8385. So what here I need to do, type kill-9. So it sends the similar command like Control-Alt-Del, and the 9-9 gives the strongest kill command so that any process will not survive operate kill-9 on that particular process ID. So here I take copy of the process ID and paste it. Now here is Audacity is running. If I hit this, immediately that process is killed. Now the Audacity has been sitting. If I run again the top command, Audacity is gone from this list. That means whatever binary I want to kill, I can kill it using the kill-9 command. Sometimes we launch a VLSI software to the terminal. Maybe we are using it as a GUI, or maybe we are using underlying. But due to some reason, it hangs or freezes, whatever term you can use, and it is not working, which is the bottom line. Now, at that particular situation, what will happen that you have to kill that process, and that time you have to use the kill-9 in the process ID of that particular software that you are running and terminate it so that you can reinitiate the same process or same software. So we have came across the top command. Now I'm going to show you a bit more advanced command, htop. In case your system do not have it, you can use the sudo apt-get install then htop. And let me proceed with the htop command. Before that, let me show you the manual. Command h. Here you can say htop is the interactive process viewer, and there are a lot of options you can explore by yourself. Let me directly go to the example. I type htop. You can see here a nice environment has been opened. So you can see here are 8 CPU cores in this particular machine, and you can see how much those CPU cores are currently being used here. So the representation of htop is more colorized and user friendly here as compared to its ancestor top. Here you can see that PID is here, user is here, PRI is here, NI is here. Now if you take it, it keeps on going and it is segregating everything. And here you can see how much memory is being used. So you can see 1.91 GB of 7.7 GB is used. 7.7 GB is the RAM capacity of this machine which I am right now using. And it has a swap memory that is 27.9 GB. It has 27.9 GB swap memory here, of which storage 2.54 MB scale. So you can see how many tasks are running here. All these things are ongoing. So here another good part of the htop is that here at the bottom you can see F1 is for help, F2 is for setup, F3 is for start, and F4 is filtered, F5 is tree, F6 is sort by, F7 is by nice, minus and nice plus, and F9 is kill, 10 is quit. So let me here launch the Audacity again. So here you can see the Audacity is here running. The beauty of the top, graphically if you select it and then if you hit F9 here, if you hit F9, it will launch the tick term which is happening in the background, and if you hit then enter, you will see enter to send and escape to cancel. If you hit enter, Audacity is closed. We'll go here. Is showing terminated. So this way the htop is much more up to date and easy to use version of the top. Graphically you can use with the menu at the bottom. You can easily choose what to do and accordingly you will get the visual navigation as you have seen. So this way you can use the htop. So another thing here what you can learn as a next command is the uname command. You can see here uname print the system information. All the commands that I am showing today are related for your system or kernel, that means the expert pro level command. Uname I am going to demonstrate to you. If I type uname -s, it is going to tell you the kernel name. So here it is Linux. If I type v, it will show the version. You can see this is the Linux kernel version. Now if I type m as a switch, it will give the architecture name. Now, if I type P, it gives the processor architecture, which is same as the machine architecture. If I type O, it gives the operating system type. So it is GNU Linux. Linux is the kernel and the GNU Linux is the OS, that means the distribution. If I type I, again, it is showing the hardware architecture, which is same as this. Now, the next command is uname-a. Here you can see that it is Linux and this is the machine name. You can see here is similar to that, and you can see this generic, and you have seen this version right here. Or here you have seen, here is the architecture. Finally here you have seen the OS type, and that is it. So the last one is a all-inclusive one. In case you are aware of all these fields which I have, if you have all of them in your mind, you can just go ahead and put uname-a to know all the details at once. With that particular note, I will move on to the next command. The next command is emesg. Now this is a very different looking command and it is used to check the boot time messages. So here you can see emesg print.control the kernel ring buffer is saying nothing but the time when the Linux was boot. At that time all the messages are logged and that particular log is shown to you by this command. Let me go here in the execution terminal and here let me type emesg. So here you can see all the command rows have been executed one by one during the boot. So you can see this CPU part and BIOS and all those things. Earlier days, maybe 10-15 years back when the Linux was booting, you can see all these processes will show one by one. Nowadays that has been replaced by a pin animation which you see when you put up the Linux machine, and all these are logged in a background log, and from that particular log we can see all these things using the command dmes. Now let me bring up this, and if I add -h, it gives the human readable format. Here another part is that once you execute -h, gives you a pipeless type of environment. If you press the down arrow key, you will go and you can see it is much more easier to read now. Earlier it was some kind of scattered or some format was not very easy to read. Now this particular format is very easy. In case you want to see what happened during the boot or any particular process did not start during the boot, all this data you can get from here. So this gives -L, which gives the colorized output. However, in this particular machine, it is default, so it is coming already. Even we do not give. In case you are operating on a remote machine or somewhere where the color is not set, so you can use this particular that means DMESG with the -L command. The next variant I am going to show you is that with the -T, that means capital T command. So here you can see that all the timestamps are modified as per the human readable format. So this is the purpose of the -T. Now all the boot commands are listed. You want to specifically filter out some of the commands that you are looking. I'll give some of the examples. So SDA is the hard disk path or the partitions, as you know already. If I want to check during the boot what happened to different partition, I execute this command, the dmessage command, when we print the boot log, and from there we are ripping out the SDA. So here you can see that all those SDA related command filtered here for us. Now instead of SDA, if I want to see USB, so you can see what the USB related stuff. So it is different. Let me clean the screen and run the USB again. All these processes are for the USB. Clean again, and let me show you another example here. Memory. So you can see all the memory related boot data has been filtered to you. Again, you can use get command with you want to see the first 10 lines or for the last 10 lines. This way, with the help of the tail command, you can see the first required number of lines or last required number of lines from the boot log. So let me clear the screen here and let me move on to the next particular command. ID is the next command, and it prints real and effective user and group IDs. So if you are working in an environment where multiple users are there and multiple groups are there, how you can see that your user ID belongs to which particular group is using the ID. So if I type ID, you can see here is my username and user ID is this, group ID is this, and groups which are there are displayed here. So there are a lot of groups. So as I have talked about the groups command, let me show you another command, that is, say you are working for a team, say front-end team, and then you want to work for a DFT team. So they will have two different Unix groups as per of the file permission and access to different locations. So if you want to change the group, that time you have to use the chgrp. Here I cannot show you an example as there are no such separate groups are defined here. You have to survive with the definition only. In actual case, when you are working in an office environment, there in case you are shifting from the front end to the DFT, that time you have to change your group using the chgrp command. With that note, let me execute here. Let me go here. The next, I will display all the CPU related info, and this is not a command. This is a file which is staying inside. This is location which we will see using the cat command. So it is the proc in CPU info file. So if I execute, you can see all the details about this particular processor, or all the cores are shown here. Let me execute this command with less. So here you can see processor, this is model is Intel, okay, flags are here. And if I go down, so it was the first core it was showing. I have 8 cores here. So if I go down, right, 1, 2, 3, 4, 5, 6, 7. Okay. So this way, 0 to 7, that means total 8 core has been shown by this particular command, and all the details for each of the core has been displayed. Let me execute. So in this same path, another file is kept which is called memory info, and let me use the less. the beginning. Once you execute the mem info, it will show you all details about the memory. Total memory is how much, memory free is how much, memory available is how much, buffers are how much, cache is how much, swap is how much. All those details about the entire memory of this system, including everything, that will be shown by this particular command. That means the combination of the cat command displaying the mem info file and the list. So folks, with that particular command, we have reached to the end of this episode. Hey guys, welcome to the 9th episode of Linux Basics for VLSI. Today is the 6th day of the bootcamp where we'll be covering some more of the expert level Linux commands. With these commands, you will operate the Linux as a pro. You may open up a Linux terminal side by side while watching this video to try out the shown command steps. So gear up and enjoy the learning experience. Welcome back guys to the computer screen. In today's episode, the first thing we are going to explore is the .cshRC file. So I have made a copy here in my local directory of the .cshRC file. Let me show you. I'm using gwin. I made a copy, so I did a .copy extension here for this demonstration purpose. In actual case, this .cshRC file will be there in your home directory when you are working in a company. And there, this particular file pre-exists. That means you don't have to create it. It will exist there. And you can add some of your own commands or aliases there or any environment variable. So let me show you. So you can see just here the cshRC file start. Usually here at the first section there will be the environment variable definition. So you can see here the path variable is here and we have appended some more paths, like this is an additional path and this is an additional path, so that if I try to use a command where it searches all the paths, those are listed in the path. The path is basically a list here, and at that time which will search inside the list path and it will go each and every directory that is included as an element of that particular list and find whether that particular binary exists inside any of the mentioned path list, or you can say array. In the PERL episode, I have shown you these two particular variables and their meaning. When we are declaring a PERL module, we must also mention these particular leaves where we are keeping our module. So I kept the PERL modules defined by me here, and that's why I have added them. Editor is a default environment variable which defines default text editor. Here in my case I have gwin as I use it as my default editor. This is a dummy I have created for you. This is usually the LM license file you will find when you are working in the VLSI industry. The license file are set with this particular variable, and there will be some similar variables too where the tool license will be stored. So generally there will be a path in a remote disk where the license exactly will be there, and this has to be set. Otherwise the EDA tool you are running, it will not run. Here is the history, file size, etc. and history size. These are default. You can set them as you can see. And also here I have kept a particular file here and associated it with the environment variable history file. Now this way you can associate many of all those stuffs that you can relate with a particular environment variable. Here in the first section there is an XML parser which I have created here. These are another installation directories. So ibus is font processing unit, so I have set all the environment variables related to ibus, and such typical environment variable section will be there in case of your .cshRC file. I'll suggest that you keep a backup of your cshRC file before you start editing it, because if you do a kind of pattern mistake or something, you will be able to restore the original file. Now let me move on to the next section. Here you can see I have defined a lot of aliases. Now you can see the commands are very long, and for them I have created alias. Here you can see here is the VHDL simulator. GHDL is there. So for synthesis it is -s. So I have shorthanded it with VHD sin. This is another shortcut, and this is for elab, this is analysis, okay, this is for simulation, and this is for cleaning. So all this stuff. So this way you can create a shorthand that you can type easily in your terminal, and that will help you to get or the jobs done faster. So here a lot of other aliases have been defined. You can see that I have alias PERL help with ph, and this way I have a command is shorthanded ph. With all these things I have shown you, generally these things you will edit, and if there is some system level thing or this admin level thing, will never touch them. That is the general guideline. So here you can see that these stuffs and these stuffs, aliases, that means set environment variable, that is setenv, and the alias, these things you will only play with. So let me close the file now. The tour of the TCSH file is done. If you have any question, please write down in the comment section. Now I will open a terminal which checks the manual. The command we are going to try out today is the time command. This runs programs and summarizes the system resource. What this binary does, if you run any binary under this binary, it will list out all the system resources that has been done. You can go through the detailed description to understand what all things come here. Let me give you a short and sweet example here. If you remember, I have downloaded the Chrome using this particular URL, so Chrome Debian package. So let me execute the same wget command under time. So time, then wget, and here we are done. So before doing any execution, what you can see here is a time command. Here time, then wget, and then URL what it has to fetch. So let me execute it. Now you can see that the wget is proceeding as usual, and in the meantime the time binary will calculate its resources. So the entire execution of the wget and the time is done, and up to this line is the output of the wget. Here to here, it's the output of the wget. And at the last line here, we can see that the output of the time command. And here you can see that the completion time is approx 12 seconds, which it has done. The purpose of time command is just to show you the runtime, and hence its name is there. And I have shown you where you can find the time. Here it has completed almost 12 seconds to complete the entire wget operation. We are done with the example of time. Let me clear the screen and move on to the next binary. The next binary we are going to try out today is LSHW. LS means listing up, HW means hardware. So this command basically lists the hardware. So you can see the name as it suggests, LS and HW. So list hardware is a small tool to extract detailed information on the hardware configuration of the machine. It can report exact memory configuration, firmware version, motherboard configuration, CPU version, cache information, all those things. Let me demonstrate you one by one how we can use this command. Here I am generating a HTML file. The output will come as a HTML format in the screen. I am using the T binary to pass it to the index.html, on which the data, which is the outcome of this command, will be stored to T. Now let me execute it. So you can see that T does the print on the screen, as well as it redirects the output inside the HTML file. So let me clean the screen, and this is a pure HTML format. I have launched the Firefox. Let it open. So here is the path. Let me get the full path. This is the full path of copy and put it inside the Firefox. So here you can see Firefox is reading this index.html. So this is the correct HTML format because it is getting browsed by a web browser. And here you can see that the computer which you are using, it is having all the detailed information through this particular file. So here you can see the CPU, it is you type the manufacturer, the capacity, the width, all those things. So here you can see the PCI bridge where the PCI slot is there. You can see the VGA graphics card here, CPU box, and connected to the motherboard. So here is the USB controller. Okay, lot of stuffs like the SATA controller which controls the hard disk. All those things are there. The Ethernet card, you can see that the Ethernet card which connects to the internet through the LAN cable. So that is here. All these informations are there. Now, why we need this particular, let me close this file and then tell you. So the reason why we use this particular command and generate the file to check, because when we are working remotely in a Linux machine, how we can visualize that what are the configuration the machine has. So you have logged into a remote machine. However, you cannot see anything about the machine. How you know that how many cores the CPU has, what is the RAM size or any other that you may require as a resource usage, maybe when you are launching a LSF command or you want to launch some GUI based VLSI tool. So at that particular time, you will need this particular command. You will need this particular command to list out all the hardware related information to cross check whether you have a correct machine or not. Now let me bring up the command again. So here HTML, another format can be XML. XML is generally used by different XML parsers and programs. As a human being, we do not read the XML. Let me here change the extension as XML. So here if I hit, you can see the XML is generated. Now if we have a XML parser which requires this information, we can pass on this particular say index.mn. So we will pass this particular XML to the respective computer program. This is also done. Now we have gone in the detailed way where we have dumped all the. I will show a more quick way you can quickly see in the terminal itself. So it is. So if I use the alias HW, then short, it will give a short and sweet description of what all there inside the physical machine. So you can see here all the hardware related information, including the audio controller, CPU, this is RAM, this is processor, what is the bus, then storage is there, PCI controller is there, Ethernet is also there. So all those things are there. Here is a wireless interface is connected, okay, with the Wi-Fi connector is also there. So all these things are detailed, listed out, however in a very short and sweet manner. You can see here the graphics card is displayed, what is the GeForce graphics card this machine has. All those things are listed out. Let me clear the screen and show you another quick way of seeing the what are the buses. Bus info. So this bus info gives all the system bus related information. If you require any bus related information, you can execute. Clear the screen. Now I will show you how you can do a classification wise bucketing of the data. So for that, I will use the class command here, and if I type network, it will display the network related information. So here you can see the Ethernet controller is there, or the wireless connector is there which connects this computer to the Wi-Fi. This is for network. Now let me clear the screen, again bring up this. I change it to storage. So you can see here it is the SATA control disk. So it is the hard disk is connected to the SATA cable, and here it is giving the detailed info. Next we do the memory. Now here you can see that how many memory is there. So this might be a very frequent use for you when you are logged onto a remote machine. Hard disk is okay, you can check with the other commands how much space is there. I have already demonstrated it in the last episodes. For checking the memory, this will help you that how much memory is there. With this particular example, we are done with this particular lshw command, and let me clear the screen. Next we will look into the command that is a kind of text processor. So before that, let me do the ls. So these are the text files. Split a file into horizontal pieces. Now refresh this thing in a more rational way, because when we try to split a file, we generally move the row wise. That means if we want to keep 4 lines, that means we are keeping only 4 rows. So it's the file or the content of a file row wise. There will be another subsequent command where I will show the column wise separation or split. So now let's look into some examples here. You can go ahead in the definition and see what all are the things. So first what I will do, let then dash L. This gives the line number, how many lines or how many rows I want to have in each segment. And I will add one more flag here, dash E, so that I don't get any file with 0 size, that means with 0 rows. So this will take care of. So this dash E will take care no file with 0 lines are split. I'll pick up the test.txt from the above list of txt file, and I add dash verbose. Verbose means it will speak what it is doing. You can see creating file XAA and XAB. These are 2 files are created. Let me add the XA. So here it is the first part, and add this. So this entire file, if I cat the original file, you will see it has 1, 2, 3 parts, and which are split into 2 parts by this particular command. Let me clear the string, and it has become cluttered. Now let me add a name. That means instead of AAXA, I will give a specific name. I give a prefix it by part. So here what will happen, let me now change the line. 2 lines per file. That means 2 rows per file. So the first one will not generate any file with 0 lines. Second is controlling the number of lines per file. This is the input file, and this is the output file prefix. Means whatever added after that, it will name accordingly. And the verbose is for the screen message that comes out while it is executed. So here you can see there are 3 split has been created. This is the first part. You can see that since we have given this particular prefix, you can give any prefix name. So after that, AA, AB and AC has been done. I am not going in showing the content because I have already shown you how the contents looks. The next command we are trying out is cut. One is split, another is cut. Cut will do the column wise cut of the file. So you can see cut remove the sections from each line of files. You can go in the detailed description here, and let me show an example that helps you better to understand. So I have here file.txt, which is nothing but the ls-l command. The output I have captured here. Here you can see this is the first column, then the second column, then the third column, then the fourth column. Likewise, the columns are there. I'll use this command. Cut, use the dash D. D is the delimiter. Delimiter is space because it is space separated. The columns are space separated. Then I give the file name. And then I give the dash F, means whichever columns I want to see as a out. So let me see the first column. So you can see the first column has come. Now if I add more columns, then I add 2, the second column has come. Now if I want to see the third column has come. Now this way if you proceed, it will keep on adding the column. Now I have given the columns 1, 2, 3. If I want to remove these columns and I want to see the rest of the things, what I will do? So I'll add a switch called complement. It will print out the rest of the file. It has removed the column 1, 2 and 3 and kept the rest of the files. Let me show you once again. If I remove this command, it gives the first 6 columns, and if I give the complement command, it gives the rest of the columns. So this way we can split a file vertically. Obviously there has to be a delimiter, we cannot abruptly split it. So the split command and the cut command, they do the horizontal splitting of a file into segments and the vertical splitting into the segments. So you can redirect these outputs into another file and store them for your use. Let me see whether I have any CSV file. Yes, I have a data.csv here. Now I will change the delimiter here. So in this command, I am changing the file name. Here you can see the data.csv, and I am changing the delimiter. Comma separated file, so I am using the comma. So if I hit the first column, now if I do the cat and data.csv, you can see there are several columns. You can see here. Let me clear the screen and bring up the cut command. So this is the first. Then if I give 1 and 2, it will add 2 and 1, 2 and 3. So third column is added. Now if I want to see only the third column, I give 3 and it comes out. Now it's very easy if you have a CSV file. If you want to extract one particular column or 2 particular columns or any column, how in the order, whatever you want, you can use this particular command. 4 and the fourth column come. Fourth column, there are a lot of blank elements. So you can see it is coming as the blank. So we have only 4 columns. So here we will stop and in the screen. So we are done with this particular command. Let me move on to the next command. The command md5sum. It generates a hash key. Basically, the hash key is a kind of hash code that is generated against the content of a file. And why it is necessary? Because electronically, if you are transmitting a file through FTP or secure FTP and the recipient receives the file, how that person can judge the file that he has or she has received is authentic one. This is one method to verify the checksums. So here you can see that verifying the checksum. Let me execute the command md. So here you can see it has generated a hash key which is unique to this file. And if I change the file name to tar, you can see there is also a tar file with the same. And if you see, this hash key is different from this hash. So 2 files are not identical and their hash key is different. How to keep this record? A redirection here. file.md5. I have kept it, and for tar I give the tar file dot. So I have stored these in a output file. So let me use the cat command. So you can see here this actually output has been stored. Now when we send this particular file through secure FTP to the intended recipient, separately we send this MD5 file which we have just created like this. So once that person receives the file and downloads the file, it may happen that during downloading or something the file may have got scrambled inside, is not intact. How he or she will check? So at that end, once the person receives the file, this particular file, or we can send it the line by email and ask him to verify with saving this file, and this way the person will verify. -c we give the file.md5. The recipient also to have this md5 sum binary at his or her end and can verify this file is okay. In case this file has become corrupt due to some reason, this will be not okay, because that time the hash will change, because 2 different content then has 2 different hashes and it will message out it is not okay. tar.md file. So here you can see the message file.tar is okay. So this way, if you create a checksum to check the file is intact or not corrupted, so this way you can create a checksum, send the checksum hash key to the person and who is the recipient, and the recipient will check the file's content with this md5 command. This is basically a way of checking the digital sanctity of a file which is transmitted across or via the internet. We are done with this command. The next command that I'm going to demonstrate here is the encryption command. I'll show here the basic encryption. When you are inside a company, they will have their specific encryption key, and you can use this knowledge that right now I am going to share to you to encrypt or decrypt your files. Here you can see it is an open encryption and signing tool. Now, the file we are sending across the internet can be checked through the checksum. However, we can do a encryption so that the data remains secret. The previous command and this command can be combined. However, they can be used separate. Better you learn them now in a simple fashion so that when in actual need, you can use them. So let me quit the screen here and let me show you an example. Let me ls tar. So here you can see that aaa.tar.gz is here. So here let me give the epg-c. What it does, ask for a passphrase. So you can give any 8-character long passphrase. You have to remember it because when you are decrypting, you have to use the same passphrase. I have to enter it twice. So after I have given the passphrase, it has been encrypted. So let me do the alias tar.ppg. So you can see this file has been encrypted into the .gpg extension file. Now this is an encrypted file. Without decrypting, you cannot use it. Here, since I am using the same terminal, my passphrase I think has been saved here. So let me, before that, let me move this file, otherwise it will overwrite. Okay, let me now pg then test. So here you can see this has been decrypted. Now if you send the file over the internet to someone else, you have to also give that person the passphrase. So here you can see here it is decrypting, and here it is saying the algorithm with which it has encrypted, and here it has decrypted the file. This is a very simple use of this command. However, once you enter the company, they will have different level of encryption. It could be AES, it could be RSA, it could be combination, whatever. That time they will also have their key, specific key, that you have to import that key instead of passphrase, or there could be a combination of the passphrase and the key. Those you have to use there. So this is, I think, basic learning that you have to learn here so that you can use them in actual practice once you enter into the VLSI industry. Because the secrecy of the file that you are transmitting, that has to be kept intact, that has to be encrypted, as well as the checksum has to be properly generated. So the encryption and checksum goes hand in hand, these two binaries. So I think I have given you a short and sweet description of what these two things does, and you have that very clear idea about them. And with that note, we have reached to the end of today's episode. Hey guys, welcome to the 10th episode of Linux Basics for VLSI. Today is the 7th day of the bootcamp, where we'll be covering single most important topic, which if you don't know, you may lose your job. And the topic is secure file transfer methods in Linux. We will cover both the command line and graphical interface methods of secure file transfer protocol in today's episode. You may try out the steps side by side while watching this video. So gear up and enjoy the learning experience. Hey guys, welcome back to the computer screen. In today's episode, we are discussing the below points. First, I'll explain what is FTP. I'll provide the necessary technical details that you need to know. Second, I will talk about the secure FTP file transfer method with infographics. Next, I will tell you the ways of doing file transfer, that is FTP. In the next section, we will enter for the live demo using both command line interface, that is CLI, and graphical user interface, that is UI. So this is the menu for today. Without any further delay, let's begin. What is FTP? Before proceeding, I'll like to talk a few points. In VLSI, generally we work inside one single company where we have multiple location and disk spaces. We mount or unmount them to access them and disconnect them. However, there are certain times when we have to send a file across to clients, customers, or vendors. At this point, the FTP comes into play, and this is a must-know knowledge of every VLSI engineer. Because whenever you have to send a file across your customer, clients, or vendor, you cannot send the files purely. That means you cannot send the file by attaching in email. It becomes public if the information and the files become open to anybody who have the email. So this is a non-secure method of sending, and this is prohibited. I'm emphasizing again, this method is prohibited in the VLSI companies. Even if you see this practice, do not adopt it, because these are against the rules and regulations of the company where you have signed and entered into a job. So always use caution and never use the email to send a file across different companies. Now these two could be you and your client, vendor, whatever other party is on the other side. So at this point, the FTP comes into the picture. Now let me come to the technicality of FTP. The file transfer protocol is a standard communication protocol used for the transfer of computer files from a server to a client on a computer network. Now, when you access a website that has a HTTP, that is Hypertext Transfer Protocol, that means it sends text, video, image, and all those stuffs. Nowadays, you access multiple social networking sites. Those are also based on the HTTP protocol. However, when we have to send large size of file, this protocol is not used, and a more efficient protocol, that is FTP, is used. So I have given you a brief reasoning of the importance of FTP in transferring files across the internet. Now let's move on to the next point. Generally, FTP users may authenticate themselves with a sign-in username and password. This means if you have to send a file, you have to log in to the FTP server with your username and password. And when the recipient who receives the download information also have to log in to a username and password. This way, the sending of the file becomes end-to-end secured. Also, we have other layers of security. I'll come to those points. One can connect anonymously if the server is configured to allow it. This is a no-no in VLSI, as all the files are intellectual property. So in general practice, when you are using the internet, you might see there is a anonymous connection you can do, and your files you can download without a login and password. Many of the file servers in internet support that, but these are the data, those are on the public domain. However, when you are working in a company, your companies are protecting companies' intellectual property to secure FTP, and there this method is always a big no. Encryption of the content is done through the SSL, TLS, or with SSH file transfer protocol. So these are the security or the encryption layer which are added on top of the FTP protocol to make it super secure, so that no intrusion can happen between end-to-end communication. FTP clients could be both GUI as well as command line. Today, I'll demonstrate both. Oh, don't worry. We're done with this particular slide, so let's move on. Secure FTP file transfer. Now, this is an infographics. The FTP concept is not that very much common in the colleges because there you do not have such facilities. That's why I kept this infographics for you for easy understanding. So this is your local machine. That means when you are sitting on your chair and you are working on your desktop or laptop in your company, this is your machine. and this is called the remote file storage server that will store the files for the file transfer protocol. These two are connected through the internet. Now, if we have to send a file from our local machine to the remote file storage server, that is a FTP server, the process is called uploading. And once you upload, you will get some email or some message in some way that you have to convey to your client or vendor, and once that recipient receives those information, he or she has to download the file to his or her machine. So this is the entire process, that means from start to end of a FTP process. Why I given this infographics? To give you an impression that once you upload the file, your process is not done. You have to also convey the download instruction to the recipient, and the recipient has to confirm that he or she has downloaded the files properly. Only that time the entire file transfer process, one end to the other end, has been considered as completed. We're done with this particular slide, so let's move on. Now, ways of doing the file transfer protocol. So far, in last few episodes, we are using the command line interface, that is the Linux CLI, or generally we call it a terminal operation. You can see the terminal snapshot is there. This is one way. We will use the FTP binary. Yes, the name is FTP itself, to upload or download the files. Now, there is another way to use the graphical user interface. So here the UI that we are going to use is named as FileZilla. This is free software. However, there are paid versions also. For your testing, you can download, it's free. Today we will test both of the methods for downloading and uploading. We have talked so far. Now it's time for our live demo. Now we are in our terminal, and you can see we are in the directory so far where we are testing the commands, and I have made a special directory FTP test where I have kept couple of files here. You can see, let me do the ls again. You can see I have kept 2 files which I will use for uploading, and then I will download them in a separate folder called download. And here I have in the FTP site, let me do the cat. You can see this is the information of a free FTP server. Here you can do the testing that whatever I am doing in this tutorial. However, you cannot use it permanent storage. That means you cannot permanently store a file there. This is a server that is used for your testing. Those people who want to learn the FTP commands and all, for them this server is there. The open system, whatever file you upload there, they will be stored there for 5 minutes plus minus 1 minute. Then they will be deleted. For your learning, you can use this server. I'll provide the details in the video description. Let me now show you the FTP command. So here is the FTP command, Internet File Transfer Program. FTP means File Transfer Protocol. However, in the Linux, whatever binary we have, it serves the purpose of the file transfer program. FTP is the user interface of Internet Standard File Transfer Protocol. This program allows a user to transfer files to and from a remote network site. This is the remote network site which I have just shown to you. This is the remote network site. Here are the switches. You can go through detailed description, and here are different modes and all. You can go ahead, learn by yourself. It's there in the manual and it's very detailed. So let me quit it. I will show you a very handy commands that we use everyday VLSI work, so that you can quickly grab the idea and learn the thing. Rest of the things, all the knowledge you can gather by yourself going to the man page about this binary. Now let me do the cat here once more for a record, and let me launch FTP. Then I give the URL. I am connected to the internet, and now it is asking for the name. So I have to copy, double click, and then middle click the username here. Now is asking for the password, so I am double clicking and clicking only one time. The password is not displayed, however it has been given, so I'll hit enter. Don't do a mistake that typing password again and again, so it will do the pasting multiple times. Now it is trying to log in into the remote server. You can see The login is successful. The remote system is type Unix using the binary mode to transfer files. Can change the mode to ASCII. Now we are switching to the ASCII mode of file transfer. ASCII means human readable mode. Now another command is hash. So if I type hash, a hash mark is printed on crossing of each 1024 bytes. That means whenever you are transferring a large file, if that is greater than 1024 bytes, so for each 1024 byte is transferred, a hash mark will be printed. Very important. This is a kind of increment display that you can have on the command line. Now you already know there is this file. We will first transfer it. So I will do the put. Put means I am putting the file in the server. You can see that here the transfer is complete and it took only 0.3 seconds. So this file is transferred. Now if I want to put multiple files in the server, I will use put. Now I will copy two files, that means this zip file and this PERL file here, and I will hit. It is asking that should I go ahead and put it? I say yes, and it starts sending. The transfer is complete for the first file. Now I have to give a green signal, that means Y, to the second file. So sequentially you can see these two files are uploaded. If I now do a ls, you can see that here the three files are uploaded successfully. Now I will have to change my directory here. Now I cannot use the cd. This FTP has a command lcd, that means local change directory. lcd, I will go to download. Now you can see the message that local directory is now this. Now I will download the files. I will type get. Okay, so the meantime, actually the files have been deleted. You can see this is the first process how the files have been deleted. I'll go back to the directory here and I will do the import this file. Yes. Yes. Now I'll do the lcd download and I'll do the ls here. You can see I'll type get to download the file. So the file is downloaded, and if I type mget and then I type the two names, I say yes. I am downloading multiple files. I say yes. So you can see that I have downloaded the files. So here the entire FTP operation, that means the uploading and the downloading, is shown to you. For uploading we have used put for single and input for multiple files, and for downloading we have used get and mget for single and multiple files. So it's time to log out. For that I will type bye. You can see we have logged out of the system. It has said goodbye, and you can see that we are again in the command prompt. If I do the ls and then let me go to download and see, these are the files. These are the two files which I have downloaded just now after uploading. So let me clear it. So the download folder is now again empty, and we are done with the command line, that is CLI example. I'll move on to the GUI example now. Here I have opened the FileZilla, and let me just clear the screen. Here let me copy this. Then I copy the username. Then I copy the password. So I have copied the host, that means the file server, then the username and then the password. And I will hit the quick connect button in the here the connection is ongoing and we are in the same directory, that means home, then test, then Linux command, then ftp test. We are in the same directory as in the command line interface. This FileZilla is trying to log into the server and it is asking for authenticating. I say okay. So you can see here initializing TLS certificate. So TLS is a kind of encryption that I have just hands back in the slides. It is logging through the secure connection. You can see here it is saying logged in and retrieving directory listing. So here you can see that the files are here. Now my files are deleted. Let me upload them. You can see I have double clicked the file and it is asking for my permission. I say yes. And here you can see the progress bar here is connecting. So this is the GUI method. It's very easy. You can use FileZilla for file transferring. So here you can see that the file transfer has been done. Let me do one more and one more. So I have double clicked every time and here you can see it is asking yes. It is going through all these steps. You can see if there is a kind of issue or error, here you can see and find out what is going wrong or right. So here it is, I think, connecting and the final file is getting transferred here. So it is done. Let us now go to the download directory and download all these files. Now I have uploaded and here this is the remote site which we have connected and this is our local directory in the left. I have opened our empty directory and let me double click so that it will get downloaded here. So you can see we have uploaded the files to the remote server and then we switch to the download directory in our local directory and then we have downloaded the files. Now I'll remove the files here, right click and delete, yes, right click and delete, yes, right click and delete, yes. So this way also we can delete the files from the remote server. That means once our recipient confirms that he or she has received the files in full volume and with all the checksum corrected and all things are done, so the files are intact and the checksum is giving the OK message, that time we can delete the files in this way. Now I will log out, so you can see disconnected from the server and this is the button to disconnect from the server. We are getting disconnected. Now not connected to any server here. We are done here with the graphical example. I'll provide all the details in the description here. Whatever I have used here as a FTP testing site, you can go ahead and use these details. Hey guys, welcome to the 11th episode of Linux Basics for VLSI. Today is the 8th day of the bootcamp where we'll be covering single most important topic about job scheduling. And the topic is crontab in Linux. We will make GUI and CLI methods to get the job done correctly without any error. So gear up and enjoy the learning experience. Welcome back to the computer screen. Today we are about to explore one of the most important Linux command. The command is crontab. So here is the manual. Here it says the crontab maintain a crontab files for individual users. Now what is a crontab? It's a job scheduler. That means you can schedule jobs at particular times and this will be repeated in a periodic fashion. That means if every day 10 AM I schedule a job, so it will run on Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, every day at 10 AM. So this is called job scheduling. So for that we use the crontab. Now here are the 4 important switches of the crontab. The L option causes the crontab to be displayed on standard output, that means the terminal. The -R option causes the current crontab to be removed. -E option is used to edit the current crontab settings using the editor specified by the visual or editor environment variable. Editor is a environment variable. In my case, it is set to Gzin. You can set it in your CSHRC file with the setenv command. Now, after you exit from the editor, the modified crontab will be installed automatically. So this E switch is used most of the time. Now, the fourth switch, the I option, modifies the -R option to from for a user yes or capital Y or small y respectively before actually removing the crontab. So this and this work together. If I go back here, you can see the crontab runs as a command, crontab then -U username, and then if we use the E, it will open the crontab default file where the crontab settings will be kept. Rest of the things are optional, like I is a kind of interactive, right? And E, L and R, they have specific uses. I can be used here everywhere, and E, L and R, as I just now shown downwards, these have to be used. The mostly used is -E. That means crontab, then -U and then -E. So this way the crontab is used. Now we are done with the definition or the idea of the crontab. Now let me go into the detail how the crontab is done. I have opened couple of URLs here where you can go ahead and make the settings. The 5 fields you can see: first, second, third, fourth and fifth. So these 5 fields are there in the crontab settings. However, it is difficult to remember because when you give like this, which is what remembering is a bit tough. Now if you come to this website, right, I'll provide in the description. Here you can come and you can say click here, and from the drop down you can see that what value you can choose, and accordingly what will be picked up. So if you 0 to 59, allowed value 0, 59 will be entered, then every minute, and other values are there. So from this drop down you can select. So I pick up from here and enter a value. First value here 5 minute. Next 23 hours. Here also you can see the lot of informations are there. If you choose this will be done. If you choose this will be done. Okay, so all these things you can read slowly, and then according to your need you can act. Here let me do it at 10 AM. So I will write 10. So it has changed. Now day of the month, here star will go every day. Month, star means every month, and so it is the day of the month, means if there are 30 days in a month, so all 30 days will be counted. If it is 31 days, it will count all 31 days. If it is 28 days, it will count the 28 days. Month, for 12 long months, it will use all of the months. Now here it is there, the default is here Sunday. Now what I do, I change it to star. So I change it star. So you can visually go ahead, use this guide and construct your crontab settings. So once this is done, you can copy it and you can open up here. So here once I move to sudo, it is asking for the editor. Let me choose to nano editor. Here you can see the details are there. Now here I have to go back again in the website. Here I copy it, I come back here and I paste it. Then I have to save it. I will type the command that will be executed is that ls, simple command. So here you can see there is a guide here also, and you can follow this example how to set up. Here I am doing the simple ls. So I'll save it and I will exit. So the crontab is done. This way the crontab can be specified in the system. Now let me go back to the web browser. Here another website is there. You can take the help of this website. It is much more elaborate. Here you can see that minutes every 5 minutes, every minute, even minutes, odd minutes, 5 minutes, every 5 minutes. Here you can see, I'll provide this link in the description. So from there you can pick it up. So here it says that you use our service do the shortcut to construct your cron job and use the cron available in your Linux or Unix system. So if I go down here, you can see the complete the following to generate the crontab line. Here you can do every 5 minutes and say every hour. Here you can pick up the days. So I picked up every day, month, every month, and every weekday. So here you can pick up, right? So here you can see as per this cron job created. You can just copy it and then you can go here and you use this sudo then crontab e command. You open this file with, here I have chosen the nano. I am removing this and I am pasting this and let me save it and then I exit it. This way you can do the settings. Now let me go back. Guys, the reason I have shown you the GUI here where you can go ahead in a web browser and do the settings easily, because it is difficult to remember the 5-6 fields that you have to fill up for each cron tab operation. To get out of this headache, I have just shown you the two easiest way. You go to your browser and then from there you configure your cron job instruction and come back to your terminal and there you set the cron job instruction. Now this is done. These two are done. These are the two GUI. So let us move on to another website. This is called GEAT, a GUI front-end to crontab to schedule jobs in Linux. So here I have kept the instruction. Let me add the repository first. So here I think the repository has been added. Let me clear the screen. Let me now update. Updation is done. So here the installation is ongoing. You can see it is proceeding. So the installation has finished. So let me clear the screen. This is now installed in our local machine and this is the GUI. Let me launch it. So here you can see add a task. Description I am writing ls. The command is simple, ls. So let me go to minute, hour and day of week. To over here, right, you can see that what values you have to give. So let me go back here. We have used pipe 10 then star star star. So let me use it. 5 10 then start. So you can see here at 10:05 every day it is enabled. So here you can see that the task is here and it's about this particular software. So it is green tick. Let me delete this task. So folks, this way you can run the GUI application or the crontab. So that means you can use either of these websites to construct your crontab builds, and then you go to the terminal. There you go ahead and use crontab-e as a root, and then you do the crontab settings and input them in the respective file. Another way I have shown you using the zip this GUI. You can also schedule it. That's all for today, folks. Thank you for watching up to this point, and don't forget to like, share and subscribe. In case you have some dislikes, put that as in the words in the comment section down below, and bye for today. Hey guys, welcome to another episode of free and open source software installation. In today's episode, we are going to install and use GEANY-ID in Ubuntu Linux. The best thing of GEANY is the tabbed interface, which helps you to open and edit 7 to 8 independent or interdependent files side by side. This is the free and lightest ID out there. Stay tuned till the end of this video to get ready with this integrated development environment. Hey guys, welcome back to the computer screen. Today we are installing one very useful and lightweight integrated development environment. As you can see here, we are on the URL geany.org. This is our ID, integrated development environment. That means you can code here and at the same time you can run the code in the same window. So you don't have to switch in between a text editor and the command terminal to do the coding and running the code. The beauty of GEANY is that it is free of cost. It is a free and open source software, and it is very much lightweight. That means it do not eats up your resources while running. Here you can see it is written GEANY the lightweight ID. And you can see it is compatible to multiple OSs like Linux, Windows and Mac OS. So in any of the OS you can download it. So here in the top row you can see that it is GEANY, the base, then about, then download. If you click it, you will go to the download page. Alternatively, you can click here and go to the download page. So here you can see the source code is also here, the Windows binary is there, Mac OS is there, and in Linux, other than the Ubuntu or Debian, you can go ahead and use the source code to build it. For Ubuntu today, I will show you how you can install it from the command line. If you go here, you can see the manual, and here there is a wiki. So if I go to the manual, download the manual here in HTML format as well as in the text format. If you go to the wiki, you will get a lot of articles here. How to do things are here, and you can find out a lot of tips and tricks here about using the GEANY. Now let me go back and go to the main page. So this is the general interface of GEANY, and color can be switched. It can have multiple themes. So that's why these are there. And here, as you can see, it is very much fast and small, and it has a community support. That means you can have all the bugs and related info from there. And here you can see that multiple plugins are there, like here PCS plugin, and here if you go, you can find that different plugins. So here you can see different plugins are available. Let me go back again to the home page. You can see here it is supporting multiple type of programming language. That means once you install GEANY, in the same window you can play with multiple codes. And if you want to go to this, let me go ahead and open in a tab. So there are a lot of available themes you can download, and you can switch to your desired look and feel. for the Genie theme. Today I'll just showing you this thing. I will today only install the basic thing so that you can go ahead and start using the Genie. So without any further delay, let me go to the terminal. So here I will type sudo apt-get you must spell this correct. Genie is G-E-A-N-Y. So I have written the command here, sudo apt-get install Genie, and I'll hit enter. I am connected to the internet right now and it is communicating with the repositories to fetch the required files. So here you can see that it has installed. So here I was logged in with the sudo password, so it did not ask and it go ahead and install the package right away. Let me clear the screen. I'll invoke Genie. But now we have come to the interface. Here you can see file. From here you can save or save as the file. The most common operation, and you can find and replace operations. You can do it from here. Replace is here. You can change the view from here. You can do multiple document related stuffs here. In case of language like C or programming language or C++, you can do the build here. This interface is very useful. First left here you will see the files, which files we are saving and writing. Here is the editor window. Here you will see the editing. If you go down, right, there are a lot of other things are here like status. Here things will be messages, and here is the beauty. Once you are working in any text editor which gives you a syntax highlighting, the trouble with that is that you have to continuously switch between your text editor and the terminal. Here in Genie you don't have to do that. If you go down below here the terminal is available to you. So this is basically shell. If I type echo $shell, you can see is the actual Linux shell, and it is not an emulated shell. It is actual Linux shell, similar to the terminal here. This is the same thing. Now let me write a Perl file. I have done the touch here and I'll open the file from here. So here you can see I'm opening the hello.pl that I have created with the touch command, and it has 0 bytes. So let me open it. One thing, whenever you are writing a file, you must give the extension of that file name properly so that Genie can recognize what kind of syntax you are writing and it can highlight. Now I come back here and I type. So I type and I hit Ctrl S, save the file. And here I type I again hit S. You can see once I hit S, the star goes from here and it is saved. You can see I'm continuously interchanging between the terminal and the text editor. However, my screen is static. I don't have to change anything. So I am changing the execution permission of the hello.pl here. I do a Ctrl S again in the editor and I run it here. So you can see hello world, it is shown. So the Perl file has executed and here you can see the syntax is highlighted. Now let me do a shell script and let me open it, this hello.sh. You can see it is created with the 0 byte size here, and I type bash, and right away I type here hello world and I hit Ctrl S, save the file. Now let me change the permission and run it. So you can see the shell script has executed. The beauty of this is that you can open in a tabbed mode. It is a tabbed mode. So in this tab, I have a Perl file open. In this, I have a shell script open. So I can work multiple documents simultaneously. I have already a Verilog file here. Let me open it. So you can see here the Verilog syntax highlighting is also there. And if I go ahead and execute using iVerilog, it has created the a.out here, you can see. And let me execute the a.out. So this way, you can use the Genie ID to code any kind of, either it is scripting, that means a Perl script, a shell script, or your Verilog file or VHDL file, anything. You can code it and at the same time you can run it here. So this way, I have shown you the simplistic way, install it and start using it. And this way, you can use this particular interface to code multiple files at the same time. And you are on a particular work where you have to keep say 7 or 8 codes simultaneously under watch. So you can open them in a separate tab, change in one and see the effect in another, or vice versa. This way, you will be able to debug the things and finish your job very much efficiently. So today we have used Genie. You can see a fast and lightweight IDE, and here is the website I have just shown you in the beginning. I'll provide the link in the description so that you can go ahead and access the manuals, the themes, etc., which I have already shown to you. And you can see it's under GNU GPL. So it's a free and open source software, and hence you don't have to pay any price. That's all, folks. Thanks for watching. Welcome to the first episode of Bash programming in VLSI. In this episode, we are going to discuss compiled versus interpreted languages, what is shell and shell programming, set your expectation right from shell programming, first program in shell, hello world, smart access to the man pages and debugging, system variable, bash RC and user-defined variable and typecasting, exit status of shell script. Handling standard input, that is command line input and command line arguments, test command and the rectangular bracket operator. So guys, let's begin. In this first section, we will be discussing the difference between the compiled and interpreted languages. The compiled language, as we know, the C is a compiled language. It has 3 steps. Source code, you have to write the source code, then compile it, and then run the executable. So, these 3 steps complete the program execution. Whereas, in interpreted languages, it is a 2-step process. Source code plus run the script. So, in interpreted languages, you don't have to run the compile step. You can create the source code and just run it in the particular interpreter. So why we are discussing this? Because shell is a interpreted language. That is, shell programming that we are going to discuss is a interpreted language. So we must have a clear idea and the clear difference between the compiled language and interpreted languages, because generally in colleges that we learn C as a first language and that is a compiled language. And when we come to the shell, so we must know the difference. Next point, the compiled language run faster, whereas the interpreted language runs slower. The reason is compiled language creates a binary. That is the reason. And the binary executes faster than an interpreter. Third point, compilation errors prevent the code from compiling. So you have done some mistakes in your source code. It will halt you at the compiling step. Now, there is a striking difference. In interpreted language, all the debugging occur at the runtime. So there is no compilation, and when you run the source code, you come to know about your mistakes. The final binary is executed directly by the CPU. In interpreted language, the source code is interpreted by the interpreter and hence your output comes. Compiled language example is like C, C++, C#. And interpreted language, we can take the example as Shell, Perl, Python, Tcl, Ruby, etc. So let's go to the next section. What is a shell? Shell can be used in interactive and batch processing mode called scripts. So we have a shell of the Unix or Linux. In that we can process the programming steps one by one. That is will be interactive, or we can dump the entire lines of the source code into a file and then run it through the interpreter. This is called script. Shell for your own command processes and then executes them. Shell also provide a set of built-in commands. So when the shell in which you are running, right, that comes with a set of built-in commands, that is all these commands you have learned when you have learned the Linux or Unix. Command line binaries can be installed separately and used in the same manner of the shell command. So this is a very important point. When we are using a shell scripting, we have installed some other binary which is not come with the package of your shell, but it can be run in the command line. We can include this binary and its options in the shell scripts itself. A Linux shell defines the system variables to control the behavior of your session. So system variables are a couple of reserved variables which some we can modify and some we can't. That defines different parameters of your session. A session can be simply understood by launch of a terminal. So once you execute a terminal, that terminal pops up like a xterm or a terminal or a KDE terminal. All these are terminals, and once you launch, that shell is ready and you can either source your code or you can use the interpreter line by line. EDA softwares related system variables can be included in the startup files that your shell reads when you log in or you launch a terminal. So when you include the setup variables that is given by your EDA software vendor, say you are running a synthesis or some physical design step, in that you are using a particular tool from any vendor and they have some system variable, they have to be there. One common example is LM license file. So that has to be there in your RC file. So what is a RC file? You know it, right? The .csh RC file or a bash RC file for a bash shell. CSH RC file is for CSH or TCSH shells. Startup files can also contain shell commands for execution immediately after login. So these RC files can have some of the defined set of codes which will immediately run during the login. The time once you just log into the machine that time. So that's all. So let's move on to the next section. Now we'll look about the shell programming. What is a shell programming? A series of individual commands, inbuilt or separately installed, combined into one executable file is called a shell script. Batch files in MS-DOS is a similar concept. You know, right? The MS-DOS, in case you are not familiar, in MS-DOS we can write a batch file which is very much similar concept in Windows or DOS operating system. Bash is considered a powerful programming shell among all the available shells. Now, the shell, because it's directly in touch with the kernel of the Linux, it becomes a very powerful shell apart from all the other shells available. And among these shells, Bash is very powerful in terms of programming. Scripts when in other shells may be hazardous to your health and mind as well as to the program. So when you write script in any other shell language like TCSH or CSH, these are not well developed and it will create glitch during your programming. So in that perspective, Bash is the most widely used shell programming language. So let's have a look of a small shell script or shell program. First line is always a hash bang, then the path of the bash shell, that is user/bin/bash, and then the code. So here I have given an example of a particular code that I write in my Linux system for a handy use. Generally, I download a lot of fonts in zip format, and in a folder maybe 10-20 files are there. And this unzip command you can see here is separately installed. It doesn't come with the Linux package. The limitation is that this unzip command, we have to unzip each file by a single command. So this short shell programming I have written, which iterates under a particular directory, lists out all the zip files, picks up one by one, and then applies the unzip command on each file. Also, in my bashrc file, I have made an alias that unzip all to the saved path of this shell script. So this is the beauty of the shell programming, that you have written a shell script and you set an alias for that. And when you want to execute it, every time you don't have to go find it and then execute it. Simply, instead of that, you can use the alias. So this is the beauty of the shell scripting or shell programming. So guys, let's move on to the next section. This section tells you to set your expectations right and the limitations of shell programming. So when you learn about shell and you hear that it is connected to the kernel, you might be quite amazed that it's a something language that can do everything. No, it is not like that. Shell have certain limitations you must be aware of before you start the shell programming, so that in between of your source coding, you don't get an unexpected stop. The first point is intense mathematical computation, like floating point, complex number. These are not supported. In that case, you can use C++. And guys, why I am telling at the beginning? Because you must be aware of a language's limitation before you start coding in that language. Otherwise, you have all concepts and everything done at your end, and then will be stuck at some point. So the next point is cross-platform compatibility. If you need it, shell is not the right choice. You can use C++ or Java. Guarantee the integrity of your program against hacking or reverse engineering. Well, shell doesn't support that also, because it is an open script. Someone can read it easily and it cannot be encapsulated. Project consists of subcomponents with interlocked dependencies. So in that case also, you cannot use a shell script. Extensive file I/O operations required. Shell has a very primitive file I/O system and it is not up to the mark to use it in extensive way. So in that case, you need to do a file I/O, a lot of them. So you must use Perl, Python, Ruby, C++, Java, or whatever you are using. So in that case, for scripts, right, you can use, or interpreted, you can use Perl, Python, Ruby, or it is compiled, right, you can C++. Let's come to the next point. Need native support of multi-dimensional arrays. Well, in shell, there is one-dimensional array only. So, you need a multi-dimensional array. You go to Perl, Python, or Ruby. Need complex data structure such as linked lists or trees. So, complex data structures like Perl has hashes, Python has dictionaries, all these things if you need, right, you cannot expect that to be present in shell. If you are handling large amount of data inside your data structure, you avoid shell scripting. Rather, you use the Perl, Python, Ruby. Need to guarantee or manipulate graphics or GUI. Sometimes you have to write GUI, shell cannot give it. Rather, you use tcl, tk, or qt. Need direct access to the system hardware or external peripherals. In that case, you can use C++. Need port or socket I/O. In that case, you also cannot use shell scripting. Proprietary closed source application. So you are building an application that you want to sell and make it closed source. So in that case, you cannot use shell scripting. The alternatives, like in that case, you can use C++, Java, Qt. Object-oriented programming. So that is another point that you cannot do in shell. You can use Java, C++, Python, Ruby. So guys, in this section, we have seen what are the limitations. So now your question is, so if this language has so many limitations, then why should we use it? Because it has a lot of flexibility to operate with the EDA tools and gives you a flexibility that you write a script and you can execute your, say, 10 repetitive steps for execution of your EDA tool. So for that automation, you can use shell scripting. That is the purpose. And since it is directly connected to kernel of your Linux, it operates very fast. So let's move to the next section. In this section, we will see that special files. What are these files? So like /etc/profile, this particular file is executed automatically at your login. So this file consists of initializations of your user ID. The files related to your user ID, they are initialized in this profile file. Then comes your home directory /bash profile. So this is also executed at the login. Then the next file is home/.bashrc. So this dot signifies that it is a hidden file that is not visible to you, and this is also executed at shell startup. So whenever you launch a terminal, it is executed. If you close that particular shell or terminal and then again open, this will be again executed for that next shell or terminal. So next file is your home directory /bash logout. It will be executed automatically at the time of logout. And then your home/bash history. So this particular file records the sessions command. So guys, these are a couple of special files which you must be aware aware of, and at some point you may need to look into them for maybe debugging or some urgent need. So guys, let's move on to the next section. In this section, this is a hello world. So this is your first program in shell. So let's begin. Here, the first line will be hashbang user bin bash. So this path is in my installation path. In your case, it may be a bit different. So if you run a which bash this command, it will give you this path. So this is a text file that is I am writing. Now hash, then if we write something that becomes a comment and we need the comments for our own good. Then comes echo, then within quote, hello world. So this completes our hello world code. So then we launch a terminal. We save the file as helloworld.sh from the text editor in which we are writing. Make it executable with the chmod plus x command, then the helloworld.sh. Then we can execute in the terminal that hello world./helloworld.sh and then hit enter or return. So guys, there is a small typo here. Underscore came into the third line. Please ignore that. It will be the same as hello world.sh. So this is the overall idea of a shell script. So whenever you have a shell script, you start with the first line as the same and then you put all the shell commands inside it and then save it, then make it executable with the chmod plus x command and then you run as /helloworld.sh and hit enter or return. So guys, you can try at your end opening a terminal this thing. So let's move on to the next section, manuals. A manual contains the details of a shell command. Now, when I talk about a shell command, it essentially can be any command like ls, like pwd, any command. So all these manuals are written in man pages. These are called manuals. And how we access these manuals? Generally in terminal, we type man, then space the command name. But I have found one particular drawback of this man page command, that if there are two languages have the same command, then this man command displays the last installed command. I have installed tickle after the shell and there is the same command in between tickle and shell. If I type man, then it will display the tickles one, not the shells one. So there is a smarter way to deal with this. Here is a snapshot of KDE man page viewer. It is not only KDE, you can install in any of the Linux distros. This gives you a GUI as well as I'll tell you the benefits. From this particular URL like apps.kde.org/en/help, you can download this particular binary and install in your system. And if you are not the owner, then you have to request your Unix administrator to install this one. And after the installation, this will be the binary. The initial path could be different, but the binary name will be khelp center. So if you execute this in your terminal, this window will pop up. Here in the window, I have done the search for echo, and here you can see in the choices, it gives two choice. That is one, application manuals and the Unix manual pages. So why these two? I said that there are a couple of shell commands that come in bundle of the Linux or Unix. And there are some other binaries like I showed is the unzip that will come, right? So that I have separately installed. So the separately installed man pages also displayed here. So we'll see in the next example. So here we can see again I have searched for gets command. So here you can see the application manuals. If there is some application which is separately installed and it contains something related to this particular gets command, you will get here. And here in the Unix man pages, I have highlighted gets. The first line shows that gets command, which is inbuilt. And then there is a gets, which is from the tickle. So here you can graphically see, and from there you can navigate to the exact man pages. Because when you are doing the shell scripting, a man page is always necessary to know the details of a command and different switches and how to give the values according to those switches. So this is a very important part. So I have shared with you this particular smart way of finding the man page. So we are done with this section. So in this section, it is the flattening or debugging of a shell script. Now, why at the beginning I am talking about the debugging of a shell script? As I told in the beginning that it is not compiled, so we do not get the errors, and only errors we can find while it is executed. To debug, right, to understand, we can give the echo command to different stages. That is an easy way, like we give printf in C code. But there is a very easy way that we can debug our shell script. So let's discuss. This has to be learned at the beginning so that whatever code you are doing, you can debug it. So the first line I'll have a focus here is hashbang user/bin/bash, and there is a -x command. So this x command does the flattening of the code during the execution. We'll see this flattening the result, but let's see the code first. So here this code will take input strings from a command prompt as arguments. Then two values are compared with the first if condition. If they are equal, echo $1 is same as $2. So $1 is the first argument and $2 is the second argument, command line argument. Else, echo $1 is not same as $2. If they are unequal, this will be echoed. Then we close the ifs with the reverse of this p. Since they are different, let's see which comes first. If $1 less than $2, then echo $1 comes before $2. Else, echo $1 comes after $2. And we close the if here. So this is the code. And guys, we have used the -x switch in the bash in the first line where we are calling the bash shell to execute this script. So let's see how it behaves. This is our script.sh. We have saved it and made it executable. Then we are executing with ./script.sh, then 12, then 56. These are two inputs I have given as command line arguments. Now let's see. And now we know that 12 comes before 56. We see how it comes. So with this, you will see first there is a plus sign and the first if condition is getting evaluated. Then you will see which particular block, that is if or else block, it is going. Okay. So the plus command is not the result, but it shows to which particular if or else condition it is going. Okay. So it is going to the else. We can see 12 is not same as 56. Now this line without the plus sign is the actual echo and we know from where it is coming. Then if the code moves further right, the next if condition is evaluated, and then the next line which is marked with the plus, say echo 12 comes before 56. So it enters the if block, not the else block, and accordingly it echoes 12 comes before 56. So guys, in this example we have seen that how we can add a simple -x command just to flatten the output, and from there we can see how our code is progressing. So this way at the beginning you can mention the debugging switch so that you can do the debug. We are done with this section. Let's go to the next section, system variables. So guys, in this section we'll get familiar with the system variables and later we'll tell the significance of the system variables in VLSI. We begin our script. This way we are printing the system variables. Echo default shell is the $shell. Echo default editor is $editor. So this editor could be your Vim or it could be Nano, anything like that. Echo user home is $home. Echo current working directory is $pwd. Echo system path array is $path. So let us see some more system variables here. Here it is, the history file, the name of the history file on which editing modes operate. History file size, the maximum number of lines to store the history file. History size is the number of commands to remember in the command history. Bash version, it will tell you the bash shell version. Columns, it will display the number of columns in your display or terminal. It is very essential. We have a x by y aspect ratio of a terminal, right? In that terminal, how many columns are there, and if we want to know the rows, right, if we put lines, so the number of lines or rows will be shown by lines. So term is the type of the terminal that are using. We have come to this point where we have shown a bunch of system variables. Now, the importance of these system variables is that in automation, when we are automating EDA tools, right, these EDA tools have some system variables associated with them, which they use. Like one is LM license file, other could be tool specific, and these are specified in your RC file. And whenever this particular system variable is specified, might happen that one particular system variable is used for 5 tools from the same vendor. So this is the importance or the significance of knowing your system variables and system variables related to the EDA tools. So let's move on to the next section where we are discussing about the bash RC with an example. Bash RC is executed by bash for non-login shells. So we are using the variables here. Let's see. We say history size is 1000 and history file size is 2000. Then we need a fancy prompt. we use the terminal, and according to that, we set a color prompt, yes, and then we close the case. And let us define some of the aliases. Right, alias is equal to ls minus alf. So this way you can define the aliases in your bash rc file. So there are two more examples I have given. It will be different for csh rc file, which you may encounter in your VLSI area. Many tools use the variables from csh rc file, but anyway they are similar, so you can learn about them. This is the typical example of a bash rc file. Here you can set the variables like system variables, or you can define an alias or set a case code here, right, which is executed at the beginning. So this kind of stuffs you can do at the initialization file is a bash rc file. So let's move on to the next section, user defined variables. Let's begin the script with the path of our bash. Then is the first one is let a equal to 25. There are two ways you can define the user defined variables. This is the first way, let a equal to 25, and then you can echo $a. Then similarly, the next way you can define, that is explicitly you are defining here, name equal to Mark Anthony. This is different. You haven't used let here, but this is also acceptable. The next one is SSN equal to a number. We are also explicitly doing it. And then we echo the name of the singer is $name and his social security number is $SSN. The next example is that today equal to backtick date, then backtick end. So this will execute the date command and give the output saved into the variable today. Now we echo today is $today. Another way is by command substitution. So today equal to $, then first bracket, date, then close the first bracket. And we echo today is $today. So guys, these are the way you can define your user defined variables. We move on to the next section, that is the comparison of $var versus the var within the curly brackets. The $var is the value of the variable var. Also, then within the curly brackets or the second bracket, the var is there. It is the value of the variable, but it can be used as a substitution. The curly braces end the variable, considers the rest as a string. So this is the word of caution. So let's see with an example. So here the example is shown in a interpreted way, not in a scripted way. So first we write hand equal to 5, then hand sanitizer equal to 60. Then we echo hand, it gives 5. Echo hand sanitizer, it gives 60. Next we go and see echo $, then within curly braces, hand, we end the brace and then write sanitizer. Surprisingly, we get the result as 5 sanitizer. So up to the closing of the curly brace, the variable is considered, rest is treated as string and it is echoed as string. So guys, in this example, you have learned the difference between $var and the var within curly braces. I was talking about, we learned the usage of bash scripting for VLSI automation. Here we can see a normal variable can be defined in two different shells, bash as well as CSH or TCSH. The normal variable in bash we can set as var equal to 34, and the same we can do in the CSH is set var equal to 34. And system variable, here in bash we can do export ABC equal to 1198. This is the syntax we use typically in our bash RC. And the same when we're doing in the CSH RC file, we'll do setenv ABC then 1198. This way we define. So this comparison is given here, so you can get familiar the way the system variables are defined. Let's move on to the next section, typecasting of a variable. So guys, in programming language, we know that there is a terminology called typecasting. So variable, we define the type like integer, string, etc. So let's see in shell how we define it. Bash variables are untyped. You get surprised, right? But it is true. Bash does not segregate its variable by type. Essentially, bash variables are character strings. On special contexts, bash permits arithmetic operation and comparison on variables. The determining factor is whether the value of a variable contains only digits. So we don't have a proper so-called typecasting in bash. So be careful about that, and let's see the next examples. So the below cases are possible: A equal to 23, B equal to AA12 and C equal to 12. So in bash, we can have any of the three examples. So no typecasting in bash. We are done with this section. Let's go to the next section. exit status of your command or your script. So guys, as we know that in an interpreted way, we can execute the command and each command will return an exit status. Also, if you write a script and execute it, at the end of the script, it will also give a exit status. Let's learn about it. The exit command terminates a script. It can also return a value which is available to the script's parent process. Every command returns an exit status. A successful command returns 0, while an unsuccessful command returns a non-zero value. Likewise, functions within a script, the script itself return an exit status. The last command executed in the function or the script determines the exit status. The valid range is 0 to 255. So guys, we have seen that whether it is a script or it is a command or it is a function defined inside the script, each of them can return an exit status. Successful, 0, unsuccessful, non-zero. This is general convention we are using. So let's learn about the exit status of your script. We take an example here. We call the shell here. Then we echo hello world, then we echo $? So whenever we use this $? It gives us the exit status of just previous command. So this will echo the exit status of echo hello world. Next, we define the exit code of this script. Exit, then 56, and this valid range we have written 56, right? How much value we can define? 0 to 255. Also, we can use some if-else loop here and we can define accordingly. When you define our exit status, you have to document it, what exit status means what. This is the exit status of your script, how you can define it. The next section we are going to discuss is reading from standard input. We start with our script calling the bash. Reading from the command prompt interactively. Echo, enter name and surname. Then we use the read and then the first variable is name and the next variable is surname. So this read command will do what? Once you type in your command prompt, once this script is executed, first this echo will print enter name and surname and then it will halt at read. So it will wait for your input. You enter name, then give a space and then surname. So the first one will be taken as name and the next one will be a surname and they will be stored into the variables name and surname. And then you can echo hello, then $name, surname. Then we echo enter address. We use read and we do not specify here any variable. And in this condition, this value is recorded in a default variable. We echo address equal to $reply. So this $reply is the default variable. So let's look at some more on the read function. We use read, then -p, and then within quote we give enter username. P is a switch and then we use this within quote. It will be printed and then we use the variable name un. This in a single without the echo, it will print and halt to read your input and store it in un. Now we use read -sp. Look at the difference. We are using -sp and then enter password and then we give the variable in which we will store the password. Difference in between the two is in the first case when you are typing, it will be at the same time echoed in your command line, but in the second one it will not be echoed so that the password you are typing will not be visible to you. Then we use echo, enter username is $un and the password is $pw. Read like an array. We can also read an array series of data into an array. So let's see how we can do it. Say we echo enter grocery list and then we print read -a then list. Now this -a switch will help to store all the data entered by a space separated values in the list. Once we are done and we have entered 2-3 values to the grocery, we'll echo the list is $list, then within rectangular bracket 0. So this is the first array element. This is how we print the array and then $list, then 1. So the syntax is shown. So this way you can print the recorded array. So guys, this section is done. Let's move into the next section. Command line arguments. We start our example. The first line is that we call the shell. And command line arguments, this is the comment here. Then we echo inserted command line arguments is $0, $1, $2, $3, $4 and so on. Then we do what? Echo inserted command line arguments are $0, $@. So once we execute the script, right, and we give the arguments, right, $0 is the name of the script, and from $1 to up to how many arguments you are giving, right, which are contained in then array will give you the command line arguments. Okay, so $0 your script name and the rest are the arguments. If any of the arguments are present, no error or warning will be issued under the ungiven arguments. While typing, right, there is no way of checking that how many arguments you are giving and whether they are, say, you have to give 5 arguments, right, for your program, and there is no way that the script knows that how many arguments will be entered. So this thing you have to be much more cautious. So with this section we are done. Let's move on to the next section. Here let's see the details of the command line arguments. Here is $, then hash. This gives the count of the command line arguments. It is similar to argc language. So I have mentioned it there so that you can relate. $0 is the name of the shell script itself. $1, $2 and so on are the command line arguments in order. $@ is the array of the command line arguments, and $* is the list of positional argument. It is useful for for loop. This for loop and all will be covering in the next episode. So wait till then. This particular section we are done. So let's move on to the next section, test command and the rectangular bracket operator. So let's see what are the significance. And before beginning, I will tell that these testings are also applicable to if command. We'll see in the next episode, but the basic logics remains the same, so that even if without the if command, we can use this, and that is by using test command. So let's see how. So here the example comes like the test, then the test command is test, and then comes the particular checking, right? Then echo the $? to get the return value of the testing. Also, we can start the rectangular bracket, and within it, your test expression should be there. And obviously, spaces have to be given just after the beginning of the bracket and before the closing of the bracket. There should be space. Then we echo to get the return value. So this way we can test, as I mentioned, that 0 is successful and non-zero is unsuccessful. That convention is followed. So here 0 is the return value that with this test or the rectangular bracket operator is 0 is true. Return value 0 gives you true. 1 is false. And greater than 1, it has error occurred. This has 3 different meanings of the return value. 1 gives you true, the condition you are checking. 1 is the false, and greater than 1, error occurred. Something that is unexpected happened. So let's see some examples. Here, hashbang user bin bash. So this is the when we call the shell. Echo when a file exists or not. We use test, then -f, then /etc/source. So this will. Then we print the echo command. So this will tell us whether this particular file exists or not, and the condition that we have seen in the previous slide, accordingly we can interpret. It is same as within the rectangular bracket -f, then /etc/host, then echo, followed by the echo $? So another checking here we are doing for a symbolic link, echo checking of a symbolic link, and within the rectangular bracket we do -l abc.help. So this abc.help supposed to be a symbolic link. According to the return value we will judge. So these are the initial example. Let's see some, and here we get the return value. This section is done. So let's see some more on this. The first line of the script is we call the shell, and echo, it's a directory test. Then within rectangular bracket -d, then td supposed to be a directory, and we echo its return value. So instead of the rectangular bracket, we can have used the test also. It will give the same. So this particular thing we can check. We are doing some automation and we have used the mkdir or some directory, and after that we need to check whether this directory is created or not. Okay, so we can check this one. It's a directory or something. Similar way, let's see the file permission test. Okay. File permission, we echo rwx. So here we have used -r, then test.txt, echo the status. So this will give the read permission status. The similar way, if we write -w, then test.txt, so this will give the write permission. And -x test.txt, this echo, this will return whether it is the executable permission is given or not. This section we are done. We have seen couple of examples here and we can use these things, and also we can use these testing options which we have used that also can be applicable for if, which we are going to discuss in our next episode. Test file operators details. Okay, comparison operator -e checks a file whether file exists, can be used with the rectangular operators. -d, is it a directory? -f, is it a regular file? -r, check the read permission. -w, check the write permission. -x, check the execute permission. -s, file size greater than 0. So these are most commonly used testing conditions. So we have discussed these all are compatible with test, rectangular bracket, testing operator and if statement. Okay, so guys, we are done with this slide. Welcome back to the second episode of Bash programming for VLSI. In this episode, we are going to discuss constructs and operators, arithmetic operation and operators, condition statement, branching and loops, file input-output operation, functions and code blocks, and finally array operation. So let's begin. In this chapter, we will be talking about constructs and operators. So let's see. Condition constructs. Test and rectangular bracket constructs are already discussed in previous episode. The double parenthesis construct expands and evaluates an arithmetic expression. The rectangular bracket but double construct is more versatile than the single rectangular bracket version of Bash adopted from Kernel. The double rectangular bracket can prevent many logic errors caused by single rectangular bracket in scripts. So in this table, we are looking at different comparison operators. -eq is equal to, and it can be used with single or double rectangular brackets. The -ne is equal not equal to, and it can be used with single or double rectangular bracket. -gt is greater than, and it can be used with single or double rectangular bracket. Similarly, -lt is less than, and it can be used with single or double rectangular bracket. The ge is greater than or equal to, it can be used with single or double rectangular bracket. The -le is less than or equal to. This also can be used with single or double rectangular bracket. Now, the less than operator, this operator can be used in double parenthesis. The less than equal to, this operator can be used in also double parenthesis. The greater than operator, this also can be used with double parenthesis. And the last entry in this table, that is greater than equal to, can be used with double parenthesis. So guys, we have seen the different comparison operators with which it can be used. That is single or double rectangular bracket or double operator. So next we are going to talk about the operator precedence. And the way we have written here, the topmost will be high and as we go down will be the low. So in this list, the entry which is at the top has the highest precedence and the entries are subsequent has lower precedence. So here comes the where ++ and where -. We are very much familiar from C, these operators. So these are post increment and post decrement. Then comes the ++ where and --- where. So where is a variable here and these are pre-increment and pre-decrement. Next one is not equal to, that is negation. Okay, this is logical or bitwise. Then double start, this is exponential, this is arithmetic. Then multiplication, division and modulo. These are also for arithmetic operations. The next one is addition, subtraction. These are arithmetic operations. Then left and right shift, bitwise operators. Then -z and -n, that is unary comparison, that is for string or is or not to null. Okay, that checking. Then -e, -if, -t, -h, etc. that we have already discussed in previous episode. These are file test operators. The next one is less than LT, greater than GT, less than equal to LE, greater than equal to GE. These are all compound comparison, that is string and integer. The next one in this list comes as -nt, ot, ef. These are file test operators. Double equal to, -eq, not equal to and -ne. So these are test operators comes next in this list. The AND, that is bitwise AND, comes next in the list. Then bitwise OR, then comes bitwise OR, then comes logical and the last entry in this table is a ternary operator. We are familiar from the C language, the ternary operator. Similar operation here. If the condition is true, first expression 1 is picked. If false, expression 2 is picked. This is a complete list of operator precedence in Bash. We are done with this section. Let's move on to the next section. In this section, we will be talking about arithmetic operators. The double parenthesis construct permits arithmetic expansion and evaluation. This double parenthesis allows style manipulation of variables in Bash. The BC command, okay, this is a separate command, and expr command are also used for command line calculator. So guys, before moving any further, in previous episode we have discussed that arithmetic operation in Bash is not that much high as it was for C. So whatever the features here, we will be discussing and exemplifying. So let's move on. So let's talk about the arithmetic, that is double parenthesis operator examples. The var ++, that is a C style post decrement. Sorry, this is a typo here. So we know this is a post increment, and this operator can be used with the double parenthesis. So we can set a value a equal to 23 as an example here within the double parenthesis. So a minus minus, that is a post decrement, that is C style, and ++a, this is pre-increment C style. That is minus minus a, that is also pre-decrement in C style. So all the C style operators we can use here, as in the coming sections we'll be using this kind of increment, decrement or setting a value. So that's why we are discussing it upfront. Okay. Arithmetic of integers. Let's begin with the hashbang user bin bash. We set number 1 equal to 100, number 2 equal to 25. Then we echo addition equal to within $, then comes the double parenthesis within which we are writing number 1 plus number 2, and this will echo addition equal to as a string, and the result of addition of number 1 and number 2 will be displayed next. This way we can do a addition. That is a basic arithmetic we are doing here. Then comes the subtraction, that is we echo subtraction followed by $, then double parenthesis within which we are writing number 1 minus number 2. Similarly, we can do the multiplication of number 1 into number 2. Also the division, that is number 1 by number 2. We can also have the remainder number 1, then modulo %, then number 2. We just create a separator here, and then we are getting accustomed with the expr command. So we can do the same addition here, like we start with the $ notation, then within single parenthesis we write expr followed by number 1 plus number 2. This will give the addition result of number 1 and number 2. Then comes the subtraction, that is number 1 minus number 2. Then comes the multiplication, that is number 1, then \* number 2. Here we have to be a bit cautious and we have to use a backslash. So this was not there when we use just the double parenthesis and not the expr. So this is a contrast here in between the two multiplication mentioned in this page. So next is the division. So number 1 divided by number 2. Okay. And here we can see that when we compare, right, in the first one, we are using the double parenthesis. Inside that, we are just adding num1 plus num2, and there is no $ mark here. In the below examples where we are using the expr, there we are using the number 1 plus number 2. So you can see the difference clearly here. So we have to clearly remember when we are doing this kind of arithmetic stuffs in Bash. There is a remainder here. Remainder is also in the same way, that number 1 modulo %, then number 2. Here in this next section, we are talking about the BC, and we will be talking about the arithmetic of real number. So far that we have discussed about the integers. Now the real number, that is floating point arithmetic. We start our script here with the hashbang user bin bash, and then we are just echoing that we are using BC here. We set number 1 as 100.57, number 2 as 25.5. And then we echo as within quotes scale equal to 4, then number 1 plus number 2 pipe BC. So see here the scale defines the number of digits after the floating point. Okay. So when we are doing the floating point arithmetic, the number after the decimal point, we can control that with scale equal to 4. And when we echo this and we piped it into BC, BC is the calculator, right? And then it will give the real number or floating point arithmetic. Okay. Similarly, we do that number 1 divided by number 2. pipe BC. So let's again see another example. Number 1 is equal to 2.3, number 2 is equal to 4.54, and this time we will be using the BC math lib. So there is a mathematical library inside this BC command, and we use it like this. So everything remains almost similar for the first part, and the second, after pipe we use BC minus L. So here we are using square root, sqrt, that is a predefined function here in bash. So we are using square root $2, okay, and we pipe it as BC minus L. So BC minus L, whenever we are doing, it will invoke the math lib of the BC calculator, and all these operations will be done correctly. Here again we do scale equal to 10 and then number 1 caret number 2, and we piped it to BC minus L. Guys, here we have seen the floating point arithmetic, or the dealing with the arithmetic of real numbers. Couple of examples you can try at your end. Let's see some more of this real number arithmetic. We have just begun the script and we are echoing the increment or decrement operator. Okay, we are using here. So we echo variable equal to 10 and then plus var. So we are pre-incrementing the variable and then piping it into BC. So BC can understand this whole expression, and there are two commands that are separated by a semicolon in BC. So first we declare variable equal to 10 and then we do plus var. These two statements are in sequence and they passed on to BC like this, and BC will do the calculation. And similar way, we set the variable equal to 10 and then do var plus and piped into BC. Another example of pre-decrement and the post-decrement examples here, and storing the output in a variable. Okay, let's see. So we do it as x equal to, we start the backtick, store the result back in a variable. So x equal to backtick echo, then we give the var equal to 500, then var modulo % equal to 7, then var piped it into BC, and storing this will do what? All the mathematical calculation done inside the backtick with BC and echo, and the final result will be stored in x. This is another good way of using the backtick for the mathematical calculation. So say there are two steps, and in first step we do this and get the output, and that output used in the next step. So this way we can use the backtick for this purpose. And we just echoing here. So we are done here with the arithmetic or real number floating point arithmetic in BC. So we have seen the various types of mathematical operations that we can do. So let's move on to the next section. In this section, we will be discussing about the if-else condition, case, for loop, that is while loop, until, and select loop. Okay, so let's begin. If, elif, and else. Here I'll be showing the not only just if, because most of the time we program with if, else, and else if also we use. Else if is nothing but elif here as the syntax here. So let us get familiarized with two types of way of writing the if, elif, else statement. So first is if, then the test condition. Okay, then we write then in the next line. We give our command list, that is whatever we are doing. Then we give the elif, then the next set of test condition, we use then, and then we give the command list, we use else, we give the command list, and we close the first if with p, that is the opposite of f. So you can see here that just after if or elif we are using then, but not after else. So we see the next type of writing the same thing in a different way, which is permissible in bash. That is if test condition, then a semicolon, and then we write the keyword then. Next we write the command list, then write elif, then test condition, semicolon, then the keyword then, command list, we give the command list here, then we write else, we give the command list, and we close the initial if with p. So guys, these are the two ways we can write. Based on how we are writing the code and how we are comfortable, we can use any one of these two for our coding in bash. Let's see the if, elif, else example. We start our script with hashbang user bin bash. We are taking input a variable, we enter transaction, $transaction, read -p. And if here we are using the double parenthesis in the beginning, that's why I have discussed all this single rectangular bracket, double rectangular bracket, and double parenthesis, so that we can get familiarized and according to our need we can use it. So this double parenthesis is for arithmetic and mathematical operation, that is very good. So we are using it here. See, if $transaction is greater than equal to 40,000, then echo hi elif the transaction is between 20,000 and 40,000 range, we echo medium, or else we say low and we close with fee. So here we have just seen the first example and we have seen here the double parenthesis use. So this way we can write a if, elif, else in bash. If file test. All the file test commands from the previous episodes we have discussed can be used with if, and this is it how. So we start our script here and then we echo that, enter the name of the file and with the read command from the input, and we store it in file and check, okay, if -e exist file, then echo the file exists on disk, or else we say the file does not exist in disk. So we close it. We are talking about case statement. We begin case, $variable is a variable. Now, this is the syntax we are talking about. The value 1, then we write the single parenthesis here and followed by the statements, and the statements will be closed by a double semicolon. I stress at this point, this will be closed by a double semicolon and not by a single semicolon. Similarly, we write value 2 and the statements, and we keep on doing. And at the last, we write the default action. When we write star, anything else from the listed values we have mentioned, we write the default action and we close the case as ESAC. So this is the opposite of case. So guys, here we can see that the $var can contains value 1, value 2 and so on. And this is the possible values, and outside the possible values, if anything comes, we go to the default action. So this is the structure of a case statement in bash. So let's look at an example here. We start our script with hashbang user bin bash. We read what is your favorite fruit. Just take the input in a fruit variable here. We start our case statement. The first option is orange, and according to that we echo $fruit is orange. Banana, the $fruit is yellow. So we are mentioning about the color here, color of the fruit. Pear is green. Apple is red. Finally, as the default condition, when the $fruit doesn't come under the 4 values and any values outside this, we say I don't know what color of the fruit is. So this is a very simple example I have given to understand the case. Okay, so here we can see that the case example. Here we will talk about the for loop. The first type of for loop we are talking about here is a C style for loop. Why I am saying C style, you will come to know. There are other variants, we will be coming shortly on them. We begin our script here and we write for. Then there are 3 parts like C. The first is the initialization counter, then the condition checking, and then finally the increment.decrement counter. These are also done in double parenthesis. And we write then a semicolon and then do echo $i$j. Here we can see initialized I with 1 and j with 100. We control the loop with I less than equal to 10, and then we have used the increment or decrement operators, and then we are echoing the I and j. So once the statements inside for loop we have written, we close it with done. So do and done are the opening and closing of the code block inside for. This is a C style structure that we are very much familiar with C. So let's move on to the next variant. So here I'm talking about a prototype here for variable in list 1 and list 2. So list is like the name of the list, okay, and we'll see with the example shortly. And the variable is the variable that operates on each of this list. So do, and then we write the action and we write done. This is another variant of for. It is similar to like for each in many of the languages like Perl. Okay, so we have a for each there. So it is very similar to that. An example here. We start our script with hashbang user bin bash for dir in document and music. So this particular script I am running from my home directory, and inside home directory I have documents and music. Okay, what it will do? So it will pick the documents and the music and as a list cd then dir. So the first for loop here picks up one at a time the document and music and enter into the directory. Then the nested for loop begins for file in star, okay, in the present directory. So we get the all file like ls star kind of stuff here. For file in star, we do echo the file name. We close nested for loop here, and then we go one level up by cd ... Then we close the topmost for loop with the done. So this will do what? It will first enter into the documents folder, print out each file name, come out of it. It will enter into the music directory, print out each file name, then come out of music directory. So this way for loops will operate. This particular variant of for can be used. So let's move on to another example. We start our script with hashbang user bin bash. So iterating over a list of array. So array will cover a later section, but just for this particular purpose for this code, we write that color list is equal to, then we write red, green, blue, yellow, black, white and purple, and we close it with single parenthesis. Okay, this is how we are defining a list. So let's write the for statement. So here we write that for color in $, that color list at the rate this one. This is basically list or array, and this is how we will iterate over the array. Do what? That we echo color. So in this way, what happens that the for loop picks up each element of this array and iterate on them. And we say done. This way, it will print out each color that is defined, that red, green, blue, etc. And it will come out of that list, iterating over that list. So let's see another one, iterating over a list. We just added a separator here. So here for animal in, now previous example what we have done, we have separately declared a list, and now here we are defining the list itself inside the for, and here the list starts with cat, then dog, then bat, rat, lion, tiger, pig, duck, chicken. Okay, and we close the list and we use the semicolon and write do, and then we echo animal and then animal name and we close. So these are the two typical way of using for iterating over a list. One is we define a list separately, and the next one we define the list itself inside the for. So let's look at some more example. So hashbang user bin bash, and here what we will be doing, using the output of a shell command. So here the list will be output of a shell command. So for ele, I'm writing as the shorthand of element. For ele in, now within the backtick we are getting the sequence 0 to 20. So sequence is a bash command that will generate the integer sequence from 0 to 20, and this will create a list itself. Sequence 0 to 20, do what? Echo the number $ele and done. This is another way of using this particular for variant for a sequence of numbers, integers. So let's see that for ele in ls dot slash inside backtick we are using. So this is another thing, that physical files on which we can operate, like backtick ls dot slash we can see, and then echo the file is the $ele. We are done with this particular set of examples. We have seen the variants and there are a lot of their examples, and we can easily use it now. So here in the next section, we are discussing about the while loop. So let's begin. While, here we are just talking about the syntax, while, then condition, then within the rectangular bracket we write condition, and then semicolon, then start, then write the do keyword. Then we define our action. Action means the statement here, and we close it with done. So inside while, we know that generally we use break and continue. These we also can use inside for, but for while we mostly use, because sometime we need to break the while loop, okay, and we don't have a loop control structure here in while, so we use break or continue. These are more often used. So these two keywords are similar to C style, okay. So this is a syntax. Let's look at some example. And here we start with hashbang user bin bash I equal to 0, while then $i less than equal to 20, then do sleep 0.5. If $i equal to 10, then we echo continue at 10. So what we have written here so far, that is while, we write the double parenthesis, inside that we write I less than equal to 20. This will control the loop. Then we write sleep is just a command which does make the command from sleep for a while, and we give the amount of value, and if $i equal to 10, then echo continue at 10. So we are using the continue statement here. We write I++. So that's why we have discussed the double parenthesis operator at the beginning. So here you can see that we are using it, and then we write the ls I equal to 18, then we are breaking at 18 and we use the break keyword. So here we'll be not incrementing since we are breaking out the loop. And we write the else, we write the counter I and p, and then we are writing I++. just to increment the counter. So this is an example of while loop and how we can use the continue and break inside it. So we are done with this example. Let's move on to the next. The until loop. This construct tests for a condition at the top of a loop and keeps looping as long as the condition is false, which is opposite to the while loop. Okay, so while loop operates till the condition is true and until loop operates till the condition is false. Here we write until, then the condition, then do, then the commands, and we are done. This is a typical structure of the until loop. And let's see some example just to get a clarify. We start our script here and we initiate I equal to 0 until $i greater than 20, do escape, and I equal to 10, then continue at 10, I plus plus, the continue. We are using the same example that we used in while. You guys check what is the difference. I'll not tell. That is your exercise. You check what is the difference in between the two. That's how you will be able to make the difference in between while and until loop. So LF here, I equal to 18, then we echo breaking at 18 and we use the break keyword. And else, and then count equal to $i, and we close the if with p. And then we use the increment counter I plus plus. And then we close the until loop with done. So here guys, I have given an example. I tell you to just try out this at your end in bash, and you see how the while and the until are different. And by running an example, you will be more confident how these two are operated. In the next section, we are discussing here the select and infinite loop. This is an infinite loop, and let's see. The select loop provides an easy way to create a numbered menu from which the user can select options. This particular select loop is more towards creation of a menu rather than any mathematical operation. In Linux or Unix, we have sometimes during the installation, it is asked that which option to use, and like that kind of command prompt we can create here with the select loop. It is useful when you need to ask the user to choose one or more items from a list of choices. It has no conditional checks at all. So this third point is the most important because we don't have any conditional checking. It will rotate infinitely. The only way out of the loop to use the break or exit. In previous example, we have seen the break, and also we can use the exit. This way we come out of the select loop, but we have to write a condition, otherwise we'll be stuck forever. So let's see an example here. We begin our script with hashbang user bin bash. Then we write select option in. We will use the variable option in the list. That list is erase, format, install, partition, and leave. Then we write do and echo option selected. So when this code is executed, right, it will ask for an option. Once you give the option, right, it will go, the variable go inside the $option. Okay. And we are using case option. Case statement we have just learned few slides back. And erase, we are erasing the disk space. We are echoing. Format, you have chosen to format the disk. For install, you have chosen to install Ubuntu Linux. For partition, we are preparing for repartition. These are just message. These are not real one. We are just exemplary purpose. Okay. Leave, we are exiting, and we use break. See here, we have used two commands and they are separated by a single semicolon, and the final delimiter is double semicolon to close that particular code block. And for any other option, we echo, please enter the correct option. And we close the case here with the opposite of case isAC. And then we close the select loop. So this select loop operates forever, and it asks in between you pick the option, right? Erase, format, install, partition, or leave. So this way, any of these options will be given. It will pick that particular option. Better in the beginning, we can print that the please enter the below options, giving the list of options. That will be more user friendly. Here, just for quick example, we have used it, and we will break out this particular infinite loop with the break here, and we have seen that concludes the example of select loop here. Let's move on. Here we will be discussing the file operations. Like I have said in previous episode, the file operation in Bash not versatile as C or any other programming language, but still we can use some of it for the cases we need. But for extensive file operations, here is not available. So let's get familiar with whatever is here and that we can use for file operations here. Reading a file. Let's look at an example here. The hashbang user bin bash, and we read while loop. We are using a while loop to read a file content here. And we write first cat then $filename. This $filename will contain the name of the file, pipe, and then in the next line we write while read line. Line is a variable which will contain each line, and then we write do, and then echo the $line with a kind of prefix so that we can differentiate, and then done. So this way we will iterate over each line inside a file. So guys, you can see here it is not very robust as you have seen, or not syntactical that we have used in C or any other language, but still we can use for reading a file. Let's see another type of or another way of reading a file in another example here. Start our script here, and we are using while to read a file content, and file name is $1. $1 is the first argument of the script here, and once we execute the script at the first argument, just after the script name, we will give the file name. If we are checking here, this example is not just an example, but it will also use the file test. So if -r, then we will file name. If it is readable, then the contents of the file are echoing here, and while read line, we use this and echo $line. And done, and this $file name. Another thing is here, what I mentioned was a bit mistake, right? And the redirection, file redirection comes at here. This $1 comes from this redirection operator at this done. So we have a left arrow here and then $file name. So file stream is redirect from here, and this is how we are reading a file name. And obviously, but this file name is not directly read by this if command, but rather than by this particular file name. And the file name we are getting from the command line as the first argument. So this is here I have cleared out. Then we echo end of $file name. We are using just checksum, just for a tryout, and we write else. We cannot read the file name. If it is not readable, then we'll say it is not readable, and we close the if. So here we see that the file stream redirection can be used in the while for reading a file. And with this example is another type how we are reading a file line by line. In this next example, we will be talking about the appending some text to a text file. Okay. So let's see the example. We start our script, and we here use the read command to get the file name. Then check that whether that file exists. We echo the file exists. The first condition is necessary because if that file does not exist, we cannot append text to it. Then the next is if the file has write permission, then enter text to append the file, press Ctrl D to exit typing. Then we write cat the redirection operator to file. Okay, what happens here? This command will open the command prompt, and whatever we are typing that will get appended in the file. We write else the file do not have a write permission, which is part of the if checking, right? And then we close the if. If the file do not have the write permission, we cannot write inside it. So this else will go in that condition. And the first else if the file exists, and then we give the message that if the file does not exist, we write the file do not exist, and we close the if. So this example gives you an overview how we can append some text in the file from the command line what we are typing. By these examples, you can see that the file operation in Bash is quite different from C style or any other programming language. Okay, so we are not opening a file in a write or read mode and operating on them. And so it is very different. So the extensive file operation, that's why it is suggested that you use another programming language that is suitable for your application. Let's go to the next section. Here we'll talk about functions and code blocks. Functions we know, and we'll get familiarized with code blocks here. Functions. The basic difference between procedure and function is function return a value, whereas a procedure don't. In TCL we have procedure, right? And any other languages we have procedure, also called proc. So the basic difference we just stated here, the procedure do not return a value, whereas a function return a value. From C, if you remember that we have a return value in each function, so based on the return type. In shell, there is no such distinction. In practice, more used as procedures than functions. Why? Because here we don't have the various data types, right? And that's why we mostly use function as procedure. The reason for this, the shell function can only return a single byte. By definition, the function will return a single byte, which is captured by $?. And the valid range of this particular will be from 0 to 255. Now that's why we cannot use function as a function, that is a function concept from C, but rather use it as a procedure here. Thus, mathematical usefulness of a function in shell is very much limited. So let's see some examples here. We start our script here and then we write odd even, and the way we are writing here, this is the function, then the function name, then opening and closing braces, okay, and then we start the curly brace, and then inside it we'll write the code of the function, and we write if 1 modulo 2 is equal to 0, then $1 is even, else $1 is odd, and we close the if with phi. And then we close the function with a closing curly brace. So this is how we define the function odd and even. Now how we are going to use it? So here we can use it as odd even, then we write 4. Once we write it in our shell script, right, this will execute, the 4 will go inside the function, then according to that, the particular echo will be done, whether it is even or odd. Similarly, given for 5, 21, then 54. So this way we can use a function. So this is a very simple example where we are playing with the mathematics here and we can use a function. Here we can see it do not have any return value. Here we don't have a return command and we are using it just as a procedure that do some procedure inside it, and accordingly we see the result. But it is not returning any value here in terms of mathematical returning I am talking about. The local and global variable. So let's see with an example here. So we write number equal to 4, echo number, then function print, then local, we use the local keyword here for number equal to $1, then echo number equal to $number, and then we close the function. And then we write print 7, then we echo number. Guys, I would like to say that you try out this at your end, this code, and see how this is behaving. I am explaining although here, and when we initially we have written 4, okay, and we echoed it as a 4, but when we say print 7, this 1 goes as a first argument, right? $1 as a first argument of the function, and it goes to the local. This is a local value of the number, and it is echoed as that local value, and where we'll get 7. So it will not print 4, it will print 7. This way we are getting the local and getting a concept of the local and the global variable. The code block. Let's look into the code block. Block of code, also known as inline group, creates an anonymous function. Variables inside a code block remain visible to the remainder of the script. So we have just given the definition, and let's see just a short example. We write a equal to 111. Within the curly braces, right, this is a code block basically, and we write a equal to 222. And we echo a equal to $a. As a result, we get 222, a value inside the code block. So this is a code block. This is an unnamed code block example. So let's see more example. We start our script with #bang user bin bash. We start our script with user bin bash. And then we write file equal to etc/passwd. Then we write unnamed code block. We start our code block with the opening curly brace. Then we write read line 1, read line 2, and read line 3. We have previously know about the read command. And then we close the unnamed code block with a closing curly brace, and we redirect a file inside it, okay, the $file. So this will do what? The first 3 lines will be stored in line 1, line 2, and line 3 variable. And then we can echo $line 1, $line 2, and $line 3. So this is a example of a unnamed code block. Here we are just seen one example of the unnamed code block, and let's move on to the section of the named code block. A #bang using the $array and a code block. We start our script with #bang user bin bash. My code block, we define the code block name and we write the code inside it. That for fruit we do echo I really like the fruit. We close it, the block, and how we use it? My code block, and we give the list of arguments, that is apple, banana, and oranges. The inside this particular named code block, the for loop is there, and it will iterate on the arguments, and each time it will print out the echo command that I really like the fruit, then the fruit name. And another example here, then we write some more fruit name here, my code block. So this way, and this is a named code block which can be used. So let's move on to the next section, that is array operation. Array in Bash. Bash support only one-dimensional array. Array elements may be initialized with variable, then within rectangular bracket, then the variable counter, okay, or the size, okay, the notation, okay. To dereference an array element, we use curly bracket notation, that is $, then start of the curly bracket, then the element, and then the index, and we close the curly bracket. Array members need not to be consecutive or contiguous. We'll come to this. We can have indexes like 0, 1, 2, 3, 4, but we can get a discontinuity at 5th index, okay, and then we can have the 6th index, okay. So like that. That is the meaning that array members need not to be consecutive or contiguous. Some member of the array can be left uninitialized. Array can be declared using the command declare-a. This declare command is a bash command, okay, and it can be used to declare array using declare-a. We'll see through examples, okay. So let's move on to an example here. We start our script here, declaring at once. So we write the entire array in one go. Students equal to then single brace pair, okay, within which write space separated, Dave, Jennifer, Michael, all the names, okay. And then we echo contents of the student array. So it will echo the entire array at once. How? Then we write $, then within the curly braces, student, and then @. This is the particular syntax we will be using. Here what we do, we echo the number of the elements. So what we do, equal to $, then start the curly brace, and then we type hash and then students array. So this will print the elements, the number of elements inside this array, 5, 10, whatever the number, okay. So it is another way of writing. So instead of @ we are using star here. And if we want to echo the indices, okay, each index or all the indexes at one go, we can write here this particular syntax. So $, then beginning of the curly brace, then bang, then student, then @, then we close the curly brace. So this is how we are getting the indices. And the third index of that, how we print it, that $, then students, then 3. This is the syntax. So these are all sort of handy tool set to deal with the array. Let's look into another example. We start the script here, declaring at once, okay, then printing the array by iterating one by one element. For index, okay, so we are using the index variable with the name index. We get the list here, $, then bang, the students @, okay. We are getting each index at every time. Then we write that echo, then the $, syntax is here, and at the place of index, we are using the $index variable, and I close it, okay. Then done. This will iterate, the for loop will graze through each of the indexes, and for that index the value will be printed. The next command here, we use unset then students 2. This way we remove one element from the array, okay, and the corresponding index will also be removed. As I said in the beginning, that array need not to be very continuous, okay, so there could be discontinuity. So this way we can remove and create a discontinuity. So let's see another example here. This way we are defining the array one by one. Say 0, the 0th index, 1 index, then 5, then 6. Okay, so in between we have skipped the all other indexes and it is okay. And 6 is pen, 7 is we write expr, then 0 plus 1, okay. And then we write 8, as well as here we are using expr operation, okay. And we echo the 3. Here we do not have a 3, right, the index. Then it will not print it, okay. Just the element 7 is, it will print the sum of the 0th and the 1th value of the array. But the below state will not do anything between the string and the integer. If we look right, 5 and 6, okay, there one is an integer and is a string, so there will be no operation. So there will be 8 will be blank here, okay. So this is another example of the array. So you can see how you can define an array one by one, okay. And in previous example you have seen to define an array at one go. So let's look at some more example. So we start our script here and reading the array from command line input. Here we write echo the array commands and we use read -a then array. So -a is for reading an array. So if we give a space separated value, can enter array. It could be integer, it could be strings, okay, anything. And it will be stored in the variable array. And we can echo it. And the number of elements stored, these two representation and indices is this script. I'll ask you to try out at your end and see how it is doing. And here at the last, we printing the indices in a sequential order. We write a for in index and we use a sequential 0 to the dollar, then within the double parenthesis $array. This gives the total index number -1 from 0 to that one. As we know that we have 5 elements, so the indices will vary from 0 to 4. That same thing we are creating here and we are varying. Here we know because these do not have a discontinuity as we are giving in a sequence, proper sequence. So we don't have a discontinuity here and this way we can iterate here. And we print out the index and the values like this and we are done. So in this next section, we are talking about the associative array. So associative array, it is very much like that we have a key and a value kind of thing. In an array, we have a key and a value rather than a numerical index. We have some maybe it may be a string index. The associative array is defined in that way. In Perl, this concept is defined as a hash, or maybe in Python it is written as dictionary, or if you go to Tcl, it is also called associative array, and some more data structure is called dictionary. Okay, so these are the variants, and in Bash we have this associative array, but obviously one dimensional. In any of the variation of array will be one dimensional, and we don't have more dimension in Bash. So that is the limitation. So here we see we start our script with user bin bash and the associative array. And here we are using declare -a then Beatles. Okay, here we see that Beatles equal to singer equal to John, bassist equal to Paul, drummer equal to Ringo, and guitarist equal to George. So this way we are defining the associative array. So first we declare it and then we use it like this particular syntax. We are writing an associative array, and you can see here the index are not numerical, they are strings. So here we write for musician write the list explicitly, singer, bassist, drummer, and guitarist. Now we do what? We echo. The musician is musician. Okay. And this way we'll iterate over the associative array. Done. Iterating by array indices. So here we get all the index in the index value, rather than in the first we know explicitly, in the second case we do not know explicitly. Okay. In the associative array, what are the index? In this way we will be iterating. Okay. And here again we are printing the index and the value, and we are done. So guys, this is the array. So after talking about this array section, I would like to mention that in the previous episode I have mentioned that Bash has multiple limitations. One of that is we have only one dimensional array, and hence the structure, if anyone wants to use, he has to switch to any other language. But for one dimensional array you can use easily in Bash. Back guys to the third episode of Bash programming. In today's episode, we are going to discuss get opts and while loop, how together we can use them. Printf command in Bash, this is similar to the C printf. String length test, regular expression in Bash, SED pattern matching and substitution. Two kinds of regular expression, BRE and ERE. We'll discuss in detail. Let's begin. First topic here is get opts and while loop. This get opts is a very powerful tool, parses command line arguments passed to the script. This is the Bash version of the get opt library function, similar to the C language. Let's see an example here. Start our script here and then while get opts, then RWX within single quote and then option. So here the get opts will get all the options from the command line, and the feasible options are RWX. So this is first of all the command line switches, that is comes with a dash. So the options will be -R, -W, -X, and the option variable will contain each of the arguments. Let's see at the next step. We write do, and then we write a case statement. $option in first case R echo read. So this is for read. We just echoing here. We are for a simple example here. We are echoing the read. Then W is to echo write. X is to echo execute. Then we close the case. then we close the entire while loop. So this way we can use the get opts along with the while loop to define a set of command line arguments which will be specifically used for particular purpose, each of them. So let's see when we execute this particular script what happens. So guys, first we have the script ./getops.sh. This is the name of the script, and then we provide 3 command line switches. So here you can see there is -r, there is -w and -x, and there is a 4th argument abc. So here the getOpts will operate on the -r, -w and -x, and in the left hand side you can see that getOpts, this particular, when it is used with while, we can access each of the r, w, x in the case command. Okay, so once we execute this line, we get the outputs, 3 different outputs: read, write and execute. Each case here is considered because we have given the 3 out of 3 command line switches that we have specifically defined. This kind of command line switches you may come across when you go to a man page of a Linux inbuilt command. So you can see multiple such switches there which are defined for a specific purpose. Similar way, when we write bash script, we can also define specific switches according to the demand of our script. So this part is done. Let's move on to the next section, the printf command. The printf command is an enhanced echo. We have so far used echo, but in bash we can also use p like printf. It is a limited variant of the C language printf library function. Typically C is the first language that we learn, and there we use printf, and any language next we learn, we look out for anything similar to printf, okay, to display echo something on our screen. So here this printf command is a subset of C language. It has a limited functionality, but okay, anyhow the basic things you can do. Its syntax is very close to the C language printf. It is not same, but it is very close. We'll show an example by which you can come to this point. Its usage is like printf, then within single quotes, the formatted string, that is that %d, %i, etc. and the parameter. Parameter means here it is like the variable whose value we want to print as a formatted string. So this is a particular format how we are going to use here. There is no parenthesis here, so it's have to be used like this. So let's see an example. We start our script here with hashbang user bin bash, and we set a equal to 55, b equal to 22.5 and c equal to Peter. So these are integer, floating number and the string. So how we can print this? Printf a equal to %d, then we give the \n, we close the single quote, and then within double quotes we mention the variable $a. So here if we execute this, it will print out a equal to 55. Similar way, for b, we write b equal to %f and then \n, and then within double quotes the $b. So you can see that here basically what we are doing is we are using the same kind of representation of the formatted string that used to do in C and the similar in bash. Let's see the string here equal to %s, then \n, then in double quotation that is $c. Guys, I would like to ask you to try out at your end and you can see how the result is coming. And one more thing, here we can use the \t, \n, all those stuffs that we used to use in C language printf. It's good to explore, and let's move on to the next section, string length test. We have printed a formatted string, and when we are dealing with strings in bash, how we can test the length of the string here. Testing a string is 0 length. So what we use? The -z, then string. It validates a 0 string, and -n, then string validates a non-zero string. We'll see an example through which we will actually understand that how these two give us a return. We start our script here, hashbang user bin bash, then we write str equal to beautycat echo, then we write our if command, if within double rectangular bracket we write z, then $str, then keyword, okay, and then we write echo 0, else we write echo non-zero, and we close the if. So in first case, the positive return will come as if this string is validated 0. So it will go to the if condition and it will print 0. We define next string as brown rat and we echo it. Then we write the if -n $str2, and within that if what we write the condition is echo non-zero. So you can see the difference that the positive return coming from this n when the string is a non-zero. we write the else command here and we write the statement echo 0. So, and we close the if. So in these two cases, you can see that in one case, when the string is 0, it will do a positive return. When it is another case, when the string is non-zero, it will give us a positive return. These two serve the same purpose but in a different fashion. So this is how we can use it. Let's execute the script. If I execute, what will happen that beautycat echoes non-zero. So the first if condition, we can see here that it will echo non-zero because the string is non-zero. In the second case, we can see that the brown rat, it is also non-zero. So it is showing the non-zero. In the first case, first if, it enters into the if condition, it checks out that this is not working. So it goes to the else. But in the second case, it goes to the if condition and satisfied and it do not go to the else condition. These are the two conventions of taking a 0 or non-zero string length. We are done with this section. Let's move on to the next section. Regex is a short form of regular expression. In this section, we will talk about the regular expression in bash. The equal to tilde operator acts much like its Perl equivalent. So here, this operator in bash we use for a regex matching. It treats the right hand side as an extended regular expression. So let's see some example here. Start our script here with hashbang user bin bash. The comment and the uncomment below packages and then run. So this is tried and tested script, and here I have given this command just to when you will run, right, after writing this script, you can comment and uncomment the below comments and see the results. So this is the package name, then we give a different package name. So this is here I have chosen the typical installer packages, right? The Debian and then the RPM. Okay, Debian is for Ubuntu or the Debian series. Okay, RPM is for another kind of Linux distro. Let's come to the testing here. We write here the package name is equal to tilde. Here we are checking the regular expression, then dot slash, then backslash dot deb. The backslash actually makes the dot a non-special character and it treats as is a dot. But before that, the dot and the start are part of the regular expression. So I'll come to the description later words. Let's see the example first. And we echo the package name is a deb package. Else echo the file package name is not a deb package. And here we close the if. So in this particular regex matching, we have done the very basic matching. In this, we are checking whether this package name that we are under concern as a package name is a deb or not. Here we have used deb from the Debian series and RPM. So these Debian and RPM, it will check the file extension here and accordingly it will echo whether it is a Debian package or it is a non-Debian package. This is the purpose of this example. Let's move on to the next section. We are displaying another example here. Hashbang user bin bash. We start the script. Similarly, comment and uncomment as we have done in the previous slide. And here the packages names are there. And here what we are doing is that we are doing package name equal to tilde. We are matching groups. So there are 3 paired parentheses and they will match to 3 different particular strings. And here we write echo package, then check. This is very new thing to you. $bash, then rematch, then 1. So this is an array which will contain each group that is identified by the pair of parentheses, and this will stored in an array. The array name is bash rematch, and each of the group item can be accessed with bash rematch 1, bash rematch 2, bash rematch 3 like that. So in the next line, we echo is for the bash rematch 3 architecture. I'll ask you to run this example at your end and see what is the outcome. This is tried and tested at my end, so I'll not go in detail because regular expression is a way that you can match text, but you have to run it in hand to get the exact knowledge. Okay. So here I close the if and then else file package name does not appear to be a match. So you try out with the 3 different package names mentioned here and you will see how the result is coming. The another echo is there, standard deb name naming convention. The total echo will be file name does not appear in the match, standard .deb naming convention. So here we are checking the .deb naming convention and we close it with P. So this is an example where you can check the regular expression. Detail of the regular expression I'll come later. What are the syntaxes? But until or unless you have an example in your mind, it will be difficult for you to grab the idea of the regex. So let's move on to the next section. Here we are talking about the SED. This is another binary available in any Linux distribution. SED is a stream editor. Now let's see. A stream editor is used to perform basic text transformations on an input text stream. And what is an input text stream? A file or an input passed through a pipe. So when we are typing in a Linux command line, either we give a file or we give something by pipe. SED works by making only one pass over the input. So whenever we are using SED and we are operating on a particular text stream, either through file or through pipe, it will give one pass. So that means it will do one-time scanning. It will not do multiple pass or multiple scanning. So it will not do multiple pass or multiple scanning, but it will only do single pass. That is single time scanning of the entire text stream. Let's see how SED can be used. SED, we start and then within single quote we write s, then hello, then world of the input text, then a redirect to the output text file. Here, this is the first thing. So we write s is for the substitution, and then hello is the word which we want to substitute with the word world. And then comes the text string, that is input.txt. And if we do not use the redirection operator, this will just show the output on the screen and no changes will be there inside the input.txt. Although it operates on a text stream, but it do not actually touch the text stream. Anyway, it do not interfere with the text stream, but it produces a separate output and we have to capture the output in a separate file. This is by default operation. Another way is that we write SED, then within quote s/hello/world, then left arrow input.txt, and then the right arrow to the output.txt. We know that left arrow is a stream input. Either we can mention it or not mention it, but it remains the same. Here we give an example how a pipe can be used for SED. So here we write cat input.txt pipe SED, then s/hello/world. We close the quote and we redirect it to the output.txt. So this is the way we are using a pipe statement here. So I'd like to ask you just to try out such things at your own, so to get very much familiar how these things are operating. In this section, we are talking about command line options, and the following command modifies the text file and does not produce any output. So SED-I, then s/hello/world, then the file.txt. In previous slide, we have seen that when we are using a input stream, SED by default is not affecting the input text stream. In case we need to change or affect the input text stream, we must use -I. Here we have shown this option. This is one of the important option, right? But in general practice, when you are learning, it's better that you avoid I and try it without the I, so that you can see whatever you are doing is coming as output while the input is remaining at the intact. So next command line option is -E. It gives the editing instruction to SED. The next one is -F. This is a file name or a script. Okay, SED can have its own script, the set of instruction we can write into a human readable file and pass it to SED engine by -F. -N suppresses the automatic output of the input lines. So here I was said in just previous slide that whatever operation SED does, the SED actually echoes it to the screen. But in case we need to stop the echoing, we can use -N. So these are the basic command line options of SED that we can use. Let's move on to the next section. Suppressing a line. By default, SED prints all the processed inputs. We can use -N to suppress the output and -P command at the same time to print specific lines. The following command prints only line 45 of the input file. SED-N, then within single quote 45, then P, okay, then the text file. So here we are using a SED command, that is 45 is the line number, P is the print. This goes to SED and it prints only the line number 45 and rest of the lines are suppressed. The following example prints the line of 1.txt and the last line of the last file p.txt. So here SED -N, then within single quote 1p semicolon $p, then 1.txt, 2.txt and 3.txt. What it will do, the following example prints the first line of the first file and the last line of the last file. This way we are using. So you can play it around and see how you can vary, because it is a non-destructive output. Non-destructive, that means the input remains intact. You can see the output on your screen and compare. So this way you can try out. If we want to reverse this behavior we have just mentioned, that is in the previous bullet, right, we can use -s. I'll ask you to try out at your end. Set exit status. So exit status is a very important thing because when we are running a command line tool in a script, we do not know how it exited. So capturing exit status has been already discussed in my previous episodes. So go out and watch there in case you are difficulty to recall. Let's begin this particular section. An exit status of 0 indicates a success and a non-zero value indicates a failure. GNU said, that is, GNU is a development in Linux, right? GNU said returns the following exit status on error values. 0 is a successful completion. 1 is invalid command, invalid syntax, invalid regular expression. Okay, so it gives a invalid whatever. It could be command, your syntax or regex, whatever you're using. 2 is the exit status. One or more of the input files specified on the command line could not be opened. That is, the file is not found or the read permission is denied. Processing continued with other files. Okay, if there are multiple files are there, in case of one file or two file it is there, it will issue the exit status to and it will continue with the other. 4. An IO error or a serious processing error during runtime. The 4 exit status means that there is some error in the IO. Okay, we are using pipe and whether we are redirecting an input text file. Okay, in that process something wrong happened. So in that case it will do issue exit status 4 for SED. We are done with this particular section. Let's move on to the next section. In this particular section, we are talking about the regular expression engines, that is BRE and ERE. So now what is the regular expression engines? So basically this is the engines that takes care of the regular expression that you give to match with the text that is in our concern. In Linux world, there are two popular regular expression engines. The POSIX basic regular expression engine, that is called BRE. The POSIX extended regular expression engine called ERE. So these are two types of engines that has been so far in POSIX, that is the Linux system. Most Linux utilities at minimum conform to the POSIX BRE engine specific. Any Linux tool that are supporting the regex at least supports the BRE. ERE could be there, could not be there, that we have to check the man page. SED only conform to the subset of the BRE specification. Here, SED by default conforms to BRE, but not the entire BRE defined by the POSIX, that is the Linux system, but a subset of that. The POSIX ERE engine is often found in programming language like Java, Perl, and Python that rely on regular expression for text filtering. So we know that the Java, Perl, and Python, these are widely used for regular expression matching. And in these cases, these engines have the ERE. These languages regular expression engine is ERE, not BRE. Okay. It provides advanced pattern symbols as well as special symbols for common patterns such as matching digits, words, and alphanumeric characters. We are talking about ERE here. The GNU-AWK will come to the next episode on AWK. The AWK program or GWAK, it is the binary, could be AWK or GWAK. GWAK means it is GNU-AWK and AWK is the old one that came with Unix and Linux from the beginning. So we will talk about GWAK because that is more up-to-date one. When we refer AWK, we generally refer as GWAK. So the GNU-AWK program uses ERE engine to process its regular expression pattern. So by default in AWK, the regular expression engine is ERE. Whereas in SED, by default, the regular expression engine is BRE. So here we have discussed the BRE and ERE, these two type of engines. Now let's see about them. So SED ERE. Here we are talking about SED and we are giving the description of the ERE. Command line switches for ERE. As discussed in previous slide, right, we have the BRE by default, but in SED we also have ERE, and to access that ERE engine, we must use a couple of things. Here are they. The -E, the switch, -R, -regexp, -extended. Any of these three can be used to turn on the ERE engine that is inside SED. Use extended regular expression rather than basic regular expression. What this does, either of these three command line switches does. ERE can be clearer because they usually have fewer backslashes. So guys, if you have come across Perl or Python or Java, right, you know that the regular expression matching there is less complicated because we are using less backslashes there for the regular expression matching, okay? And we only use the backslash there when we are trying to convert a special character into a regular character. GNU-SED has accepted -e as a undocumented options for years and BSD. SED have accepted -e for years as well, but scripts that use -e might not prompt to other older systems. So we are talking about system specification, but still at my end, when I try with our latest systems, we can use -e very easily. The special characters recognized by the regular expressions are, so here we are going to talk about the special characters. Dot, star, rectangular bracket, caret, dollar, curly bracket, backslash, plus, question mark, pipe, then parenthesis. Guys, just take a snapshot of all these characters in your mind. These will be going to use for the regular expression matching. We are done with this section. We move on to the next section. So we are talking about SED, BRE and ERE engine here. In GNU-SED, the only difference between basic and extended regular expression is in the behavior of the few characters, that is question mark, plus, parenthesis, braces and pipe. With BRE syntax, the characters do not have special meaning unless prefixed with a backslash. While ERE, the syntax is reversed. There, the characters are special unless they are prefixed with a backslash. So, we mentioned these special characters and also in the previous slide, right? So, these special characters in BRE, we have to accompany a backslash at first, but in ERE, we do not have to do that. And these are the two conventions that are different, or rather specific convention to BRE and ERE, and that's how BRE and ERE at user end comes as a different, okay? So here in this table, let us see what happens. Here, let me bring my mouse pointer so that I can show. So little plus sign, okay? We echo this a plus b equal to c into a file foo, okay? Here we have dumped this data in foo, and then we use sed-n and a plus b and p foo. So it gives a plus b plus c, okay? And here we use a plus b equal to c, dump it, okay? And to do the same thing here, to match the plus here, right? What is happening, right? We have to use a backslash. So here, if you see, right, this plus is treated as a plus and not as a special character plus here that we have mentioned. And in the right hand side here, dealing this, by default this is a special character and we make it a normal character, right? We have to use a backslash. So since this is used as a single line, right, this will just show this one, right? And try doing this, right? You remove this backslash and try to print, right? Here it will not come out. So the syntax, if you keep same in both of these operation, right, what will happen? That in one case it will work and in another case it will not work, and vice versa. Say one more example here. Echo AAB and we dump it into foo, and we run our SED right here and we check. This is just matching. Here we are matching. We are doing the matching only, not the substitution. And here we use plus as a special character. Here we use plus as a regular character, and here we are using it as a special character. So we include backslash. So what will mean that this will match with two A's here. Okay. So I think this is plus means that one or more times. So A comes here one or more times, that is two times it here, and then B. So this will not match A plus B, rather A, if it is there A, that is AB or AAB or AAAB, then this regular expression will work here. And on the right hand side, to do the same, we just give the plus sign and remove the backslash. So this is the basic difference between the BRE syntax and the ERE syntax. This table with two different examples we have shown. So I'll request you to try out at your end these two examples. This is a simple example. Try out and see the difference. Try both these things, that you keep the backslash and remove the backslash, and in the same sequence you compare this. Rather, you can write a script. Inside that you can put all of them, all the combinations, and see the results. Okay, so we are done with this section. Let's move on to the next section. Here we are talking about SED BRE syntax. Now we will go in detail. This star, the special characters here. The star matches a sequence of 0 or more instances of matches of the preceding regular expression, which must be an ordinary character, a special character produced by backslash, a dot, a group of regular expression, or a bracket expression. So star means it will match 0 or more time the particular thing is present. So it could be a character or something like. Dot matches any character including a new line. So any character it matches. Caret matches the null string at the beginning of the pattern space, that is string. So later I will come to the different examples of SED. There you will see how these characters are being used. Dollar, it matches same as caret but refers to end of a pattern space. Here by pattern space, what we can understand, it is a string, beginning of a string or end of a string, or if it is a line, the beginning of a line or a end of a line. So this pattern space means particular text stream which is captured inside delimiters. The backslash plus here as start but matches one or more times. The plus means one or more time. The question mark, backslash then question mark as start but only matches 0 or 1. Question mark means it matches 0 or 1 time. So here it is backslash I then slash, it is as start but matches exactly I sequences. So here you can put a decimal integer and the range will be from 0 to 255. So you can give the range of this matching here because these three like star, plus and question mark, they are limited to their use. But if you want to extend the matching of the character, right, in that case you can extend the matching or be specific with this particular syntax. Then ij, it means matches between I and j, inclusive sequences. So here you are giving a limit from I to j. And this particular syntax you are using matches more than or equal to I sequences. So that means I sequences it could be, okay, or more than that. So here we are matching the group. So here each of the parentheses is preceded by a backslash and inside that we match a group of text. We can match multiple such groups in a particular string and each will come to one particular RE match. Okay. So backslash n matches a new line character. Then regular expression 1, pipe, and pipe has to be preceded by backslash, matches either regular expression 1 or regular expression 2. So guys, this is the full set of PRE syntax that we are using for regular expression matching. Let's see some example here. A, B, C, D, E, F. If we use that string for matching, right, it matches A, B, C, D, E, F. Then if we use A star B, this matches 0 or more A followed by a single B. So for example, B or A, B. Okay? So star is 0 or more times. This can match A star B with B or multiple A then B. Okay. A then question mark then B matches B or AB. A then plus then B then plus matches one or more A's followed by one or more B's, like AB is the shortest and then multiple A then one B then one A then multiple B or multiple A followed by multiple B. So this can match it. So this is how regular expression matches. Then if we write dot start or dot plus, both matches all the characters in a string. However, in the first case, every string, while in the second matches only the string containing least one character. Because plus is one or more times, right? At least there will be one string. You will see some examples and at your end you can try out, because until or unless you try out the regular expression at your end, it will be difficult to grasp the utility of a regular expression. So here, if we enclose these characters, right, A to Z, then capital A to capital Z, and then 0 to 9 within a rectangular bracket. This matches a sequence of any ASCII letters and digits. So it will capture any combination of alphanumeric text. Then caret, then hash. So this matches a line beginning with hash. Backslash, backslash, dollar. So this matches a string ending with a backslash. The regular expression contains two backslashes for escaping. So the first backslash escapes to the escape character for the backslash. Otherwise, it has a special meaning. Okay. Backslash dollar. Instead, this matches a string consists of a single dollar sign because it is escape. So let's move on to the next section, that is SED ERE syntax. The only difference between basic and extended regular expression is in the behavior of a few characters. So these are question mark, plus, parenthesis, braces, and pipe. While in basic regular expression requires these to be escaped to used as special characters, in ERE there is no escape needed. Let's see some examples. In this section we'll see PRE and ERE example compared side by side. ABC then question mark becomes a ABC backslash question mark using a extended regular expression. It matches the string ABC then question mark. C \+ becomes C+ using extended regular expression, and it matches one or more C's. A, then \, opening curly bracket, then 3, then comma, then \, then closing curly bracket becomes without the backslashes in extended regular expression. It matches 3 or more A's. So here in this next one, we also see the \/ vanishes and becomes without \/ in the extended regular expression. It matches either ABCA BC or ABCA BC ABC. Okay, you have to try out to understand this, as I said earlier. So this next one becomes without the backslashes or the grouping, right, when using extended regular expression. And A \, pipe B becomes A pipe B when we are using extended regular expression, and it matches A or B. So this is how the things will be different in BRE and ERE. So you can make a choice whether in which you are comfortable. Okay, you can choose either BRE or ERE. Better you get accustomed to the ERE, because once you move on with the other languages like Perl, Python, there the ERE is used. Better you can remember one particular convention, and that you can recall globally and use in your coding style. So we are done with this section. Let's move on. Set delimiters. Let's look an example. We start our script here, and the set delimiters in substitution is S, then slash, then slash, then slash, then G. In between the first two slashes, we mention the string that we need to substitute, and in the second two slashes in between, we mention the replacement. Okay. These delimiters, anything can be used as delimiter, not only slash. So this is the fact that I have to bring to you. That's why I'm giving this example. And here is the content of the file that I am going to use in the next lines. Remember, the delimiter could be anything. So we write sed, then S / about / nothing about, then G. Okay. And test. We give the input file name. We have dumped the text in test. So here it will replace about with nothing - about. Okay. In the above case. And here instead of slash, we can use colon as a delimiter. We can see. Also, we can use a hash. This is a very more useful when we are thinking of a file path, right? We have to match a file path. Then it becomes very confusing that the slashes inside the path. And so what we can do, that we can use anything other than slash that time, like colon or hash, and we can match a path, file path in Linux, and we can continue the path as is. Okay. So the path actually in the string and the path, the slash used in delimiter, will not get confused if we use a different kind of delimiter. And this is absolutely fine in SED. So next we can see that here you also use the colon as a delimiter. So I'll ask you to try out this example at your own to grasp the meaning. The motivation behind this particular slide is that you can use anything other than slash as a delimiter in SED. SED, the matching lines. Start our script here, printing the matching lines only. In SED, we do the matching by regular expression, right? And we want to print only the lines that is matching with our given text using GP along with N. So what we'll do, get-n, then we write S, then / about, then / nothing, followed by GP, and we close it and give the file name. And here we give a separator just to understand. Ignore the case matching. If we want to ignore the case, right, what we do here, we remove that particular P right here. So this will ignore the case. Try out this particular example. You will see that how it is different. Okay. The test file data is given in previous slide. You will go and try out this thing and see how this two is giving you different. So the meaning will be very clear to you. We have used a separator here just to differentiate between the two outputs. We are done with this section. Let's move on to the next sections. SED, printing the line number. To begin our script, and here we are using like head command, display the first two lines and quit. So SED, then to, then Q, and we close our single quote and then the text. So this does what? It prints first two lines and quit. So here instead of 2, you can use any number, and you can use SED like a head command. You know the head command in Linux, or in case you don't know, you check out the man page of head. Here you can use the SED as a head command and echo a separator here and display the line numbers. Why you are using the separator in the same script, right? If you are getting outputs, right, they will be one after another. And in case you do not use a separator, right, for your understanding, the things may not be clear. This separator will separate out two different lines. So here we write what? Sed, then within single quote equal to then test. Pipe sed n colon is substitute \n with 4 dashes. So you can try out this with and without the pipe. Okay, you will come to know how sed is printing the line numbers. So that's all. First and last word substitution. So guys, before saying anything, I'll just like to mention these example and tried and tested at my end. I'm leaving the trials of these things at your end so that you learn the bash programming by yourself. I can show you, but once you try out at your end, you will get the good understanding of it. So let's begin this example. Start our script here, removing the first word here. What we will do, and sed, then s, then caret, then substitute dash w star, and we substitute with nothing. So here we have done substituting the first word. We echo a separator, removing the first word with the space. So here we have done a different thing here. Then after w star we have put a dot. You must see that how it different. We echo a separator, and then we are removing here the last word. Sorry about the typo here, and O got missing. Here what we do is that S, then slash W, then star, then dollar. This dollar marks the last of a text. So here we are removing the last word, matching, and we are substituting this last word with nothing, because in the next pair of forward slashes there is nothing in between. So this will remove the last word. We'll try out this example at your end. Replacing with a matched phrase. We start our script here. We have a abc.txt. First we cat it just to see what is the content. Then we echo our first separator, substituting the match phrase with itself plus something more. So we have the text on somewhere in the txt file, and we substitute on with itself. Okay, that is %. In the substitution phrase, we can see that within single parenthesis we have %. So we are substituting the match phrase with itself. We echo the second separator, and in the next one we substitute in with %2. So in will be replaced by into. You must try out. You can create the abc.txt as you wish, and you can change the words of the matching words by yourself. The next separator we have echoed. The next, so if we write the script in a script file and give it to abc.txt, you can see. So this is just an example, and in the fourth separator is echoed, substituting the word with boundary. We substitute one with itself, that is %, within the parenthesis. We echo the next separator, and we substitute here the bone and then with %. So try out all these examples. It's all for learning, because when you have to use sed, right, in your specific case, you have to define it. Before that, your mind should be very clear what you are learning and how the sed is working. Try out this example. Okay, let's move on to the next slide. Sed translator. Here, we start our script, and this is a comment, but example we are using here, we are encrypting. So sed for transliterating, we have to use Y, not S. Okay, and then we use slash, and we mention stream of characters A to J we have mentioned, and then 1 to 9 we have mentioned, and in the next after the slash you can see in the example. And what this will do, it will be replacing A with 0, B with 1, C with 3, and so on, and finally J with 9 inside the abc.txt. It will make an output with the changed, but it will not modify, as we know. And here what will happen, that some of the alphabets are replaced by its desired numeral. This is one way you can encrypt a text. No one else will be able to understand. Only you know the mapping, right? Just for a fun, you can try it out. You can write a text file and you can encode it with your own mapping. So we echo here a separator, and we are operating transliteration only to 2 lines, line 1 to line 2. So here we can see that within single quote we are using 1, 2, then within curly braces we write the Y slash A to J, and then slash 1 to 9, and then abc.txt. Come back guys to the 4th episode of bash programming. In this episode we are going to talk about mostly on awk, and the topics that we are going to discuss is as introduction to awk, command line option and exit status, built-in and user-defined variables, fields and records in awk, regular expression in awk, SED and AWK combined. So let's begin. So let's look into the introduction of the awk or GAWK. The GEAWK program is the GNU version of the original awk program in Unix. So nowadays, whatever awk we use, mostly it is GEAWK and it is the GNU awk. So awk or GEAWK can extract data elements from large bulky delimited text file. Awk or GEAWK can produce formatted report from extracted data. The perfect example of this is formatting a log file. So basically, this awk tool is used for report generation from a log file or a ASCII file or a text file. So it reads the file, interprets different fields and can print a formatted output file. We'll see the details in later. Awk or GEAWK program allows you to filter just the data elements you want to view from the log file and then format them in a manner that makes reading of important data easier. So that's what I called the data processing stuff is awk. So let's see more on awk. Programs in awk consist of pattern and action pairs. So pattern means maybe it's a regular pattern and corresponding action. An action without pattern always runs. So example, we can use a print statement. So here we have printed $0. I'll later on disclose what is $0 on later slides. So here within a single quote, what we have written is a awk code or awk script. Okay, this script is different from the bash script that we are going to write. It is the set of commands that are acceptable by awk and can be written in a fashion of script. Here we have written an inline script. Mostly we do write inline script for awk, but if it is a lengthy one, we can write in a file and feed it to awk. We can use hashbang header line to create a awk script that are directly executable. So that is what I was telling. We can write a awk script which will contain the awk readable commands only and feed it to awk. Comments start with hash and continue to the end of the same line. So hash is used for the same single line comment. Okay. You may use backslash continuation to continue a source line. So sometime if the length of a line is too much and we want to continue the line as a single line, but in where we are writing we have to continue that time we can use a backslash as a continuation of a source line. Lines are automatically continued after a comma, open brace, question mark, colon, logical or, logical and, do and else. So these are conventions of awk. Let's move on to the next slide. Awk command line options. So awk is a tool inside the Unix or Linux, right? So it has a couple of command line options. Let's see which are very much important. The awk command line options can be used as, first of all, the binary GEAWK, then option, then the awk script or command. So this script could be an inline script or a file script written in a file, and the input file. So this input file is the log file or typically a ASCII file or a text file which we are processing. Or the GEAWK can be used in a fashion that GEAWK, then the awk script, then the command and then the input file. This way the awk can be used. These two ways, either of them is okay. So let's see what are the options of awk. The first option here we are displaying is -f then fs. Specify a file separator. So -f is the switch and the value will be fs, whatever file separator we are using here. -f file name. So -f is the switch and file name will be the real file name that we are giving. This file name is to be read by the program from. So this is the awk script that we are talking about. Okay. So -v is var equal to value, defines a variable and its default value. And just before proceeding to the next part, just clear out any confusion. First of all, we write a script in bash that we execute in bash. Inside that we are calling awk, and awk itself can call another script which will consist of awk exclusive commands. So that we have just described with -f file name. So let's go to the next point. -mfn. Okay, mf is the switch and the n is the value. Specifies the maximum number of the fields to be processed, to process the data. So this is field. Okay, field you can take as the columns. Okay, this is the maximum number of columns to process the data. Okay. -rn specifies the maximum record size in the data file. So you can take the record similar to a row, specify the maximum number of rows. Okay, r-n. -w is a keyword specify the compatibility mode or the warning level for GEAWK. Okay, so it will issue the warnings if you use that. Awk exits status. If success, GEAWK exits with the value 0. Everything has done perfectly, it will return value 0. If there is an error occurring, the GEAWK will exit with value 1. If a fatal error occurs, the exit status is 2. Here we are talking about the awk variables. Okay, the awk script or program can store and recall values using its own variables. So I said that awk can use its own variable where the commands will be its own exclusive commands, and awk can have its own exclusive variables that in this particular section we are talking about. Okay, so these variables are different from bash and limited to the awk script itself. So that is what I said. These are exclusive or limited to the scope of awk. So these variables are different from the bash variable. These are not bash variable. These are variable local and exclusive to awk. Okay. There are two types of such variables. Okay. First, the built-in variables. Okay. These built-in variables are predefined variables in awk. And user-defined variables. These variables we can define by ourselves, the name of these variables. So let's move on to the next section. The built-in variables. Let's see what built-in variables are there in the awk. Since they are already predefined, we must have a glance with them. The field widths, a space-separated list of numbers defining the exact width in spaces of the each data field. So field width is the space-separated list of numbers defining the exact width in spaces of the each data field. Okay, each field can this much of width. So field means the column. The column, we can define the column width with this particular variable. Okay. FS, the input field separator. So this is a column separator for the input, that is the incoming file on which we are processing. RS, the input record separator. Record, I mean, this is the row separator. Okay, field separator is the column one and the RS is the record separator. Record separator means it's the row separator. Okay, for the incoming file. OFS, output field separator. So this will define the column separator for the output report. ORS, the output record separator. So this will define the output row separator. The OFS will define the column separator of the output file and the ORS will define the row separator of the output file. argc, we know the argc, the count of the command line arguments. argv, the array of the command line arguments. argind is the index of the argv of the current file being processed. Okay. Let's see some more built-in variables. Conv format. Okay, so this is the conversion specifier for numbers. When we use printf, right, that time we use this kind of formatted output. So here the default is %.6g. Error number, system error in the file read or write operation. File name, the file name of the data file used to the GEAWK program. Ignore case, if set to a non-zero value, ignore the case of the character in the string in which the GEAWK command we are using. So this is for ignoring the case. NF, the total number of data fields in the data file. So this gives the total number of columns in the data file. NR, the number of the input record processed. So this is the number of rows in the records that have been already processed. OFMT, output format displaying numbers. So this is again formatting specifier, right? So that is default is %.6g. R length is the length of the substring matched in the match function. R start, the start index of the substring matched in the match function. So when we are matching the regular expression, right, these two comes into picture. We may use them. So we are done with the built-in variables. Let's move on to the next section. User-defined variables. The assignment of a variable has the form of variable equal to expression. It assigns the value of the expression to var value of 1 to the variable x. Okay, let's take an example. So here how we write x equal to 1. The name of the variable is used to the reference value. And print x prints the value of the variable x. In this case, it will be 1. So we see how we can use our own variables. These variables, these user-defined variables, very much limited to the awk script and will not be passed on to the bash. So these are very much local to the awk engine. Okay, so we are done with this particular section. Let's move on to the next section. The awk variable example. Let's see. This is our bash script we are beginning. And we are using built-in variables. FS as a field separator of the input. OFS is the output field separator. So I mentioned that field is the column, right? and whereis is the output record separator. Record is the row. Okay, I just mentioned. So here example I have explicitly written them. So here is the geawk command we are seeing. So here let's slowly look into this. The first part here, let me bring my mouse pointer here. So here within the code, whatever we are written is a inline script for the awk itself, and this entire thing is inside a bash script. Okay, but this particular script is a awk script and it has its own style of writing. So this is a begin block. It defines and initializes the variables, like it's kind of header section. So we write fs is equal to, we know this is what field separator, okay, for the input is colon, okay, and output field separator we just define anything we like to do, we have defined, and here semicolon ends the first command and the next command comes as like within the curly brace. Okay, so here print $1 $7, and here our awk script ends, and then the input file, it is the file everywhere in any Linux system /etc/passwd. So you can just operate on this. Try this example at your side so that you will see what output is coming. This example is tried and tested, so I am not showing any trials on this, so it's a task to you. Try it out. So here we define first the binary, then goes the awk script, and then goes the file on which we are operating, the input file. Okay, so the next line comes here again. So here what we have done, bring my mouse pointer again. Here we have in the header section, that is begin block, we have written what is the input field separator, output field separator, and output record separator. So we know that record separator is the row separator. So what happens, we change it to double new line. We have redefined it, and we have print $1 and $7. So you can try this out at your end and you will see. So you can change the output field separator as you wish, and output record separator too. And we put an exit here just to end the bash script. So guys, here we have seen the first example of the awk script here, and we see the awk has its own script, and which is different from the bash script that we are writing. So you get all the clear idea that initially we are talking about. Okay, so this example is done. Let's move on to the next section. Another example. Starting our bash script, and the script or program is not counted in argc or argv. So here in the geawk program, what we are doing when we are executing this particular bash script, right, we have our command line arguments. So we are printing the values here, argc, how many arguments we have given, and then we are printing the index 0 value, index 1 value of the argv array. So you can try it out at your end and see the results. Okay, and here we just, because we are using the header section only as awk script, that's why we are not giving any further any text file on which we are processing. We are just using the header section here. The next thing is the accessing and printing the environment variables of the shell. So we know that in bash there are several shell variables. We have discussed these things earlier. So here we are in the header block, begin block, we are printing what? pwd, and then we type the environ. Let me bring my mouse pointer here. You can see right here this awk function, right, environ, and then if we say pwd, it will call the system variable of bash, which is $pwd, and home will be the $home. So we have to use, in case we have to call any system variable of bash, we can use this particular environ function of awk. Okay, and this way in this particular example we are printing the pwd and the home of the user. So let's move on to the next one example. Here we are printing the shell. Again, we know in which shell we are operating, so it will be bash definitely. Here we are printing the editor. Editor is basically if you use right vi. So in editor default this will be editor if it is defined. User defined variables and arithmetic. So here we are doing a mathematics here. Okay, in begin block here x equal to 4 and then x equal to x into 2 plus 3 and then the print x. So these are three statements separated by semicolon. This is an awk script. These are three statements separated by semicolon, and we know the header block, so begin. That's why we don't have any text file on which we are operating. Okay, so the begin block we can do without any input file, and we end the bash script with the exit. So here we have discussed that how we are using the variables. Okay, we have printed the user defined variable in the last example, and also we have also printed the system variables. Okay, so altogether we have seen all the examples in this case. This is also tried and tested script, so you can try it at your end. All that you need is a Linux environment. This particular slide is done. Let's move on to the next slide. the awk, fields and record. So far we have touch based the field and records in multiple cases. Let's see them in detail. The GEAWK manipulates the data in the text file, so the input text file. It does this by assigning a variable to each data element in a line. So there are two typos in this line. Please excuse me for that. So it does this by assigning a variable to each data element in a line. Each data field is determined by a field separation character such as a white space. By default, GEAWK assigns the below variables while matching the data fields. 0 represents the entire line of the text. So now when we are considering a text file, when we are doing the matching, $0, if we print it, right, it will return the line of concern on which line the awk is currently operating. Okay. $1 represents the first data field. We are matching fields. The input file has multiple columns and first column is the first field, second column is the second field. Okay. This way $1 will print first column. $2 represents the second data field. This way, $n represents the nth data field. $0 prints the entire line, $1 the first column, $2 the second column, like this, it will go on. The default record separator is a new line. Record separator means the row separator. The below procedure sets fs and rs redefines the record as any number of lines up to a blank line. So here we have just defined it. You can try at your end this example. So fs is equal to \n and rs is equal to just blank. Okay. So let's move on to the next slide. So begin and end block. So far we have seen the begin block. Okay. And we have talked about this header block. So let's see in detail. Okay. So here start the script, printing something. Printing the header of the report. When we are using the begin, right, we define the header of awk script. Okay. So here we have used print hello world, just simple like that. Then printing the footer. After replacing the fourth field and print the substituted line. We first do the echo, my name is Rich, pipe GEAWK. Then we start our script. Okay. $4 equal to diff and print $0. So here, let me bring in my mouse pointer. So this is the line in concern. Okay. So here the $4 will be the fourth one. So 1, 2, 3, 4. So reach, right? Reach is the fourth one. Here we are substituting reach with diff. And then we are printing $0. This means entire line. So what it will print? It will print my name is Dev. And what we're doing here, end, then print task finished. So this will be the last one. This will be the footer block of the code that will get executed. And it will print the task is finished. Okay, so that means the entire script is done. So this is the purpose of the header block, that is begin block, and the footer block, that is end block. Okay, so begin executes at the very beginning of the code, whatever we have to do at the beginning of the code, like initialization, printing a message, anything like that, or printing a header, even we can do that. Okay, so begin is used for that, and end is used for to finish the finishing footer of that code execution. It could be printing something or doing something, some particular operation. So let's see the next one. Combining beginning and end. So in this particular example, we have combined both beginning and end. So here we have used GEAWK, then -f as a colon. So file separator. The begin, then we have used printf, and then process starts here. We have the first header one. Header ends here with the semicolon. Then body of the code starts here, printf %is, then $, has UID, then again %s. There are two %s, and first one will catch $5 and the second one will catch $1. Okay, this is here the code body is done, and then we write the footer, end, print, the task finished. Okay, and we are operating on file etc/buswd. Okay, so here in this particular file, field separator is colon, so we have mentioned the colon here. Try it at your end. So because this particular file is there, all Linux systems. Okay, so you can try it at your end, and this script is also tried and tested, so you can try it at your, that is your task now. And we conclude the bash script with an exit. Okay, we come to the next section here, regular expression usage in awk. Okay, so we know that awk can operate on a particular file and graze through the different columns and rows in that particular text file. But why we are grazing? We have to match something. Okay, there will be multiple columns and we need particular few columns, right? And we have to see whether something is there in the particular that column. So that's why we have to use regular expression for matching text. Okay, so that's why awk contains the regular expression. Previous episode we have discussed, right, that ERE and BRE. Can you recall awk which uses which particular engine? That is a task to you again. So here a pattern that can be anything, okay, contained within the two slashes, the regular expression, relational expression and begin and end. Regular expression use the extended set of meta characters and must be enclosed in slashes. Relational expressions use relational operators. Use bang to negate the match. Okay, so in case we are given an regular expression and precede that with a bang, that means we are negating the expectation. That is to handle the lines not matching with that particular pattern. In addition, the ternary operator. We know there is a ternary operator. So here also the example is given. Okay, ternary operator may be used in a pattern. That is also possible. If it is in case we want to use, there is a ternary operator also. The begin pattern is applied before the first line of the input is read. So that is what I said, right? The begin, whatever inside the begin, it is a header block. It operates even before the processing the first line. The end pattern is applied after the last line of the input is read. So that we already came across. Begin and end pattern must be associated with actions. If multiple begin and end rules are written, they are merged into a single rule before being applied. So there is some additional information on the begin and end block that we have just discussed. This particular slide we are done. So let's move on to the next slide. So let's see what are the regex. C, particular C means matches any literal character. C, that is not a meta character. Meta character is a special character that is used for a special purpose. We'll come to see, and we have seen in the previous episode that what are meta characters. Can you recall? Otherwise, go and see the third episode. Okay. So here backslash escapes the meta character that follows, including itself. Caret anchors the following regular expression to the beginning of the string. So this caret means that the beginning of the line. Okay, the regular expression immediately following by this means it has to match at the beginning of the line. Dollar anchors the preceding regular expression to the end of the string. So dollar is that it means that we are expecting the regular expression to be at the end of the line. Dot matches any single character including new line. Regular expression 1 or regular expression 2. Okay, this could be one regular expression itself. Between two regular expression R1 and R2, it allows either of the regular expression to be matched. In case we are expecting either of them, we can mention in a regular expression 1 pipe regular expression 2. So when we use regular expression within the first bracket, two regular expression, that is used for concatenating regular expression. Star matches the any number including 0 of the regular expression that immediately precedes it. Okay. Plus means one or more occurrences of the preceding regular expression. Question mark matches 0 or 1 occurrence of the preceding regular expression. So star is any number, plus one is one or more number, and question mark is 0 or 1 occurrence. Okay. The regex within first bracket used for grouping regular expressions. Okay. These are groups. And with the rectangular bracket, right, matches any one of the class of the characters enclosed between the brackets. So we'll see the examples later. These are the set of regular expression and the meta characters that we can use in awk. Awk processing a CSV file. So this particular CSV file I have provided for you in the description so that you can download this file for your trials. Okay. So let's move on to the beginning our bash script, right? Matching the capacitors by regular expression. So in this particular CSV file, there are capacitors, resistors, etc. And we are matching the capacitors here. There is a first line, and here let me bring my mouse pointer. So here we can see that the columns are separated by a comma here in this particular input file. CSV means comma separated value. So the separator is a comma, and we are using -f comma just to notify awk that hey, our input field separator, that is comma, scan according to it. So here what we are doing, the $2, right? With $2 we have discussed, right? The second column entry, okay? Tilde equal to, and here what we are doing, small p or capital P, either of them could be there, and small f and capital F. So matches. So capacitor has a unit, right? This is the double quote. So each of the field are there in the quote, okay? So here PF could be small p, small f, small p, capital F, capital P, capital F, capital P, small f. Any of the pattern could be there. PF is a unit of the capacitance, picofarad. So here it will match, and it is matching, okay, the $2, the second one, and here comes up the body of the code, that printf, then we use the format specifier here and $1 and $2. The first column and the second column you are printing, and it will operate on the data.csv. So what it will do, it will match the second entry with this particular regex, and they will be certainly the capacitors, and it will filter out the capacitors and while scanning each and every line inside the data.csv, and only the line which contains, and it will just extract the two columns $1 and $2 and print them. Okay, so try it out. Okay, so we have just a separator here printing the screen separator in the matching the registers by regex. So here we are scanning for the registers. Similar to that, let me bring in my mouse pointer again here. So we are scanning the second column data here, and we are matching with the tilde, and within the lashes we are writing that 0 to 9 and then K. K is the kilo. Okay, so resistance will have kilo ohms. So this could be our match, and this is at the end. Okay, so at the end there is a double quote mark. So here we go, and we'll print out the format specifier and $1 and $2 in this case. In first case we have printed the capacitors, second case we are printing the resistors. So here the second separator comes as a visual separator. This is when we are printing the output in the screen, matching the items that has a URL. So here when we are scanning this particular CSV, right? So here what we are doing, that $4 means the fourth column data. Okay, there whether there is a HTTPS. Okay, so we are putting it inside the lashes, and 4 whether we are checking first that 4 matches with the HTTPS. So lines those are having URL will be processed through this command. So printf, then the format specifier here, and then $1 $4 and operating on data.csv. So this is a task to you. Try this out at your end. This is tried and tested script, so I am not showing any example here. So this comes our next visual separator. Okay, and here we are emulating a wc-l in awk. Okay, we know that line count in a file, right? The number of lines here in awk is that echo, and here we have used the awk, and in the awk code here, let me bring on to my mouse pointer again, and here it is awk, then our awk script is end. At the end of the file processing, it prints nr, so how many records it has processed. Records means the rows means the lines. Okay, so here it will print nr. Okay, at the end it will print. Okay, and data.csv, so it will just give the same as if we do wc-l then followed by data.csv in bash. Okay, so try this out and we conclude our bash script here. We are done with this particular example. Let's move on to the next section. In this particular example, we'll see how we can combine awk and sed together. Okay, so let's begin. We begin our particular bash script here, and then what we are doing here, we are regex matching by awk and regex substitution by sed. Okay, so sed we learned in previous episode. In case you do not recall or want to just have a again brush up, see the third episode. Okay, so what the sed does is that it can substitute. Okay, so let me bring on my mouse pointer again here. So here we are operating on a data.csv. Okay, and here we say to awk that it is the separator, the column separator is comma, fourth column here. Okay, we are operating match with the HTTPS. We use the format specifier, and when this is done, we have done this already, pipe it to sed, and we substitute small https with capital HTTPS. Okay, and the output will, instead of small HTTPS, it will be capital HTTPS. So that's how we can combine awk and sed together. We print a visual separator in our echoing terminal. Okay, and the next example comes. So here what we are doing at the fourth column, right, we are matching HTTPS, then we are printing with then data.csv, then sed what we are doing. So if here what is there, right, we remember that in sed we can use colon as a delimiter. Okay, so we are using colon as a delimiter, and these slashes, if this particular text is found, right, //eu, it will be substituted by //ww. Okay, so this is done with the sed. We are done with this particular example here. Try this out at your end. So this is how you can use awk and sed together to process text file and then substitute something in that particular. Okay, so this is why, because we need some time. Why I give this example, in some time when we process a text file, right, we have to do some cosmetic changes, and for those cosmetic changes we can combine awk and sed together. Awk can generate a report definitely, but for cosmetic changes we can combine sed together, and everything we include in a bash script so that it's all automated. Okay, so guys, we are done with this. I would like to thank you for listening up to this point and completing the entire series.